Howdy, everyone. How are we doing today? Be it, as Jay says, morning, evening, or whatever time it happens to be where you are. Happy present. I like that. Happy present. I can move my camera slightly. Let's see. I will Zeta European time. Let's see. I can slightly adjust my camera so that I'm slightly more centered. Let's see. How about if we go there and we do that? Is that better? Let's see. Let's actually do it the other way. Hey, Jay, how are you? There we go. That's better. Alrighty, so as always, we're going to be starting with the most requested puzzle from the Patreon and YouTube members. Just in case you don't know, you have a few options for ways to support the channel, and if you choose to do that through either Patreon or YouTube membership, then at certain levels you get the option to vote on what puzzles we'll do on the stream. And so I always do the most voted on puzzle from the bucket. And then I will frequently choose other puzzles that people have indicated that they would like to see on there as well. So this is the most voted on puzzle. So we're getting more and more people who are now using the vote button. So currently this with 4 votes is the most. So this puzzle is dedicated to Mind Drive, Luda, Andrew Sarkis, and David Ratner, who all requested this puzzle. Interestingly, and I'll take out of this what you will, this is the second consecutive puzzle voted on by the fans, which has been a grkles puzzle. So I like grkles puzzles, and apparently the fans and the windmills and the turbines also like grkles puzzles, because this is the second consecutive week where we have been doing a grkles puzzle. The last one was Progress. It was great. If you didn't see that one, you can go look in the VOD later, and you can see that. In terms of administrative news, I just wanted to mention that I recently posted, as in a couple days ago, I posted a new puzzle on Logic Masters Germany. It's called MIA. I really encourage you to go check it out. It's not too often that I'm setting a puzzle and I end up feeling like I get legitimately surprised by the logic of the puzzle, but this was definitely a puzzle where the entire logic of the puzzle ended up quite surprising me at a number of points. So I really encourage you to check it out. It's labeled as being 5 stars. It's really quite close between 5 stars and 4 stars, so don't let the 5 stars intimidate you over much. Jay in chat did it already, so actually both Jays in chat did it already that I'm aware of. So anyway, so I encourage you to check it out. And also, I recorded the entire process of me setting the puzzle, which took 3 days and 12 hours or something like that. And I also recorded Tristan solving the puzzle during the test solve, which I often talk about, but we have an actual authentic test solve so you can see what that looks like. That's going to get all sort of put together and put on the channel at some point. It's a lot of footage to sift through, so it might be a bit. But then if you do the puzzle now, then when it drops on the channel, you can enjoy seeing that whole process of how everything got put together. So that's all I have to say, I think, as far as stuff before we jump into this grkles puzzle. I will be announcing the next Zeta setting challenge soon. So either later today or on Thursday, whichever happens to be. Oh, and Tristan has announced that we have a new patron, John Mormon. So welcome, John Mormon, to the Patreon. We greatly appreciate your support. And thank you to all of our supporters on Patreon, YouTube, people who give super chats, whatever way, even those of you who subscribers, those of you who just come and watch some stuff sometimes, we value all of you. It's been really exciting seeing all of this sort of take off. Okay, so with that all out of the way, let's talk about the rules of grkles puzzle. So normal Sudoku rules apply. And highlighted cells of the same color are clones, though interestingly, there are not colors. But I believe I could highlight these and say those are clones. These and say these are clones. And these and say these are clones. The disappointment dragon is slipping Zeta a few bucks. It's possible. Yeah, the rules mention coloring in the rules, but then there's no actual coloring. So, Doomdiot. Doomdiot is our new patron. So welcome, Doomdiot. I will say you by the name that people in chat actually can recognize. Although now that I'm looking at it more closely, I'm now wondering if it's Doom Media. So I think you could spell the word media. Yeah, it's Doom Media T. I kind of feel like I know how I would make a cryptic crossword clue out of this screen name anyway. Yes, thank you, David. David donates $50 and says, "You mean like this in honor of grkles and his popularity." Thank you so much, David. I appreciate that. grkles is popular, and so you donate to me. I like this. I appreciate this greatly. Thank you very much, David. Your support to this stream has been amazing, and we really appreciate it. And I know I speak not just for myself, but for all of the other Sudoku streamers who you also support and sort of make this a very positive community, not just with donations, but also with your commentary, the gratitude you show, the general positive attitude you have. You're great to have around. Alrighty, so grkles tells me I want to delete this coloring because I'm going to want to do more coloring, which, makes me happy to hear. But I wanted to at least explain what this whole clone business means. So clones are, I think, an underused skill, or an underused mechanic. I am part of the problem. I've only put clones in my puzzles, I think, a total of once. But what it means is this cell is exactly the same as these other cells, and that cell is exactly the same as those. These are exactly the same as those. And the same is true for red cells and for blue cells. They all sort of match up. So if we wanted, we could attempt to color... we could give every one of these things a different color, except I don't yet know that they don't repeat anywhere. So I won't do that just yet, although it might end up being the first thing we have to prove, that like one of these is actually different or whatever. Anyway, that's the clone part of the rules. And then I have the Mathrax part of the rules, and I will admit I've only literally once thought about Mathrax at all, which is that during my Christmas puzzle wreath, I wanted to use every clue type I could imagine, and I needed a clue type, sort of for symmetry, I needed a clue type that was sort of a circle on a square, and so I was like, Mathrax is like that, I'll look up what it does. And I could no longer tell you, what this is. Yeah, the complicated bijection between setter names and YouTube names and names on the CTC Discord and all of these sorts of things that we try and keep track of. But yes, no, there is a secret Niverio in chat. So you can attempt to identify which of the mysterious people with green names is Niverio. Yeah, these clones aren't sort of swivel. I think classically clone Alima means no rotation, but then I think a lot of the cooler clone puzzles have some amount of rotation. Like amusingly, my clone puzzle is actually called Windmill and specifically involves rotating the things. There we go. Jay Dyer has outed themselves as Niverio. So now the mystery is solved as to which of the people in chat is Niverio. All right. So what this clue is saying is it's referring to the mathematical operation that you get when you do these. So the divide sign means I'm supposed to divide one of these two by the other. And then when I do that, I get 3. And here, when I divide one of these two by the other, I get 3. Now here it's saying when I subtract one of these from the other, I get question mark. And when I subtract one of these from the other, I get question mark. Now, at first that might seem completely worthless, but what it's actually telling you is that the difference between these two cells is the same as the difference between these two cells. Now, note the rules don't specify this explicitly, but they implicitly tell me that question mark is not the same as that question mark is not the same as that question mark. So the question mark is only for the pairs on the diagonal that it appears on. And then this O indicates that all of these digits are odd. So that's not really a Mathrax clue, I don't think. Unless the binary operation being described is, are both of these odd? And then this is saying yes, in which case I suppose maybe that is that. Alrighty, so this looks like a lot of fun. I have no idea how difficult this will be. I could have looked it up, but I do not know. So we're going to, let's see. grkles says actually O and E are valid Mathrax clues. Who knew? I certainly didn't. I'm going to guess this is a good bet cell, but grkles can tell me if I am wrong. And then we will get started. So the 3 here actually puts a great deal of constraint on these digits already, because they have to be digits that are either divisible by 3 or multiplicable by 3. And by multiplicable by 3, I am excluding digits like 4, because although I could multiply 4 by 3, I would get 12, which is not a legitimate business person for this puzzle. So the numbers that are multiplicable by 3 are 1, 2, and 3. And then the numbers that are divisible by 3 are 3, 6, and 9. So these digits are only from the quintuple 1, 2, 3, 6, 9. And so that's automatically also true here. Now, I should mention, grkles already has sort of alluded to the fact that I'm going to want to either remove the yellow coloring or subcolor these various things. And so I'll definitely look to do that. Now, I would like to know if there can be any repeats between these cells. So in particular, I would love to see any cells I know aren't repeated anywhere. So let's start, just for lack of any better place, let's start with this cell that I'm going to put a black flash in. And let's ask... let's ask if this black flash could repeat anywhere. So it can't be anywhere in blue. It obviously can't repeat in yellow, because yellow is contained to a single box. It's not there or there by this looks at both of them. But unfortunately, the black flash could be here in red. So this could be, I think, black flash, unless I'm supposed to observe that there's a Mathrax reason why it can't be. But certainly not that I see. Now, Nicholas points out that I started in absolutely the wrong place, because actually what I can see is that blue and red can't have any repeats between them, because this blue looks at those reds, and then this blue... and then these two blues look at that red. So red and blue are 5 different digits. So red and blue are entirely different digits. And so that means if there's any digit in red or blue that I can show doesn't repeat in yellow, then I will know it is its own special digit and I can award it its own special color. Unfortunately, I'm not sure I see any such thing. But I do think Nicholas's point is probably one of the first things we're supposed to observe, which is that red and blue have no repeats. So these are a quintuple. David bets 7 on the bet cell. I'm thinking if there anything Sudoku-logically that I can do with the fact that red and blue don't have any repeated digits. Like, could I ask where I have to put the red digits in this box, for example? And I'm afraid the answer is not necessarily immediately. Oh, the blue cells see all of yellow? Ah, yes, that cell sees all of yellow. Great point, Andrew. And then, so this cell at least sees all of yellow. So this cell can get its own color. So this can become green. So green is a digit that does not appear in any of red, yellow, or of course the former blue cell. And then this blue cell sees those two cells there, and that cell from there. So blue now can be promoted to a real color. So green and blue, blue is now a single digit. Green and blue are digits that do not repeat or that do not appear in red or yellow. So when we're playing Sudoku games with blue and green, we can ignore all other places. So green in this box, for example, green is up here, and that's going to let us place a green. So green's in one of these two cells. One of those is green. I don't know which. But that's going to let us place green here. And so we have our first digit in the grid, kind of. Zach will have to wait a little bit to come out. But now that has placed this on an odd clue. So green, everywhere it appears, is odd. So I can do that. I think Zach is going to have to hold off and wait until there is a digit. Although if he gets particularly impatient, I might let him do an intermediate dance if this is going to if this ends up taking a while. Non-trivial cell equivalence dance. Yes, beautifully done. Okay, so can I do anything similar with blue? Like blue over here. Yeah, blue's up here at least. Ah, yes, I can do exactly the same thing with blue. Blue is in one of these two cells. And so then where does blue go over in this box? It can only go here. And so if we're going to get really messy with the coloring already, we can say that one of these two is blue. Which is kind of horrifying, but what are you going to do? Let's see. Now, I did want to point out a point that J40 made a while ago, which is that there's only 1, 3. And so the possible divided by 3 relationships are 1, 3, 3, 9, and 2, 6. And I can't use 1, 3 twice. Or could I use 1, 3 twice? I'm now worried. What if I used 1, 3 twice? Or 3, 9 twice. Or 1, 3. I can't use 1, 3, and 3, 9, can I? I don't think. Yeah, I can't use 1, 3, and 3, 9. But I think I could use 1, 3, 1, 3. Let's see. Jay tells me I can't, in as many words. If I put 1, 3, 1, 3 here, then this would be so Oh, right. It's because they're diagonally. Sorry, it's because it's diagonal. Yes, that's the point. Yes. So if I did what I was wanting to do, which is to just say, oh yeah, let's just pencil mark it like that, that all looks well and good until you realize what this actually means is that. And now these diagonals don't divide to 3 and these diagonals don't divide to 3. So J's original point, why is it not undoing? Please undo. No undoing anymore. There used to be undoing. Okay, there we go. For whatever reason, now it's back. Okay. So the point is that because I can't use 3 twice, I need to use a 2, 6. So somewhere in here, there's a 2, 6. I don't know where. Okay, so and a 3, yes. So green is definitely not 3. That's one consequence. Because green, no matter what it is, sees the 3 that is in this mess. So green is not 3. So that is a non-trivial digit elimination dance. One moment, let me scoot slightly closer to the screen. Everything has become more serious. Let's see. We could have the rainbow penguin. We'd have to have Tristan on camera to get the rainbow penguin to do the color dances, but the rainbow penguin would definitely be up for doing color dances. Let's see. Green is in one of these two. Let's see. So someone said something is placed in something. Row 5, column 6. In row 9. Let's see. In row 9, it's not in any of those places. Oops. It's not in any of those places, and it's not there. Do I know more than that? Did I get the right row 5, column 6? That's not row 9. Let's try again. Let's try again with row 5, column 6, and row 9. So in row 9, row 5, column 6 in row 9. It's not in any of these places. It's not here. It's not there. It's not there. But couldn't it be in red? I think this is the digit that I don't... This is the digit I think could be red. So now, actually, I think we can actually go back, though. I think there might be... No, I don't think there are actually any yellow digits that I know aren't red or vice versa. No problem. I also acknowledge the coloring could be clearer. Okay. Three, 6, 9. Okay, so what else can I do in terms of... So I know one of these, in fact, one of these two is green. Do I want to pencil mark that one of these two is green? Am I at a point in my life where that is a thing I want to do? I don't think I'm yet at a point in my life where that is something I want to do. But I may get to the point in my life where that is something I want to do. And I may get there quickly if the puzzle is not going to cooperate. Let's see. It is being hinted that it is actually worth thinking about this cell. And where it goes in places. So, like, over here, it can only go there. Up here, it can only go there. Let's see, in this box, it's sort of constantly pushed into these spots. But we could think about it in terms of this times clue, maybe. Is thinking about it in this times clue useful? Oh, thank you, John. Yes. By the way, welcome, John. But yes, likes to the stream are very helpful. YouTube likes them, and then other people find the stream, and then other people hang out and have fun. In box 3. Okay, so this digit in box 3. Yeah, so this digit in box 3 is not in any of those places. Why isn't it up here? That's the thing I'm missing. Okay, so this digit... Oh, the question is, where does it go in row 3? Okay, so, okay. Okay, I see now. Okay. Gorgeous. Okay. The question is, where does this digit go in row 3? And so the key thing is, I know this digit isn't here because of the divided by 3 Mathrax clue. If these digits were the same, this Mathrax clue would have to be a 1. So this digit is red. Because in row 3, if I look at where it goes, it is not in any of these places. It's not there, I just argued. It's not blue by previous argument. It's not here because it sees these, and it's not here. So it is in one of these red cells. So this digit actually is in red. However, on Earth, I want to attempt to highlight that. Okay, this digit is both yellow and red. I'm going to highlight that way for now. So this digit, the yellow-red digit, I don't think I yet am willing to argue, or I don't think I'm yet prepared to argue that there aren't other digits that are both in yellow and red, but I may become ready to argue that at some point. But the yellow-red digit I can look at in this box, and it needs to go in one of these 2 cells. I don't especially want to pencil mark that yet. Let's see, but no, I know where it goes in red, don't I? It doesn't go. No, I don't know. I just know it goes in one of these 2. One of these 2 is yellow red. In all instances. Does that do anything interesting Sudoku wise anywhere? It tells me one of these 2 is yellow red. Box 7 is interesting. Let's see. Okay, so all right. It is on... So yeah, one of these. This is Jay's point. One of these is yellow-red, which means that 2 of the red digits, namely these 2 red digits, sum to the same as these 2 digits or something. I wish this clue were more interesting. Like, a plus question mark clue is not really giving me a whole lot of pressure. Yeah, yeah. But remember, so someone's saying it's diagonally, and these 2 digits are, so whichever of these 2 are the digits are the same. So the point is the sum here is even. That's the conclusion, because the yellow-red cell is getting counted twice. So the sum is even. Now, knowing the sum is even tells me diddly squat, but yellow-red does get added to itself. I was thinking yellow-red was getting added to this digit, but that's not actually what's happening because of the mirroring. But it does tell me the other 2 digits have the same parity. So both diagonals here have the same parity, which I did not know before. It does, I guess. Nicholas is completely right. It does mean that red can't be 9, and that red can't be 1. I don't agree that it can't be 6, but it can't be 9 and it can't be 1, because if these two digits, say, were 9 and 9, then I need to also make these sum to 18, and that's not happening. Or if these were both 1, they would need to both add to, these would need to add to 2 as well, and that's not happening. But I don't think there's any reason why these two can't add to 12, say. So now this is down to 2, 3, 6. So that being 2, 3, or 6, does that rule out anything from here? So if this is 3, it eliminates 3 from this cell. So this cell can't be 3 anymore. So it can... It's not the most powerful deduction, but this cell is not the 3. Let's see. And this digit is not, as far as we know, on any other... I guess, actually... Yeah, it is on one of these two Mathrax clues. So... The yellow-red clue is either on a divides Mathrax clue or on a plus question mark Mathrax clue. And it is on this multiplies Mathrax clue, which is interesting as well. I not really appreciated this multiplies Mathrax clue. But there are at least a few digits that I can rule off. So if I put in all the digits... there are some of these that cannot possibly appear here. So, for example, 5 can't appear here because I can only get 5 as a factor of a product in one way in a Sudoku box. And the same is true of 7. So at the very least, these are neither 5 nor 7. I might be able to do better than that. 9, I think, sadly, is okay. 1, I think, is okay. What's wrong with 1? Oh, you're saying this specifically can't be 6. Not in general. I was just looking at things that could actually go on the clue at all. Now, these cells I think we have to pencil mark because we actually know that these cells all see every cell pencil marked with a 2, 3, 6. So these are not 2, 3, or 6. So I think we should pencil mark that in as much as it's a little bit painful to do so. Yeah, so I might be willing to indulge this. If this is 6, then the product here could be 12. No, it could be 6, because this could be 6 and 2 with a 3 and a 4. So I think I'm not quite... But whichever of 2, 3, and 6 is not over here, we can actually say something like, whichever 2, 3, and 6... Oh, no, it could be there, can't it? I think it could be there. grkles was interested in this cell. From these cells, I know there's a 2, 3, and 6 Alima in these 4 cells because of the divided by 3 clue, and these 3 cells, through the medium of the clone, see all 4 cells that have a 2, 3, and 6 corner marked in them, which is super cool. I don't think at all useful, but super cool. So I know 2 of 2, 3, and 6 are in yellow. No, I don't. I know at least 1 of 2, 3, and 6 is in yellow. That's not row 1, 2, 3, column 6. Ah, yeah, the same thing is true of these. So I agree that these can also be pencil marked, because these also see these 2 cells in yellow and these cells in the box. So these are also from not 2, 3, or 6. Okay. These aren't 2, 3, or 6 either, because blue we've established already is not in yellow, and so blue sees these digits and the things in yellow. So this is also not 2, 3, 6. Okay, so I think that this is the correct thing to look at, because now where are the 2, 3, 6s in box 2? The only places for 2, 3, 6s in box 2 now are these. So that's pretty restrictive. Hey, Ranks, welcome. Let's see. J40 is asking, aren't row 5, 6, column 6 placed in box 2? Row 5, 6, column 6 placed in box 2. Well, they're not there. They're not there. So, like, if I look at them individually, I'm not sure. I think I'm missing something. Hey, Yura and Pause and Ranks. We've got a bunch of, as in row 1. Do I know that these 2 cells aren't yellow, red? And do I know that these 2 cells aren't these 2 cells in reversed order? Yes, because of the divided by 3 thing. Because of the divided by 3 thing. Right, okay. Got it. Okay. So where do these 2 digits, aka these 2 digits, where do they go in this box? And the point is the same point as before, which is that this digit can't go there, and it also can't go here because of the divided by 3. That's really clever. So these 2 digits are these 2 digits. And so these are yellow, and one of them is red. But they're both yellow. Now, of course, we already know the yellow-red is down here over here. These 2 are there. Okay, let's see. Jay says we can place the other yellow in box... Oh, Jay has retracted the claim that... Okay, so now some people are, I think, wisely asking, where is this cell in row 3? And I fear the answer is that this cell is not going to go into row 3. Wait, no, this is in row 3. Where does this cell go in row 2? So let's see. Okay, let's see if we can follow along with chat and discover where this cell goes in row 2. So it needs to be in this box. So it's this cell we're talking about. It's not blue, and it's not there. So I think this cell is also yellow-red. I think this cell and this cell are now the same. So these cells can actually get a color, if people agree with me. These can become purple. That and that and that and that. I think all of these are now the same. 2, 3, 4, 5, 6. through that medium of the fact that this digit in row 2 had actually gotten pushed to be there. Okay, so there is a yellow-red cell. But now this cell is now purple. Let's see. And so the purple cell, remember, is one of the cells that's up here. And we know where, actually. So now this cell is purple. And this cell is yellow-red. So it is a 2, 3, or 6. Purple now is placed here. So this is a yellow-red. Got the purple in box 7. We have one more purple to place, which is we have a purple over here. And I think that's all the purples. I believe I have placed 9 purples now. That looks like 9 purples. Okay. So this is red-yellow. Because red-yellow and red-yellow can't be in the same place. And so now that's red-yellow, that's red-yellow. Okay, so red-yellow can now just grow up and get its own color. Red-yellow can become... well, I think it's most poetic if red-yellow becomes orange. Okay, and so now the only question, I guess, is this red digit the same as this yellow digit? Because if this red-yellow... If I know that these two are different, then we actually have legitimate colors now. Annoyingly, I don't think I know yet. So red and yellow are the only colors that could be the same as any other color. Red and yellow could be the same. Okay, so these are both 2, 3, 6. So... Oh, I've not... Did I not place all of my oranges? I did not place all of my oranges. There's an orange, too. I somehow thought I had placed all my oranges. I've now placed all my oranges. Okay, so the total here is now either 4, 6, or 12. So red and purple add up to 4, 6, or 12. And red should be noted. Red is a single digit. I just don't know yet what the digit is. Let's see. Okay, so I might be able to... maybe I don't want to think about that yet. Okay. Are there any interesting places where things have ended up related that I would like to look at? So these cells are unfortunately nothing. But the red, if I look at where does red go in this box, red in this box goes up here. And so where does red go in the central box? Red in the central box. Oh no, red in the central box is in one of those two cells. I still don't know. Oops. Why are we in alphabet mode? No, no, no. Get me out of alphabet mode and then undo all of that nonsense. That is not working. Okay, I don't know why undo is suddenly not working anymore today. It's something to do with the way the alphabet mode is set up. Okay, but I just wanted to do that. Okay, okay, let's see. Okay, I'm going to try and just disable the letter tool for now because it is not working. All right. So, so purple is not 6. Letters were cool while they lasted. Okay, so Chat seems excited for me to examine purple. So let's examine purple. 1, 2, 3, 6, 9. Those have always been the candidates for purple. Okay. Now, I completely agree with Calzone's statement that purple is not 6. Because if purple was 6, well, that's not going to work because orange, remember, orange plus orange is either 4, 6, or 12. But if purple was 6, then that would require orange be 6, and well, that's super not going to work. So purple, not 6. This purple, also not 6. Oh, sorry, that was Alima, sorry. Calzone also said something about the number 6, but it was a different thing about the number 6. Okay, so this not being 6 means this cell's not 2. Okay, so there's a much, much more sophisticated claim that purple is not 9. So if purple was 9, this digit would be 3. But this digit is not red, right? And then this digit would also have to be 3. So if purple was 9, two things happen. Red is 3. But also this digit is 3, and that digit sees red, so that does not work. That's messy, but I will take it. So not 9 either. So this being not 9 doesn't actually tell me much about this cell, I fear. So purple's only 1, 2, or 3 now. I took 9 out of every purple cell, right? Did I not take 9 out of every purple cell? I mean, if one purple cell can't be 9, Tristan, none of the purple cells can be 9. Because the purple cells are just one digit. Oh, I had these selected. Aha, yes, you're right. Good catch. Would never have gotten that. This somehow survived. It's 6 survived when it should not have. I'm wondering how much I should play around with what each of the worlds looks like for these. I admit I don't super want to. Why did I write out this? What was I writing out that this can't be? This can't be. Do I really know that this can't be 5 or 7? Yes, I do know that. That's right. These can't be 5 or 7. That was the point. Good point. Okay, so Alima sees a very smart observation, which is that if green is 1, now because purple is very low, there's actually no way to make the other diagonal work. Because if green was 1 and purple was 3, that would be 4. I can't make this double 2. And if green was 1 and this was 2, that doesn't work either. So green is not 1. That is a very cute observation. Also row 3, column 2. Yep. Thank you, Nicholas. If only I could rule out this being 3, that would be really helpful. Ugh. Nicholas is suggesting I pencil mark all of this. That looks to me like 9 cases to work through. Let's see. Okay, so if orange is 2, and this is 1, then this is a 3. If orange is 2, this isn't 2. If orange is 2 and this is 3, this is 1. If orange is 3, this is 3 and 3, so that's 6. This could be 1 with a 5, or it could be, can't be 3 with a 3, but it could be 2 with a 4. And if orange is 6 and 6, then the only thing this can be is 3 with a 9. Oh, that was unpleasant. Okay. Why does purple have to be 3 if orange is 6? I don't think I said that, did I? If orange was 6, purple is 3. If orange is 6, one of these two is 3. Oh, no. Okay. If orange is 6, purple has to be 3 down here. That's right. Okay. So if orange is 6, it is true. If orange is 6, purple is 3. Because then this has to be 3, 9. We did actually do that in our sort of exhaustion of the cases over there. So yeah, if orange is 6, purple is 3. Okay, but Sayori had more to say. And then what do you put on the -3 clue? Wow, that is... I feel like Chain is underselling that. But I agree, yes. So if orange is 6, purple is 3, and now this number has to be 3 different from 3, but it can't be 6 because there's a 6 in the row, and it can't be 0 because this isn't an S cell puzzle. So orange is actually not 6. It's not the thing I wanted to not be 6, I'm afraid. So this is 2 or 3 as well. Okay, so once orange is not 6, then of course this can't be 9 anymore. Or for that, yeah, 3 and 3 is fine. This can still be. I think all of these are still possible. If 6 is corner marked in box 1. Yes, I do have 6's corner marked over there. So now there definitely is a 6 over here. Oh, by the way, that not being 6 means this isn't 2. Sorry, means this isn't 2. Well, I guess it's not 2 in the corner either. So one of these really is 6. One of these really is 2. This isn't a 2 anymore. So Ranks was just telling me I could clean up the corner marks, which I could. I just hadn't yet. So one of these really is 2. One of these really is 6. Okay, let's see. I can go ahead and write in that red is 1, 3, 4, 5 everywhere just to see if it inspires anything. Red really can't be 5, can it, with this clue? Yeah, there's no way red can be 5 because of the divided by clue. Because 5 is the only way you get a 5 involved. And so if there's a 5 here, I can't get a 5 involved in this product or in this product at all. So these aren't 5. So red is 1, 3, 4. Oh, wait, no, that's right. Sorry, I think Yura is correct. I think red could be 5 if I repeat red. No, it can't be, because if I want to repeat red here, I have to also repeat purple here, and I can't. So, good question, but can't do that. Let's see. Red is restricted in box 7. Red is certainly not going here or here or here. It's not going any of these places, of course. It's not going there, of course. So red is in one of these 2 places in box 7. What about box 9? Ah, the box 9 red is going to tell me which of those is right. Hey, Jovi. The box 9 red... No, I still don't know that red isn't yellow. I would really like to know that red isn't yellow. That would make my life much better. I was going to say red has to go up here, and so that's going to resolve it, but it does not, because I don't know that red isn't yellow yet. Let's see. Yellow goes in one of those 2. Red in box 6 is on the Mathrax. Ah, yes, red in box 6 is on the Mathrax. That's a good point. So one of these is 1, 3, 4. Okay, so that means that I don't think that quite does enough. Ah, 2 is in orange or purple. That is a good point. 2 is orange or purple, and so therefore none of these cells are 2. Yeah, so every cell that sees an orange and a purple is not 2. And in fact, actually, every box has its orange and purple placed. So these aren't 2. I think now this cell can't be 1 if we want to go to really finicky things, because if this was 1, it's now making a product that's a prime, and that's not going to work. Isn't orange 3 because of the O rule? Oh, welcome, Jovi. Thank you for becoming a fan. We greatly appreciate your support, and are always happy to have you around here. Orange isn't on the O, question mark? Now, if the O doesn't have any repeated digits, that's kind of interesting. Because if the O doesn't have any repeated digits, that's like 4 different odd digits on here, which seems unlikely to happen. So if this O has no repeated digits, then these 2 would see all 4 of those odd digits, and there could only be 1 odd digit amongst these 2. Which, remember, we actually know that red and purple have the same parity. So if there are no repeats on the O, then because we know red and purple have the same parity, if there are no repeats on this O, these see 4 different odd numbers. They see the green from back there. They would have to both be even, and they would have to be 2 and 4. Okay, Andrew says red is not 3 because it sees all the cells. Oh, good. Okay, so red sees these and sees orange and purple, so it sees those. And we know, this is a beautiful point, Andrew, that one of these 4 cells is a 3, and red sees all of them. So red, not 3. It's not orange and purple that I know have this. No, it's red and purple. Red and purple have the same parity. That's the point. Red and purple have the same parity. Okay, so that probably has some consequences about these. So now purple can't be 1, because the only way purple was 1 was if red was 3. So purple not 1 anymore. So now orange and purple are a 2-3 pair. And so purple, so there are two possibilities, which are orange is 2-2, which is 4, in which case these are 3 and 1, or orange is 3-3, in which case these are 2 and 4. So that makes none of these cells 3 either. It makes that cell not 3 either. Can remove the 3 pencil marks here. Ooh, thank you, Wisteria. Thank you for becoming a patron. Greatly appreciated. Well, I'm enjoying I'm getting a lot of new members and patrons and whatnot this morning. Thank you, everyone. People do really like grkles puzzles. It's the only conclusion. I don't know if yellow and red are different. Yellow and red are the only colors in this puzzle that I don't know if are different, which evolved in a complicated way, and assuredly makes this more complicated to attempt to view. Doesn't 1 p.m. feel morning-y to you, Tallcat? Let's see. Okay, Sayori says 6 in column 1. So where does the 6 go in column 1? It can't go in any of these places. Could 6 in column 1 go here? Do I know that 6 in column 1 can't go here? Oh, thank you, Wisteria. I'm glad you enjoy the VODs. I know when I view streams, I very often end up viewing VODs, but... Oh, haha, 6 is not odd. Good point, good point. Chat has a beautiful point about 6, which is that 6 is famously not odd. And so 6 actually is up in one of these 2 cells. Good to know. Okay. But yes, thank you very much, Wisteria. I'm glad you're enjoying the stuff. Okay, so the 6 is up here. I should go ahead and fill these in. 1, 3, 5, 7, 9. Except I know they're not 3, because I know none of them are orange or purple. So these are all 1, 5, 7, 9 at the very least. So the whole point of all of that was that yellow can't be 6. So upside down 6. Yes, upside down 6 is odd. Very relevant. Jay has an even fancier point, which is that where is 8 in column 1? It is either here or it's in one of these 2 places. It's in one of those. However, blue sees yellow through the medium of that cell, so this cell always sees an 8, so it's not 8. It's 1, 4, or 9. That is pretty cool. I feel like I'm maybe going to have to force this dot, and I really don't want to. But the fact that there's a 2-3 pair in the box is going to make this harder to make work. If someone in chat goes through all of the options and tells me what the answer is, I might take it. Let's see. Okay, so down here, it is true that these have to quotient E out E in some fashion, but Unfortunately, not knowing anything about these digits makes it hard. I mean, I know the quotient's not 1, but the quotient could be, say, 2 and leave a lot of options. Okay, Tallcat is trying to prove that this can't be 9 to start. So if this is 9, how many prime factors does this have? If this is 9, this has 3 prime factors, which are all 2s and 3s. And so there's no way then to make neither of these 2, 3, just by counting the prime factors. And so I agree this definitely isn't 9. So I think this probably isn't 4 for exactly the same reason. Oh, no, because it could be 4-2, and 4-2 could go with 1-8, because a key feature in the proof I just gave you was that the product had to be more than that. This can't be 6, though, by the same argument, because 6 times 2 or 6 times 3, those are too big. That's only 3 prime factors, and so I would need to put a prime factor in each of these. One of them would have to be a 2, 3, and it can't be. So this is actually automatically 4 or 8. So that is, so if we just keep counting prime factors, we might be in a good spot. So now this can't have 2, 3 factors. So this can't have 2, 3 factors. So the 9 is gone. This has to have at least 3 factors of 2. So this can't be a 1, because then I would not be able to get at least 3 factors of 2. Let's see. Okay, so I guess the combinations that work here are 1, 8, 2, 4. That's one of them. And then we've got something like 3, 4 doesn't actually work. 3, 4 doesn't give me enough 2s. Wait, did I say something wrong? Did I say there were at least 3 factors of 2? I think I eliminated something I wasn't actually allowed to eliminate. Because I only know that there's at least 2 factors of 2. But I do believe it can't be 9, because I can't get 2 factors of 3, no matter how hard I try. So yeah, 8 and 2 doesn't work. Meme Rister is pointing out, and I agree, because then I would need to make it as 4 and 4 or 1 and 16, neither of which would work. Yes, Nicholas points out this can't be 1, because I do need at least 3 prime factors in total, so that can't be 1. The only way that this can be 1 is if this is 8. So I guess one consequence I can say of this is there's always a 4 in here, I think. Oh yeah, can't be 4 for exactly the same reason. If I put a 4 here, I only get 2 prime factors, because that forces this to be a 1. I think one of these two is always 4. Is one of these two always 8? What if neither of these is 8? What if this is 6 and this is 4? Does that work? If this is 6 and this is 4, then this needs to be 4 and 3, and that doesn't work, because then this needs to be 6 and 2, but that doesn't work. And if this is 4 and 2... No, this could be 4 and 2 and 1 and 8. No. Okay, yes. Sorry. If neither of these is 8, then I have to use a 4 and a 6, which means I need to use a factor of 3, which means I need this to be 3. But now this is multiplying to 12, and this can't multiply to 12. It's a little bit annoying, but you can see it. So these aren't 8. is the upshot of this. Let's see. Okay, is one of these always 4? Okay, if neither of these are 4, then this is an 8 and a 1. And that doesn't work. 8 and 1 does not work. Because then this only has 2 prime factors. So one of these two is 4. So none of these are 4 either. Okay. And now this is a quintuple. And so we know what red is. So this is now a 1, 5, 7, 6, 9 quintuple. And so we get a digit. Red is 1. Sorry, red is 4. Ta-da! And that gets us a digit dance from Zach. This is the 4 dance. 4 dance. 4 dance. 4 dance. Woo! Woo! You had to wait a long time for this one, I know, Zach. So you have a lot of energy to get out. 4 dance. 4 dance. Woo! Thank you, Zach. We appreciated that. There are many penguins in chat for you. Okay. So, now, that tells us that purple is 2, which tells us that orange is 3, which tells us this digit is 6, because I need a 3 on this somewhere, and I can only get it here. This can't be a 1, so it had better be a 4, and that had better be an 8. All well and good stuff there. And so now yellow and red are indeed the same. So I can go ahead and get rid of red. Red can become yellow. So yellow equaled red the whole time. This is a 4 by yellow equals red theorem. All right, so now we have some 4s to place. So we can place the last yellow here, I believe. Is that the last yellow? 1, 2, 3. No, there's a yellow over here too. And I didn't actually enter the digit there. Oh, and there's 1 here too. Okay, so when I said we had all the yellows, I was very wrong. There were lots of yellows. If I was smarter, would I have seen that they had to be clones of each, or that they had to have the same sets of digits the whole time, grkles? Was there a way for me to see that immediately? So this quintuple also tells me what this digit is. I don't know what it is, but it tells me what it is. It's not 1, 2, 3, 4, 5, 6, 7. It's an 8. It's an 8, everyone. It's an 8. All right, so there's an 8. There's an 8. So blue isn't 8. Blue isn't 4. So blue is over here. So blue is in one of these cells, and it's not there. So blue is in one of these 2 cells. Let's see. We've got so many digits in all at once that we need to carefully go ahead and update all of our pencil marks and do all of our Sudokuings. Let's see. I do know blue is 1579. Let's see. Green not 5 in box 6, I am being told. Good. If green was 5, then this plus would be 7, and this would need to be a 3, and it can't be. So green not 5. Green is 7 or 9. I'm being told we can place 6 by the 3 slashy thing. Ah, yes, thank you. There's 6 by the 3 slashy thing. No, Try again. There's 6 by the 3 slashy thing. There were 2 options. It took 2 tries, so everyone can be very proud of me. Let's see. Does that 6 play nicely with any of our other 6s? It tells me one of these 2 is a 6 at least. Oops. Yeah, this has been a very fun puzzle. There was only one slightly torturous part in the middle, but I've now forgotten what it was, and now my memory is just replaced by doing a lot of coloring, and, well, that makes me a happy Zeta. So I do know 8 is in one of these cells. Well, thank you for stopping by, Jovi, and thank you for picking up your little badge and your various assorted Zeta emotes that you can show off now. Although YouTube only lets you show them off in the channel of the person you're watching, which I think is a little sad. But have fun at work. Hopefully it is a pleasant day, and I will see you again soon, hopefully. Okay, so green is actually getting forced into only one of these 3 cells in this row. Oh, green's not there, I can at least say. Could green be here? Green could be here if green is 9 and this is a 6. I don't think I know that this isn't a 6. In fact, it seems fairly likely to be a 6, actually. Row 7, column 7 has only one option now. Oh. Why did I not see that? That should have been a very easy thing for me to spot. This is a 5 because it's 3 different from 2. Fun fact. Yeah, the trying to find the hidden green in the row somehow seemed much more appealing than finding that. Unfortunately, this doesn't tell me if blue is 5 or not. Yes, it could have been a -1. That's true. It could have been a -1. Let's see. It's not a 5. Because if this is a 5... Sorry, it's not blue. Because if 5 is blue, this is a 5. And now the sum in this box... Oh, no, it could be, because 1, 7 is an option. I was convinced that you needed a 2, 3, or 4 to make an 8, but it turns out I don't think you need a 2, 3, or 4 to make an 8. Hey, Ken, welcome. We're doing a puzzle that you voted for. Where are 6 and 8 in row 3? So I will highlight every cell that can be 6 or 8 in row 3. So we have a hidden pair. And in particular, it's a very nice hidden pair because that's an 8 and that's a 6. That was a very good spot, Sayori. If 6 got a color, then I would pay attention to it. That's probably true. It's not wrong, we'll say. So that means this isn't a 6. So this is a 6. How long has that been hanging there? That's been there forever, hasn't it? This was a 6. Probably. This isn't an 8 anymore. I can confirm that much at least. 8 in column 1. 8 in column 1. Gorgeous. Okay. Blue's not 8, because look at the pencil marks. Or because it's sitting next to an 8, whatever. So now 8 in column 1 actually only goes here. Great spot, Chris. So now that lets us place 8. Well, I guess it just goes in one of these jujillion places. 8 in column 9 now. Another good spot from Carl. So 8 not here. If you bet 8, I'm sorry. 8 not here. So 8 is here in column 9. Ever creeping forward on the 8s. So 8 in this box is actually quite restricted. I'm sorry, Neil. Do you have message editing? If you have message editing, you might be able to go back and change your bet, and then everyone will be impressed. This is a 1, 5, 7, or 9. Nicholas would like me to look at a clue, which is probably a good idea. If this 4 is with a 9, this 8 would have to be with a 3, and it can't be. If this 4 is with a 7, the 8 would have to be with a 5, which it could. If the 4 was with a 1, the 8 would have to be with an 8 or a 9. Sorry, if the 4 was with a 5, this would have to go with a 7 or a 9, which it could be. If the 4 was with a 1... No, if the 4 is with a 7, then yeah, this would need to be that. Okay, so we at least got an elimination out of that. Also, this can't be 1, because that would make the difference 7. But I think there are legitimately a whole bunch of options. Let's see. Should I pencil mark in these cells? That seems like a good idea. So I need a 1. I've got a 2, 3, 4. I need a 5. I've got a 6. I need a 7. I've got an 8. And I need a 9. This cell certainly can't be 1. If it's 5, these two are 1, 7. If it's 7, these two are 1, 9. If it's 9, these two then have to be 5, 7. A fraction does not imply an integer denominator, Josh. I do not believe. I think these could have common ratio 2/3, for example. So all I know is one of these is there's a virtual black dot here. But as long as there's a virtual black dot here that goes in the correct direction, then we'll be in good shape. So I guess... Wait, is that even right? Because I'm noticing there aren't any black dots that I can put here. How is this ever going to work? I feel like I've confused myself. It's okay. Row 7, column 6 has to be a 9. Nothing else works. Okay. So if this were a 1, this would need to be a 4. That's not going to work. Oh, I did my math wrong. Josh is right. Josh is right. Yep. I think what I said actually wouldn't work. This is not a 5, spoiler, because that's a 5. If this were a 7, this would need to be a 4, and that's not going to work. So this has to be a 9 with a 6. Very good spot. I sadly don't know that blue isn't 9, so this still doesn't resolve the story of blue. But it does resolve that that's not a 9. Okay. I think that means this isn't a 7. Because if this were a 7, the only way that I would make these two add up to 10 is as a 1, 9. So this is a 5. And so now these add to 8. So I need these to be 1, 7 in some order. So this is a 1, 7. This isn't a 5. This digit is probably a 6 now. And probably has been for quite some time, because I don't think this could have been a 6 in any plausible universe for a very long time. let's see, these 2 digits are known, so we're going to learn a lot about the bet cell in just a second. So these are a 1, 2, 3, 4, 5, 6, and a 7. So if you bet 1 or 7, keep holding your breath. You might get there. You're almost there. If not, don't worry. There'll be more puzzles. You can bet more later. These cells, 2, 3, 4, 5, 6, 8, 9 are what these are. These aren't 6. So this is a 6, actually. Yeah, blue can only be 5 or 9 now, because one of these 2 is blue. So I can fill in 5 or 9 in all of these abandoned cells. Sorry, blue, you've really not been part of the puzzle. I apologize. I'm sure grkles will make sure that blue plays a larger role in the next puzzle for you. Let's see. Blue is one of these 2 cells, but annoyingly 5 and 9 can both show up there. Excellent. Okay, so Chris has a beautiful spot, which is that we can actually resolve what blue is, because this 5 here ruled 5 out of here and gave us a 179 triple, making blue 5. So blue is 5, and that means we can uncolor the imposter blues, and we can give these their proper color of blue. Well-deserved, well-deserved. So these aren't 5s anymore. So one of these 2 is a 5, for whatever it's worth. Okay, yeah, we're going to fill in these cells and then look at this clue, because I bet if I fill in these clues and look at that clue, it will be helpful. So I've got a 1, or sorry, I need a 1. I've got a 2, 3, 4, 5, 6, and I need a 7, 8, 9. Okay, if this were a 1, well, that's never going to work in any possible universe. Let's see. If this is 2, 7, well, that's not going to work. So this has to be 2, 9. So green is 9. And this cell is a 7, which means this is a 1, which means the bet cell is a 7. Makes that a 1. This a 7, that a 1. 1, 5, 9. This is a 7. This is a 1. So these aren't 1 anymore. That's not 9 anymore. These are a 5-something pair. Let's see. We've got a 5-1 pair, it looks like. David wins. Congratulations, David, on your correct bet on the bet cell. Good choice. This is a 9 and an 8. You both voted for the puzzle and then got the bet cell right. So that is like the best of all worlds. That means this is really 9. Or sorry, this is really green and this isn't. Important to keep track of those things. Oh, this is green and I never greened it. Are there any other, let's double check. Are there any other like missing colors that play? I don't think there are any other missing colors. Ooh, congratulations, Doomdiat. Although I'm really curious if Doomdiat is the correct pronunciation, or if I'm supposed to be saying something like DU Media something. I'm still unsure. That's a 1. This is known. 1, 2, 3, 4, 5, 6. That's a 7. Let's see. This isn't a 1, so it's a 5 or a 7. So this is the 9 for the row. And so this is a 5 or a 7, but it's not a 5, so it's a 7. This is not a 1 or a 7, so it's a 9. This is not a 7 or a 9, so it's a 1. That's a 7. That's a 1. That's a 5. So that lets us do a 1 and a 5 here. You are no color, and you are blue. So you are also blue. I missed you. You are also blue. I missed you. Okay, quick. Oh, you're green. Wow, I'm doing terrible at colors today. Okay, That's all the blues. Oh, you're green too. And you're green as well. Okay. I think I now have all my colors. But I would not be surprised if I screwed that up somehow. This digit, I know what it is. It's a 7. I really envy Mark and Simon's ability to look at a row for a 1/12 of a second and know what digit is missing from it. Oh, thank you, Andrew, for the super chat. Much appreciated. It's been a very loving day so far. I appreciate all of the donations and members and everything. Thank you very much. Thank you for watching. 5. Let's see. We got a 6 and an 8 to go here, and I don't think I know the order of the 6 and the 8 yet. Although it's probably going to get sorted out by this mess down here. So let's just jump into the mess down here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so these are not 7. That's not 7. Oh, sorry, these aren't 7. These aren't 7. That's not 7. This is 7. I got there eventually. It took a while. This isn't a 1. So this is a 1. So this is a 6. So this is an 8. So I don't think I used this at all. I probably used it earlier. I didn't actually need this to disambiguate this. 8 comes up here. That's a 6, and that is an 8. I will say a big testament to how much I enjoyed that puzzle is that I was expecting the time that popped up to be like 45 minutes, and it was actually twice that. So awesome. Yeah, I'm really happy with that. I enjoyed that one a lot. Tristan has requested that I take a moment before going to break. Oh, probably so Tristan can update all of the various screens so that everyone is appropriately thanked on the screens for the break. Because we want to make sure that we thank everyone who has joined. And so now I've got a bunch of new names to pop up on there. I'm trying to remember, there was some step I found really tricky in the very sort of I guess like a third of the way into the puzzle. Oh, Jovial broke the user script or the script with her underscore. Well, Jovial deserves her underscore. For a long time, I had the email address _@umbc.edu, which I greatly enjoyed. I'm 99.9% sure I no longer have the email address. Although I do think, surprisingly, I checked my undergrad email address and it was still there not that long ago. But yeah, definitely there is a lot that you can learn by watching others, and especially in this chat, there's a lot of very skilled solvers who are much better solvers than I am, but I can read them and then explain what they say, hopefully. Oh yeah, there's some people who have not yet liked the stream. If you have not yet liked the stream, please do so, especially in light of what's about to happen. Which I can preview what's about to happen while I wait for Tristan to tell me I can go on break, which is that we're about to do this, which is a Niverio puzzle that is I'm told is a very puzzle, is my understanding. So when we get back from break, we'll be tackling dynamic construction, which is one of the newer famous hard puzzles. So get your popcorn ready for this next one, because you're gonna get to learn all kinds of things. Let's see, we can preview some of the comments. Let's see, Magnus Joffison says that it's hardest at the beginning. See, Playmaker did it. Says that it's nice, has an intricate solve path. Let's lots of comments. Kodak did it. Yeah, the Cogito did it. Yeah, so we'll get to do this. Oh, but only a Penpa link? I guess I can do it in a Penpa link. That's fine. Oh, but I'm gonna have to figure out how to do this whole resize thing, because there's a resize button, but it doesn't actually do the thing I think that it was claimed it would do. So I'll figure it out. I'll figure it out before I return how to make this look better on the screen, because currently this looks okay. Well, it'll look slightly better if I do that. Oops. Yeah, I'll figure it out. I mean, Tristan will come and do it for me, because Tristan is very committed. Let's see, resize to display size at the top. I don't. Where are you seeing display size? There we go. Okay, so got it. So, like, change that like that. Okay, so it doesn't let you actually, like, drag stuff around. I thought it would let you drag stuff to resize it, but it doesn't. But it will let me do this. There we go. Okay, I think that's as big. I think if I go up one more size, I think it becomes... I swear I went up a size and it got smaller. Okay, there we go. I think that's probably... Oh, that's way off the bottom of my... Sorry. Oh, no, that's not what I wanted to do. There we go. I was able to drag it. There we go. Okay, so I can drag it around like that. Okay. Oh, 40 was fitting perfectly. Well, now, sadly, now I have ruined it, because now I have refit it by doing that. I want it to be as big as possible. Okay, so I'm going to go to break, and then when we come back, we will be doing dynamic construction, which I will have to read the rules to. But it should be a great time. You will notice this puzzle is rated... Where did it go? Oh, I lost the thing. Oh, Tristan says I still am not allowed to go to break. Okay. Can I open? No, I can't. Okay. I'm going to have to also, while I'm on break, pull up a copy of the LMD page so I can read the rules. Because I accidentally clicked out of the LMD page. Yes, I've got to stall for time and talk about how nice I think the font in Penpa is or something while we wait. How generous it was for us to get 3 different given ones. I think the 5 is a little too swoopy. I can talk about that. But the 14 looks very bold. The 14 is very nice. It's not a good live stream unless something goes wrong. Yeah, believe it or not, Neil, my most recent puzzle has 5 given digits, which is just insanely generous. All right, but I'm going to go to break real quick. I'll be back shortly, and then we'll be back with dynamic construction. So see you all very soon. You can share your thoughts on the various fonts of the different Sudoku programs in the meantime. Alrighty, welcome back, everyone. So I'm going to read the rules here on LMD, which I admit I should have read, at some point in my life before attempting this puzzle, but what's the worst that could happen? By the way, this is the third in a series. The previous two dynamic puzzles by Niverio have both appeared on the channel. So Dynamic Duos appeared as a video on the channel, and if you've not seen that video and you enjoy Schadenfreude, you should definitely check out that video. You can see Tristan and I solving dynamic duos and forgetting one of the rules, which, as it would happen, made it much more difficult. Oops, not that one. The tilt. There we go. Okay, sorry. Tristan pointed out that I was too low in the camera frame. So there we go. So now I am less low in the camera frame. So the second one I did on stream, that was Dynamic Dots. And then also Mark from CTC did it. I don't think anyone from CTC ever did Dynamic Duos. But anyway, this is the third one. So we have normal irregular Sudoku rules apply. So this is, again, the rules for this puzzle. Normal irregular Sudoku rules apply. Place the digits 1 through 9 in every row, column, and region. The regions need to be determined. All regions are 9 cells long and orthogonally connected. The outside clues represent one or more of the following constraints. If a clue satisfies more than one constraint, both satisfied constraint types count as used for the next point below. Okay, so these are... Yeah, definitely this is one where you're going to have to click the link to read the rules, because the rules are not all going to be on screen, as you might you might infer by the fact that we... even on my screen, there's still a lot of rule left. So most of these, I think, are going to be very standard, though. So number of cells in the first contiguous string belonging to the first region from that direction. So this is, I think, called a frame clue sometimes. I guess the frame clue is the sum, but anyways, so basically just to draw that out, if I had a region that looked like this, we'll slightly make that more plausible. This would be a valid way to fill that kind of clue, because the 5 is telling me that there's 5. Could leave the rules on screen, but move the puzzle off screen instead. That sounds like a good idea, Josh. So I think I'm going to call this a frame clue as I talk about it through the puzzle. It's just telling you how far you get before you get to the first region boundary, counting in from the edge. By the way, there are not links yet, but there will be links soon. Another, and this one's much, much worse, is the number of regions that show up in the row or column. So if I did this, that. If I somehow filled in these to make regions, then there would be 5 total regions, and so this would be a region count. Oops, I keep clicking the wrong side. And note here, it's not switches, it's the total number of regions. So if yellow did that, this would only be 4 total regions that show up in the column, which is... that's non-standard. The standard way would be to count the number of borders. This is not counting borders, it's counting the number of distinct regions. Okay. So region count. So we have frame clue, region count clue. We have numbered rooms clues. So a numbered rooms clue tells you, and this has nothing to do with the region stuff, it tells you where a particular digit is. So in this case, it would be telling you where the 9 was. So if this was a 7, it would be saying count 1, 2, 3, 4, 5, 6, 7, and place the 9 there. If this were a 5, then you could say have a 3 here, and that would say count 3, 1, 2, 3, and place the 5 there. So numbered rooms clues work very similarly to 159. So if you've played much with 159 puzzles, which I was going to say are a craze right now, but really I think that craze has kind of died down. But there was a long craze where suddenly everything was a 159 puzzle. It's a variation on that. It's a slightly different flavor of indexing. Note, you always count from the side. So I could actually have a 3 here and reference the same 9. Sorry. This isn't a 9. It's from this side, though. So if this were a 4, I would count up 1, 2, 3, 4, and put the 2 there. Okay. Sandwich clues give you the sum in a row between the 1 and the 9. So if I had, say, a 9 here, and then I had a 2 here and a 3 here, ignoring the 2 over here, this would validly make this a sandwich clue, because it would sum the 2 and the 3, which are between the 1 and the 9 in the row. That's how sandwich clues work. Skyscraper clues are always the ones that people like the least. Let's just fill this in with random digits. It doesn't matter at this point. So the way a skyscraper clue works is you start at the side with the clue, and you count how many digits you see, with the rule being that you see a digit if it is higher than every digit that has come before it. So this 4 is seen, the 3 is not, and the 9 is seen, and then nothing behind it is seen. So this is counting, like you're imagining these as being heights of buildings, and you're imagining that high buildings block low buildings. You'll see this as you'll see examples of this where it comes up, but basically the 9 always blocks everything because 9 is the highest digit. And X sums clues. The deductions aren't that difficult if you can keep track of the rules. And I can't even look at the rules without scrolling. So we're going to have fun here trying to remember what the rules are. I'm going to have to flip back to the page. Apologies in advance. All right. And X sums. X sums give you the sum. So first of all, there's always an X in an X sum. So the X is the first digit in that direction. So this would be a 3 for the X sum. And it would tell you how many digits to sum. And so in this case, it would say, hey, sum the first 3 digits in this direction. And so I could do a 2 and a 4. And that would sum to 9. That would be a valid X sum clue. I could also do something like, if I wanted for the 8, I could do a 2 length X sum clue with a 6 here. Again, the first digit always does double duty. It tells you both the length and also contributes to the sum. And because we do a lot of Christoph Seeliger puzzles, you've probably seen X sums if you've seen around these things. But Christoph Seeliger is the one who I think usually is doing X sums. Okay. So I'd say 4 of these are standard and 2 of them are ish. Now, every row and column outside of the grid can contain each type of clue a maximum of once. So when I look at these 4 clues, the 0, the 14, the 9, and the 5, I get a maximum of 1 of each of those 6 things. So once I find a numbered rooms clue among one of these things, then there are no other numbered rooms clues among them that are valid. Okay. And it did say before that if a digit satisfies multiple, then it uses them both for either the row, column, or box. So if this were a numbered rooms clue and a, I don't know, skyscraper clue, say, then this could be neither of those. Okay. Let's see. And additionally, just to continue, there are more rules. If the clue outside, or if the outside clue is a numbered rooms clue, the indexing digit and the index digit have to be in different regions. Okay, numbered room means indexing and index digit are in different regions. If the outside clue is a sandwich, the crusts of the sandwich have to be in different regions, and the filling must be a separate third region, but all filling cells must belong to the same region. If the clue is a skyscraper clue, every seen skyscraper must belong to a different region. And the cell that follows the tallest building, if there is one, must be in a different region from that 9 cell. Oh boy, yeah, I'm definitely going to have to come back and read these about 1,000 times, I fear, as we do this puzzle. And if the outside clue is an X sum, all digits contributing to the X sum must belong to the same region, and the following clue must be in a different region. Okay, so clarification question, since we have the setter here. If something is a valid X sum purely numerically, does that automatically mean all of these chaos construction rules follow? Or does it only count as a valid X sum if it also meets this rule? That is the one thing that is unclear to me. The rules are much clearer in the original Turkish. I cannot interpret it as both as... So if it's numerically correct, so let me just fill in an example. If this is a 2 and a 3, then these two are in the same region automatically, no matter what else is true. That is what you're saying, right, Niverio? Okay, got it. All right. So, that being the rules, let's get started. This is going to be tricky. So the first thing I notice is that there are 6 flavors of clue that we have. And 6 clues in column 1. Uh-oh. Suddenly, there we go. Okay. The Windows News thing popped up and was refusing to go away. In column 1, or column 0, as Niverio calls it in the rules, there are 6 clues. And so these 6 clues have to be one of each type, and none can double count. So let's look at the ones. So the ones can't be X sum. The ones can't be X sum clues because there's a 1 later in the row, and so in order to be an X sum, a 1 has to start with a 1. So the ones can't be X sums. If this 1 was a numbered rooms clue, it would be a 2. Likewise, if this 1 was a numbered rooms clue, it would be a 2. Okay, what are my other options? So the ones are not numbered rooms clues. They're not sandwich clues. Okay, I'm going to write on a sheet of paper in front of me what the clue types are, just so that I remember. I'll find a blank sheet of paper. 1 second. I just want something to point at. Okay, so one of them is region count, which has no chaos implications. One of them is the... Oops. I'm glad I did not hit that button after I'd started the puzzle. The other is... Okay, we have this sort of frame clue. So how far into the region you get. Okay, and then in terms of our standard clue types, just to review, we have numbered rooms. Okay, and I think the only thing for numbered rooms is that the number is in a different region from the index. Okay. The sandwich clue we have is the crust is one region, and then the each fillet or each bread is a different region, right? Numbers outside the grid. Cast. Sorry, I'm looking at the wrong place. Crusts are in different regions, and the filling is in a different region. Crusts are different regions, but the filling is all one region. All one region. Apologies if it is boring to watch me write this out, but I think it will smooth the experience greatly if I'm not constantly flipping back to the LMD page to reread the rules. Skyscraper clues. The rule is every scene skyscraper is in a different region, I believe, if I remember correctly. As is the digit following the tallest building. Yes. Skyscraper and the one following the 9 are in different regions. And finally, X sums. And the X sums one is that the X sum is in one region, and then that region ends after the X sum. Okay. So let's come back here. So while I was thinking about all of that, I actually thought of something different I wanted to look at relative to these, which is that I wanted to think about this 0. Because which of these... I did get a second monitor. I just haven't gotten around to setting up a second monitor so that I could have it open. It's probably a good idea for streaming for some things. It would certainly make having guests much easier to have a dual monitor set up. Okay. But I think this 0, and I think this is very interesting, because I think this 0 can only be a sandwich, which I think is then going to force this 14 to be an X sum. I think that's what's going to happen. Let's go over it carefully. So 0 cannot be a region count. There are not 0 regions. It's not a frame count either. It's not a numbered rooms clue, or as I seem to have written on my pad of paper, a numbered booms clue. It's not a skyscraper clue, and it's not an X sum clue. So this is definitely a sandwich clue. It's telling us the 1 and the 9 in this column are next to each other. But in particular, and I have no idea how I'm supposed to denote this. Oh, I guess I can write it up here, can't I? Can't I write this? This is... I want to write this in super, super small. This is sandwich. I can write this up here in a way that is kind of invisible, but I think is as good as I'm going to get. So this 0 is the sandwich. So now the 14. Now I think the 14 has to be an X sum, which is the interesting part. And the reason I think the 14 has to be an X sum is because 14, famously, is larger than 9. So it can't be the region count. It can't be the frame clue. It can't be a numbered rooms. It can't be a sandwich because there's a sandwich in the row. It can't be a skyscraper. Let's see. I think it actually might make viewing easier if I do that and then readjust. Oops. If I do this and then resize everything. Sorry, I know the size. We spent forever getting the size right before. Let's apply the changes. Let's see how that looks now. I think it probably will make for a better viewing experience if you actually can see my scribbling about what these things are. So I think this is probably going to be good. I think this is probably about the size it has to be in order for us to see it. Okay, so this is an X sum. And so, now that we know it's an X sum, Probably, by the way, these should be in black, not in green, so that they're actually visible to humans, at least kind of. So now we probably know something about how long the x sum is, right? So the x sum is not 1 long. It's not 2 long. Could it be 3 long? Well, no, because if it was 3 long, then it would need this digit to be an 11. So can it be 5 long? Well, no, it can only be 4 long. And so we at least get a digit. And so you may recall you got to see Zach's 4 dance earlier, but Zach gets to do the 4 dance again. So this is Zach's 4 dance for the exciting first digit of the puzzle. The flip was not part of the 4 dance. He was just excited for the puzzle. I have teased that I will talk about the stutter challenge later. I will talk about it after this puzzle, provided that I survive this puzzle. Okay. So that 4 now means the sum of these 2 digits is 9. And it also means all of this is one region. So I want to go ahead and color all of this is one region. And I know there's a region border here. So this is a different region. So we've got that. Okay. So now I want to think about the 9. Yeah, these two sum to 8, but they could be a few things, right? They could be, maybe they can be 2, 6, or they can be 3, 5. I guess this puzzle is crazy enough. I'm going to pencil mark that. So now, what are the types left? Region count. Well, the 9 is not the region count. I'm also pretty sure I can tell you the 9 is not the frame count. Because if the 9 was the frame count, I'm definitely not keeping the edges green because they aren't really visible unless I make them thick like this on stream. So I think the answer check is just not going to work. But they're just not super visible if I don't make them this kind of bold kind. Pencil marks in row 2 have the wrong sum. Oh, because the sum was, sorry. I was saying the sum was 8. The sum's not 8. The sum is 9. So it is 2, 7 or 3, 6 is the things. There we go. Okay. I'm maybe not completely prepared to disprove that this region does do this, but I think it's very unlikely that this is a frame clue. It being a numbered rooms clue would be perfectly fine, and it's not a standard X sum. So, in fact, actually, this is either a weird frame clue, because it would create a region that blocked off the entire rest of the universe, or it's a numbered room clue for the 9, which is useless. And then the 5, I guess, then has many options and is so not very interesting. Okay, so that is worth keeping in mind. Okay, so now the place I know the most is this place. So this one could be a numbered rooms clue. However, it can't be a region count. No, it can't be a numbered rooms clue. That's the point. This can't be a numbered rooms clue because of the Sudoku nonsense. Or sorry, because of the chaos construction nonsense. Wait, no, it could. Sorry, I keep saying this wrong. But this could be a numbered rooms clue. It would just need to be the fact that this is in a different region than that. Okay, but that's fine. Those could be in a different region. They probably are in a different region. So the 1, it can't, however, be Oh, it could be a frame clue, so it could be a 2 or more and be a frame clue. Well, it couldn't be a 2 and be a frame clue because then it would also be a numbered rooms clue. Sorry, this is going to take a little bit to wrap my brain around. This is Dynamic Construction by Niverio. So in this particular case, this can't be a 2, but it could be a frame clue if it's bigger than 2. It could be a numbered rooms if this is in a different region. You could never have a 1 sandwich. It could be a 1 skyscraper if this was a 9. And it can't be a 1x sum in this instance. All right. This 8 is maybe interesting. Nicholas, the 0 in column 1 is a sandwich clue. It is already marked. I know the letters are little, but it is labeled as being a sandwich clue. What is this 8? This 8 already can't be lots of things. So I think this 8 might be forced. There can't be 8 regions. It can't be a frame clue. So both of those are gone. It could be a numbered rooms clue. It can't be a sandwich clue because the 9 is at least here and these sum to 9 already. There's no way we see 8 skyscrapers because we see neither the 1 nor the 4. And how would I make an 8x sum? 3, 1, 4 I certainly can't do. 2, 6 I also can't do. So yes, this is a numbered rooms clue. That is the punchline here. So the only thing this can be is a numbered rooms clue. I have to remember that in number. I have to remember that in order to write text, I have to switch to number mode. Okay, so this is a numbered rooms clue. And numbered rooms is the only thing it is, because it's the only thing it can be. And so what is the number of the room in which the 8 lives? It is going to be 2, 3, 4, or 5. I don't know if any of those are going to be immediately discounted by anything. But certainly 2, 3, 4, or 5 are the options sort of naively. It can't be a 1. Oh, I guess. It can't be a 4 because there's a 4 up at the top. How about that? I was going to say it can't be a 1 because it would put an 8 on top of it, but also it can't be a 1 because there's a 1 in the column. So 2, 3, and 5. Those are the options for where the 8 can go. So that's pretty interesting, and I do know there's a region boundary between those at the very least. Let's see. Okay. I still feel I probably have to describe what these are. I don't know. I don't yet know, I feel like, much about all of this. So I think a good point to go to is Nicholas's point, which is about where do 1 and 9 go in this column? Because the 1 and 9 are a sandwich. And remember, the 2 breads of the sandwich are in different regions. So the 1 and 9 can't go here. And the 1 and 9 are next to each other because this is a 0. So the 1 and 9 can't go here because that would create an isolated region over here. So actually, the first place in the column where I could even plausibly have a 1 and a 9 is here. Actually, even that's not true, is it? I can't have a 1 and a 9 there. Because if I had a 1 and a 9 here... Oh, no, I could have a... No, I can't. I don't think I can actually have a 1 and a 9 here. Hey, Jessica, welcome. We're doing dynamic construction for reasons I can't fully describe, but we're doing it. It's happening. So yeah, if this is a region boundary, I can't create any new regions in here, and I can't also I can't fill it all with green unless I create the region boundary here and make this not green, in which case this is a 1-cell region. So this, though, I could make my 1-9, and so I could have my 1-9 in this column be here. So I guess the question is, where is the 1 in the column? The 1 in the column can only be in one of these places. But we can do better than that, because I can't put a 1 here. Because if I put a 1 here, I would be saying that this is a valid numbered rooms clue. Because, Garion, one of the rules is that the two breads of a sandwich are in different regions. Which I fully appreciate cannot be put on screen, but the two breads are in different regions, so there's a border between them. If this was a 1, it would be a valid numbered rooms clue, which would mean the index and the indexed cell would have to be in different regions, which would mean this would have to be in 2 regions, which it definitely can't be. So one of these two is a 1 in the column. And that means that one of these two if this is green, then isn't green 10 cells? Oh, no, sorry, you're right. I can't count. Sorry, in my mind, this green was 5 cells long, and I was creating a 10-cell region if I did that, but I'm not. I'm creating a region that is very fillable. So actually, this can be 1-9 because it's not. Even actually, this can be 1-9 now. Oh no, this was much better when this was when this was 5 long in my head than when it's 4 long. Because actually now I can go back as far as this. Without creating any problems. So yeah, I can put the 1 almost anywhere in this column. Very regrettable. So yeah, I think that was not actually a... I think, unfortunately, that did not work out. Okay, none of these are allowed to be numbered rooms clues anymore, so this can't be a valid numbered rooms clue. I know that. Yeah, I'm not claiming this can be a 1. This can't be a 1. So yeah, these two can't be 1s. But I think starting here, you can make this a 1 without it being a disaster. So this 1 clue has to be something. What is it? It's not a numbered rooms clue. It can't be a sandwich clue. It could only be a skyscraper if this is a 9. If this is the 1 and that's the 9, the 1 just keeps going out that way. Oh, I rewound. I deleted the 4, but then I rewound too much. This can't be a numbered rooms clue because there's a numbered rooms clue amongst these, and I'm not allowed to repeat types along edges. Uh, so I have to do Sudoku with the clue types. And so there's already a clue that has to be a numbered rooms clue, so this can't be a numbered rooms clue. So it's either a frame clue. I think we can probably rule out that, yeah, it can't be a region count because of the sandwich clue in the column. In principle, the 8 could be a double clue. However, in practice, the 8 can't be a double clue because there's nothing else it could be. Oh, right. This can't be a 9. Right. Okay, that's a good point because so Sayori has a very good point, which is that I was looking at what this 1 could be. And this 1 does not have a whole lot of options. So it's not a region count. It's not allowed to be a numbered rooms. It could never be a sandwich. It can't be a skyscraper. That's the thing I missed, because if this were 9, this would have to be 1. And it can't be an X sum because that would require a 1. So this is a frame clue. The only thing this 1 can be is a frame clue, which creates this border. Okay. Good point, Sayori. That was great. This is frame. Which means now when I go to do this, this is at least going to go to here. Continue along the edge. This is going to be a new or old region. I don't know which. This might be green, for example. 1, 2, 3, 4, 5. Yeah, this could just barely be green, maybe, possibly. I mean, so far, I mean, not that we've gotten a lot, but we've gotten a good bit so far. It hasn't been, we haven't done anything monstrous so far. Okay, so neither of these are allowed to be frame clues. Oh yeah, if this were green, it would definitely isolate this. So this is a new color. So we can make this yellow, just recreationally. Because green would isolate something if this were green. Good catch to Eric there. Okay, so these 2s, they can be a bunch of things. I don't think the 2s are interesting, unfortunately. I don't think I know that green has to enter column 1 at all, unfortunately. But if green doesn't enter column 1, then the 1 and the 9 are quite pinned. Garion asks a good question, which is, where is the X sum clue over here? Because there has to be one. The 1s aren't allowed to be X sum clues in this puzzle. The 4 could, I mean, 4 is just never an X sums clue. So one of these is an X sums clue. Do I know which is an X sums clue? Unfortunately, again, this being 4 long and not 5 long is making my day worse, because if this were 5 long, it would immediately rule out the possibility that this is the X sums clue. Let's see. Okay. I'm going to pencil mark 1 in the corner of this, and we're going to pencil mark these because it is restricted. It's not super restricted. So none of these can be 1. Oops. Oops. I didn't mean to add 7. I meant to take away 1. That can't be 1. That can't be 1. That can't be 1. That can't be 1. Now, this definitely can't be 1 because if it's 1, that's a 9. That's not going to work. But I think once we start here, if this is a 1, I could have a 9 behind it, and that would be okay. So I think any of these 4 can be 1s, I believe. So I think it's limited. It's more limited than it looks, but I don't think it's very limited where the 1 can go. Now, if the 4 or the 5 or the 5, if any of these is the checksums clue, it's got to be a 2. What could this one be? Maybe I should ask about that. Do I have any idea what this one could be? It could certainly be a numbered rooms clue. It could be a frame clue. Can't be a sandwich. I guess it even could be a skyscraper, annoyingly. Never mind. I don't think this is interesting. So if either 5 is an checksum, Garion is pointing out, this is really cool. If either 5 is an checksum, it's a 2-3, which then makes... So if this is 5 is an checksum, it creates a 2-3 pair, which makes this a 5. Which would then also put an 8 there. If this is a 2-3, then I do get a 2-3 pair here, but I don't know that it does anything. There's something going on here with the fact that this kind of wants to be a numbered rooms clue with a 2 and a 5, but it can't be. So interestingly, if this cell is a 2, this cell can't be a 3. So if this cell's a 2, this cell's a 5. For whatever that's worth. This 14, maybe it's worth saying, is either an checksum or a sandwich. If this is the 1 or 9, it's definitely... maybe that's the point. If this is a 1 or a 9, the 14 has to be a sandwich. And that's seeming really hard to me, because now this is a region, this is a different region, maybe that. Is that creating a problem? Because the crusts, remember, of the sandwich have to be in different regions from the filling. So if this were a 1 or a 9, I'd have to have a region boundary here, because there would be a sandwich going up or down, maybe one there or one there, but also one there. I think that could just barely work. let's see. What other clues have I not looked at well? Okay, so this 9, I guess it's got... So now the 9 for sure can't be a frame clue, because there's 3 different regions in here. We can't do that. So the 9's not a frame clue anymore. We no longer have to consider that. It's definitely not a region count. It could be numbered rooms. It can't be sandwich or exum because we've already got them. And it could be skyscraper, maybe. Okay, so the only things this 9 can be are skyscraper and numbered rooms. Now, the skyscraper clue would be ridiculous, but also very lovely. Because Niverio has repeatedly said this puzzle opens up a lot once you get through the break-in, so I'm guessing this is a skyscraper clue is what's going to happen. So that would make this go 1, 2, 3, 4, 5, 6, 7, 8, 9. Is there a reason why that can't happen? Or I would honestly like you more if you could tell me why this can't be an X, or why this can't be a numbered rooms clue. That would be even better. But I'm going to bet on this column being the digits 1 through 9 straight down for the moment. If I have to bet on what I think is likely to happen here. Let's see. So, Tristan has solved it, it sounds like. Though, have I gone over what this 1 can be? I think the frame clue is most likely. But let's see, it could be frame... Oh, well, congratulations, Kodak. Yes, in a skyscraper... Oh, right, sorry, Alima is right. It can't possibly be a skyscraper, because in a skyscraper, every skyscraper is in a different region. So this is a stupid numbered rooms clue. So, because it's not possible that all 9 regions show up in column 3. So, so then this has to be numbered rooms, because it can't be the region count. Sorry, because if... because the rule for skyscrapers is every scene skyscraper has to be in a different region. And so if I saw 9 skyscrapers, that would put a region boundary between every pair of these, and that is not going to work, I'm assuming. Is it possible that actually that could happen? Do I need to prove that that can't happen? Okay, Niverio is not telling me I need to argue carefully that I can't actually put 9 different regions in column 3, so I'm just going to go forward with it and believe that I can't put 9 regions in column 3, because that seems very unpleasant. So this is a numbered rooms clue placing a 9 somewhere. Yes, numbered rooms are pretty pretty painful in this particular puzzle. It's like every other clue type is quite interesting in terms of what it says, but numbered rooms clues are not. So this 5, what can it be? Unfortunately, lots of things. I think the 5 could still be a region count. or a frame. Can't be numbered rooms. Can't be sandwich. Could be skyscraper. Can't be X sums. Let's see. Okay, so this is lots of things. I don't want to corner, or I don't want to center mark this. Nicholas notes there is some interaction between the 9 that I place here and the 1, 9 that have to go touching each other in column 1. But I don't think... ooh, that's awesome for codec. I want to have lunch with Mark and Simon. That sounds fun. Okay. Are there any places that I can't place a 9 for sure here? I definitely can't place 1 here. I could place a 9 here, I believe. I think I could place a 9 in any of these places. I think I could place a 9 in front of the 14. Is placing a 9 in front of the 5 broken for some reason? I don't think so. I don't think it's like I can't place a 9 in one of these automatically, at least that I can see. There's probably some combination that I am missing. And now the problem with this 9 is that this 9 definitely could be a frame clue. Like, I could easily have blue running the entire bottom row. Okay, I can write in the possibilities here. This is not a 9 or a 4 or a 1. That might be it. As far as what I can actually say about 9s. I don't think I am going to get there with thinking about 9s in these 2 columns yet. I like the thought, but I don't think it's going to quite work. Okay, so Jay is telling me this can't be a frame clue, which would be exciting. Okay, this can't be a frame clue because it would break row 9, column 0. The sandwich one? No, the 5. The 5. Okay, so if this is one region. Okay, so here's Jay's point. If this is one region, what on earth is this 5? And every clue type involves putting more than one region in a row. So the 9 can't be a frame clue. That's very smart of an observation, Jay. So this is not a frame clue. It's not a region count. It probably is a stupid numbered rooms clue. Could be a sandwich. Certainly it's not a skyscraper because that would require putting a 1 a place you can't put a 1. And it could maybe get away with being an X sum. So I think this can only be a numbered rooms or numbered rooms and X sums or a sandwich. Oh boy. Yes, they will to Codec's great sorrow. They will be known as stupid numbered rooms clues from now until the end of time. Alrighty. I mean, I guess I could try doing Sudoku on ones, because there are... So, there are lots of places I can't put ones. Ah, okay. Garian says look at the row 8 clue. So the one... Okay, so what is this one clue? So it could be a frame clue. It can't be region count, because that would cause the same problem that Jay just identified. If it were a numbered rooms clue, it would be a 4. I don't see why it can't be a numbered rooms clue with this being a 4. It's definitely not a sandwich. It could be a skyscraper if this is a 9 and this is a 1, I think. Okay, so this can be the numbered rooms clue. Garian says. Skyscraper would isolate yellow. Oh, right. Skyscraper would isolate yellow because this and this would be in a different region, and this would be in a different region. Right. Okay. So it can't be skyscraper. I at least appreciate that. But yeah, this is either the numbered rooms or the frame clue. Very, very good visualization there. There's actually some interesting stuff going on with the fact that this is a 2, 3, or 5 is really mucking with my ability to make a 5 sandwich in this row. It's not making it impossible, but it's putting pressure on it. Like the exact combination of digits 2, 3, and 5 is sort of sus in terms of this column. These I know sum to 9. And here I'm not worrying about duplicating. None of these can duplicate at all. I'm placing a 9 somewhere in this column. It's not down there. Can row 8, column 1 be a 9? So if this is a 9, then I need to put the 1 there, and then we create the same problem. So this is never a 9. I agree this is never a 9. So we're in this weird universe where either this is a 4 or there's a border there. I thought we'd started at the top left. You're saying we have not milked everything out of the top left that we can yet? Okay, so Garian and Carl are trying to investigate what happens if this is a 1. So if this is a 1, so let's just put this in. If this is a 1, this is a 9, because I can't put the 9 down there for reasons that we have argued. And so now the claim is that this row is unfillable. Let's see, I'm not quite sure I see what breaks in this instance. I don't think I can visualize far enough ahead, even with writing it in the grid, to rule out there being a 1 here. Okay, so Niverio's hint suggests to me I'm supposed to ask what this 1 could possibly be. So it can't be region count. It could definitely be frame, I believe. It can't be numbered rooms. Okay, so let's write this out. Okay, so it can be frame. It can't be numbered rooms because if it was numbered rooms, then it would also be frame, and it can't be both. So it can't be numbered rooms. It can't be sandwich because you can't have a 1 sandwich. If it were a skyscraper clue, it would put a 9 right here. Right, you can't do that because by the skyscraper clue, there would be a border after the 9, and then that would make this also a frame clue, which will not work. And it can't be an X sum because that would also make it also the thing. So actually, Niverio's hint is wise. This is a frame clue. So there is some sort of region here. And so whatever that region is, I think I'm going to uncolor this yellow cell. I'm going to leave the border, of course, but I don't know. I don't know what it is. I don't know if this is going to be yellow or not. But the point is that now that region has to get out all the way to here at least. And so we can fill in edges over here. That is the conclusion that we have so far. And may or may not escape all the way down to here. I don't know yet. Right. And now the column 1 sandwich is not able to start in either of these places anymore. Because remember, the crusts of the sandwich have to be in different regions. So now, if I believe my pencil marks, the 1 only goes in one of these places. And so the 9 can only go in one of these places. And we've already said this one isn't a 9. So I think we actually get a 9 here. I think this is the only place the 9 can go. Because the 9 has to be next to a 1. And I think the 9 either goes here, because it can't go here. We already argued this isn't a 1, because if this is a 1, it's in an it's in a region of size 1. So we have a second digit. And there's either a border here or a border here. I don't know which one yet. Right. And then this now, if we go back to here, Garion points out, we went over all the possibilities for this before. So frame was one of the possibilities. It can't be a region count. Could be a numbered rooms. It can't be a sandwich. It can't be a skyscraper. And it can't be an X sum. And so as a result, this now is a numbered rooms clue, which means it is a 4. Can see Niverio, the constructor, trying to get this stupid numbered rooms clue out of the way as quickly as possible. So this is numbered rooms. So this is a 4. Interestingly, this being a four... No, never mind. Don't listen to me. Oh, and I know these two are in the same region. That's another consequence of this. This can't be a frame clue. Because if this were a border, this would be a frame clue, and it can't be because I already have a frame clue. So this is going over to here, which means that blue is going over to here now, which now means that this can't be an X sum anymore. So let's look closely at what this can actually be now, because this now, since it can't be an X sum, because then I'd need to be summing at least 3 cells. So now this could be region count or frame count, but it can't be numbered rooms. I guess it could be skyscraper. I don't know. I don't think this is actually that interesting. All I know is that it's not an X sum anymore. Okay, so now Sayori thinks we now actually have narrowed down where the X sums can go to only here, because this is definitely not the X sums because it starts with a 9. And it's not possible to make a 4 the X sum. Right, okay. That's why we were interested in this, because it was one of the only places an X sum could go. And now an X sum can't go there, and simultaneously an X sum can't go here. So this is the X sum. And so if this is an X sum, that's not a 1, which means this is a 1. Now this has got to be a 3, because it can't be a 4 and it can't be a 2. So these two cells need to sum to 11. So they could be 2, 9. Oh, and in particular, these are also both red. These are red, and this is not red. By the X sum, who's a what's it? So these could be 2, 9. They can't be 3, 8. They could be 4, 7. And they could be 5, 6, I believe. In particular, this can't be an 8, because this is the 5th spot. So this is not a 5. So this is now a 2 or a 3. That actually gives us our virtual 2, 3 pair now in the column, which means this isn't a 2, so this isn't a 9. These two I know are in the same region. So I think that means this region's not red, because that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. This is now a different region. So this can go back to being yellow, because it would need to be 10 cells if it were red. Also, people are pointing out the much easier... There is a sandwich in column 1 that needs to have a border between the 1 and the 9. Also, this isn't a 4, so this isn't a 7. Thank you, Carl. Just by the fact that there's a 4 in the column, as it would happen. One of these two is an 8. I might as well corner mark. Well, let's see. What are our clue types we have left? We have a skyscraper clue type left. We have a number of different regions clue type left. And we still have a sandwich clue type left. This can't be a sandwich anymore. So now one of these... Oh, that can't be a sandwich either. So this is a sandwich. This is the only place in the column that can be a sandwich. And so these are a skyscraper. Oh, and that one's not the skyscraper. So this is a skyscraper. And so this is the number of regions. So we've got that all filled in now. 4 can't be the sandwich because I would need to go 1, 4, 9, and there's a 4 in this column already. So that given 4 up here was doing a lot of work in terms of that who's a what's it. So this can't be an 8 because if this were an 8, the skyscraper would break. So this is the 8. So that's a 2 because it's the numbered rooms glue for the 8. So these are not 2 or 7. They are 3 and 6. So this isn't 6 and that's not 5. These are from 5, 7, 9. That one's not 9. This also is not 9. If this is 7... Wait. Oh, yeah. There has to be a border here because remember the way that skyscrapers work is there's always a border between the scene There's always a border between the scene skyscrapers. So the 1 means this is definitely going to be seen, which then means that this is yellow. And means that this isn't yellow. Someone in chat was excited about the fact that this 5-7 pair meant that's a 9, and so that's a 2. So that means there's an edge here because I can't have... Red already has a 9, so this can't be red. So this is not red or yellow. It's certainly not blue, so it has to get out. So this is a whole new region, which is going to be purple. Purple is going to come over here. That's going to make an edge here. Tristan's completely right that yellow has to get out, which then makes blue have to get out. So we can do a little bit more edging into the grid. And yellow can't take the 1. Thank you, Jay. That was a very good point. So now yellow has to get out this way. And so this is not yellow, so it's purple. Now purple still has to get out, so we get that, and both purple and yellow have to get out. Purple and yellow. This is probably blue, but I don't think I know it. I don't think I know what yet. I think red now has to get out. If I count, red's only at 1, 2, 3, 4, 5, 6 cells. It could grab a 7th, but it needs more than that, so this is red. Creates an edge there. Now we're under an enormous amount of pressure on this number of regions clue. Because we need to get 5 regions in this row, and so far we've only gotten 1, and we've taken up 4 cells. So that is great. Chat very helpfully somehow has found that there's a 2 here because I can't put a 2 anywhere else in this column because red already has a 2. So this is green. Thank you, chat. So we can do that around there. We can do that around there. Let's see. Nicholas would like me to remove the 2 candidate from this cell. In fact, I can remove some more because it also can't be that number. That's a 6. Because this is placing a 9, so I can't play. It can't be a 6. I think it could be most of the rest of these things. If it turns out to be green, it's going to rule out a lot. Right, yellow currently is still trapped, so yellow needs to get out another cell. Right, I know this cell isn't red. Oh, right, there just is a 2 there, so it's certainly not 5. Because I cannot put the 9 on top of the 2 in this puzzle. Making this a 3 is tight, but it's possible. The 5 is a sandwich, which is interesting. Because the 5 is a sandwich. It's going to have to be a single 5 whenever I get there. The 2 clue in column 3 can't be a numbered room clue. Right, this is not a numbered room clue, so it's not a 5. But it could never be a 5 because the 5 is between the 1 and the 9 in this row. Can't be a 7 for the row 7 skyscraper. Right, okay. That is a really nice spot, yeah. So yeah, if this is a 7, then I would need to see 8 and 9. Wait, why couldn't I see 8 and 9 later in the row? I feel like this could be a 7 if I saw the 8 and the 9 later in the row. We mean row 1, column 3. Row 1, column 3 can't be a 7. Oh, yes. If this were a 7, that would be a 9, and that would definitely break the skyscraper. Agree. Let's see. Jaleb claims this has to be a skyscraper clue. No, sorry. This, column 3, row 10. This one, sorry. This one. Jaleb claims has to be a skyscraper clue. Let's go through the options. So it's not a frame or a numbered room. It's not a region count. It's not a frame. Oh, I already said it's not a frame. It's not a numbered room. If this were a sandwich, it would require a 2 between a 1 and a 9, and it can't have it because neither of these things can be 9, so it's not a sandwich. There's no such thing as a 2x sum. And so, indeed, this is a skyscraper. Very good spot. So, the 2 is indeed a skyscraper. Let's see. Does that tell us? I mean, it certainly makes it. No, it means this can't be an 8. So this can't be an 8. So because if this were an 8, it would put a 9 there, and then this would need to be in a different region, and it's not. So this is a 3, which means that's a 9. So it's not red, the 9, because the 9 is here. The 3 is not green either, because there's already a green 3. So this is surely some new region. Yeah, nothing we have can get there currently, so this is a new region. It can be orange. I know there's a region boundary between these, but I don't know where exactly. That's not told. Red does need to get out. Yes, Sayori. I actually remembered it. Somehow I actually remembered it. I'm sure chat would have gotten there if I hadn't, but I actually remembered that piece somehow. So red gets out. Red can't go there. 1, 2, 3, 4, 5, 6, 7, 8. Okay, red only gets one more cell. Right. There's one above the... So I remembered the rule all the way up until I actually placed the 9. That's how long I remembered the rule. And then once I placed the 9 using that rule, then I did not remember it anymore. So this is a 9. Okay, so... This 2 is very far away. Let's see. Rick Ward, welcome, by the way, Rick, says 1 placed in column 3, row 4. I'm not sure I see how. As of yet. So I do see that this cell has to be a 7 or an 8. Just for the skyscraper clue. So the 1 in the column we're saying is placed, so it's not there or there or there. It's not there. It's not there or there or there. It's not there. Oh yeah, sure. Hidden single in the column. Very nice. We have a hidden 1 in the column. It can only go there. I mean, this 9 is probably green, but who knows? I don't make any claims that I know yet. I am keeping in mind that pretty soon, once I get, like, if I got one more purple cell, I would know every single cell in this row is in a different region. I'd get just boundaries all over the place. I'm looking backwards because I haven't really looked a whole lot at these clues. I'm trying to see if any of them I learn anything exciting about. Like, this one can't be a sandwich clue anymore, for example. That doesn't seem that useful, but let's see. Yeah, the can't be a sandwich. It could barely be a region count. In fact, it being a region count would make a lot of sense, actually. Yeah, I think it's probably a region count, but it could be the other thing. Okay, are there any things I have to avoid? Why can't red turn up one, Garion? Because this 9 could be green, I believe. Then green would be broken. Oh, right, because green, right, because then green can't get out here, because there's a border here, right. So red can't go up, because if red comes up, then this has no choice but to be green, but then green can't finish. Okay, very good, very well spotted. So red actually goes right and finishes. Cool observation. Region dense. Region dense. Region dense. Region dense. Woo! Okay, so one of these two is a 4. In terms of things that can do. I see Nicholas also saw that I got the worthless 4 pencil mark. Let's see. I am going to now corner mark the rest of this column because you all can't stop me. Hey, Andrew, welcome. 1, 2, 3, 4, 5, 6, 7, 8. It's absolutely nothing, doesn't it? Let's see. Yeah, I sure think it does do nothing. Let's see. This can only be a 7 if this is an 8. So none of these are 8, which I guess, whatever. Right. The 5, Garion points out, the 5 in row 9 is part of the 5 sandwich, so it's not there. So one of these is a 5. So I love the reference to old Tempest era Magic cards. I am here for this. So these are 4, 6, 7, 8. So purple, I believe, can get one more cell here. It can't take more than one cell in this row. So is the point that purple's always going to end up taking this cell? Because purple doesn't have any more options? Right. A frame clue, Andrew, counts the number of cells before you get to your first boundary. So this is a frame clue of 1 because it's 1 red cell and then no more. If there were a frame clue here, it would be a 4, counting these 4 cells. And to the cell to the left of it. Yeah. So here's the point, and this is very well spotted, 57 Thorns. Purple can take this cell. I do not know that it can't. But because of the 5 regions, purple can't take this cell. And so that means that purple, in order to get to 9 cells, is always going to have to take all 3 of these cells. I think all 3 of these are going to end up being purpled. Oh, and purple's not allowed to be a frame clue. Right. That is an even better way to phrase this. That is much better than the way we did it. Is that purple can't be a valid frame clue, so purple can't come here because again, that's the most cells purple could take. Okay, so we got all of these without actually knowing that, but then so 57 Thorns came up with a really hard way to see it, but then came up with a much easier way to see it, which is great. So we've got purple doing this sort of bendy thing. You are on a roll. Let's see. Should I pencil mark the candidates into the rest of purple? I mean, should we be playing purple needs a 1? Hey, at 11. An Admiral Melkor. Okay, what can the row 9 clue be? Okay, let's go back to the row 9 clue. The row 9 clue. Okay, what can this be? Can it be an X sums? So if it were X sums, it would need to be 2, 7, or 3 and then 1, 5, or there's a 2 in the row. Oh, yes, it's not 2, 7. So it would have to be 3, 5, 1, 9. 3, 1, 5, 9, something like that. So yeah, so this would have to be a 3 exactly. These two would need to sum to 6 without a 2. So it would be 3, and then the 5 here. So it would have to go 3, 1, 5, 9 exactly. The 1 and the 5 in separate regions, and the 9 in yet another region. So the point is that breaks the combination of the rules of the X sum and the sandwich. Because the X sum rule says all 3 of these have to be in the same region, but the sandwich rule says that these have to be in different regions. Okay. So that was completely horrible, but we'll take it. So now we have to ask, okay, what can the 9 be? So it's not the region count. It's not a frame clue. It's not a flame clue either. It's not a frame clue. It could be the stupid numbered rooms clue. It can't be a sandwich because the sandwich for the row is 5. It can't be a skyscraper demonstrably, and we just said it can't be an X sum. So it is the stupid numbered rooms clue. So numbered rooms. So it is the patented stupid numbered rooms clue for this collection of cells. Yes, the hashtag stupid numbered rooms. Yes, using hashtags to label them would be awesome. That would be very on brand, I feel like. The 5 clue in row 6. Do we mean the 5 clue in row 7? I think we probably mean the 5 clue in row 7. Can't be numbered rooms. Can't be frame. Yes, this can't be frame. Oh, column 6. Column 6. This one. Okay, column 6. Got you. Because amusingly, this one also can't be frame anymore. But this now can't be frame because it would make all of this purple. So now this only has 2 options because it's not frame, it's not X sum, it's not numbered room, and it's not sandwich. So it could be region count, or it could be skyscraper. Those are the possibilities. Region count or skyscraper. This has considerably more optionality because we only know about one thing that it's not. Let's see. I can go ahead and fill in the candidates here. So it looks to me like it can be 2, 3, 4, 5, 6, except it can't be 2. So it looks to me like it could be 3, 4, 5, 6 for the 9. Oh, it can't be 5 either, because the 5 in the row is part of a sandwich, is part of the sandwich. So it is 3, 4, or 6. So there, or there. I'm not sure I'm prepared to go further than 3, 4, or 6. Let's see, if it were 3, it would put a 5 there and a 1 there. Let's see, can row 9, column 4 be a 9? So several people are claiming that this cannot be a 9. So if this is a 9, I guess it's worth noting what the shape of this sandwich is, because the way that this is going to play out is going to be that this sandwich is going to create a 1-cell wide region that's going to have to get up. And so, yeah, if this is a 9, it definitely breaks. So if this is a 9, that's a 5 and that's a 1. The 9 now, but there's a border here, which then forces a region to go up here, and now blue is only 5 cells. So Carl rules out this being a 6. Jaleb says this can't be a 4 either, which would be the 9 being here. So the 9 being here would have to put a 9 here, a 5 here, and a 1 here. I don't immediately see what's wrong with that. With this being a 4. But in any event, we know one of these two is a 9. So if you think about where the 1 would go, if this is the 9, the 1 has to go here. And if this is the 9, the 1 has to go here. So one of these two is the 1 for the row. See, so interestingly, Carl and Jaleb think that this is opposite numbers. I don't see either of their points, but both of them think that it can't be the thing that the other thinks it has to be. If I'm reading chat correctly. Yeah, I mean, I marked the places 1s could be. I marked the places... So that implicitly marks the places 5s could be. Okay, so Carl is saying look at the other option. So look at... This is the 9, so this is a 3. That's a 1, that's a 5. And now this is going to... Is this going to force this to be blue? Because this can't be... Well, these can't both be blue. So, yeah, this is going to force this border. Right, it's going to force 2 1s into blue and force blue to be too small. So, yeah, so that's completely right. Yeah, if this is the arrangement, this just does not work because these two are in the same region and they create this barricade. Okay, so this is not a 3, so it is a 4. So that's the 9. And once that's the 9, that's the 1, and that's the 5. Hey, SPQ. So these are now, if I write it out, some other numbers. Let's see, we've got a 1 and a 2. We need a 3. We've got a 4 and a 5. We need a 6 and a 7 and an 8. That sounds approximately right to me. Probably should ask what this 2 clue is going to be, given that there's now a 1 here. So it's not a frame. It's not a numbered room. I guess this could be a sandwich, but it's not a skyscraper or an X sum. Okay. Here's a good point. I know these two are in the same region now, because otherwise I'd have no. Sorry, I'm reading this wrong. Uh, uh, we can do lots of bordering in row 9. Good point, because of the whole sandwich nonsense. So it's funny, when I read it, the sandwich rule sounded the most natural, but in practice, it has been the most obtuse. So this is not any color that we already have. So this can be pink. This is not any color we already have. So it's going to be let's make it brown. Why not? This could be blue. Oh, if it's not blue, is there any universe where blue can finish? If this is not blue, it has to get out through there, and now blue is a maximum of 7 cells. That's not going to work. So this is blue. And if that's blue, this is blue. The 4 and the 9 are in different places. Now row 9 column 1 can't be a 7. Because that would make this a numbered rooms clue. Good spot at 11. So if this is a 7, well, the 5 is in the 7th spot, so that's not allowed. So this is not a 7. So 7's now up here in red, so 7's not in either of these two cells. If this isn't blue, whatever it was would have to escape through this hole, which would then mean blue couldn't be anything. So that cell's definitely blue. Same if this cell wasn't blue. And now blue only has one outlet, which is there. And so blue has to look like this. So blue's done. Wait, what did I do wrong? Row 8, column 5 can be yellow. Oh, right. Sorry, this can be yellow. Right. Right. This could be yellow. Was this able? No, this I knew couldn't be yellow. That's why I got confused. This I knew couldn't be yellow. This can be yellow. Right. So the way people in chat have seen this is by asking themselves my least favorite question, which is, where does blue get a 4? And they've seen that if blue lived in the bottom 2 rows, blue would not be able to get a 4. So the thing that has to happen actually is that blue does still need to take this cell, because blue needs to escape through here or end here, but it can't end here because of the 4 thing. So actually blue is going to take this weird shape. And I think that is the correct number of cells. That is the correct number of cells. And we get to place a 4 here for the chat. And so now this is yellow. I also sometimes have to add killer cages, but adding killer cages doesn't have to be my favorite part of Sudoku either. So yellow's done. Let's see. So this cell could be purple, annoyingly, because then just would need these three to be different colors, so that's not a big deal. Let's see. Kind of want to egregiously pencil mark all of this. Yellow is what we in the family call a hammerhead zeta. That is what has happened here. See, 5 in blue goes here while we're doing while we're playing this game. This can still be an 8, I believe. Blue is paying its respects, I see. 5 in yellow? Oh, is your point that 5 in yellow forms a sort of pseudo X-wing with these things? So none of these cells can be 5? I agree that none of these cells can be 5. Let's see. Do I know that this has to be a numbered rooms clue? If I knew that this had to be a numbered rooms clue, that would tell me something, kind of. Yes. I also tried earlier, JLib, to use this 5 to say, well, those can't be 5. So I did exactly the same thing. Let's see. If this 5 is a numbered rooms clue, it would be an 8. Okay. So maybe now we need to pin down what this 5 is. So I think it probably can't be a region count, but I don't want to rigorously prove that at the moment. I'm certain it's not a frame. It's not a numbered rooms. It's not a sandwich. I guess it could be a skyscraper. Can it be a skyscraper? It's not an X sum. So it's either a region count or a skyscraper. So I guess the point is, either way, there are a bajillion regions in this column. Because this is either a skyscraper, in which case there need to be at least... Oh, wait. It's always a region count. Because if it's a skyscraper clue, then there are 5 regions. So this is definitely a region clue, and whether it's also a skyscraper clue or not is totally irrelevant. I noticed that earlier, that the region count and skyscraper were kind of redundant with each other. So there are a bajillion regions in here. In order to get this all the right. So whether it's a skyscraper is just completely irrelevant, I think. 9 in yellow has only one spot for skyscraper reasons. All right, 9 can't go here. 9. Right. After the 9, there needs to be another thing. So 9 in yellow could go in one of these spots. But the claim is if 9 went behind it, it would be too late. So I guess the point is, to say it slightly more precisely, Jay, there are at least 5 regions in this column. So there could be maybe 6 somehow. Does the 9 in row 3, column 3 force row 9 to be an 8? No, the reason this could be a 7 is that if this is a 7, I could hide the 8 behind the 9. And then that works. So yeah, so this is at least 5. But if it's 6, then that means that you have to do something utterly ridiculous with the skyscrapers that's never going to work. If 9 in yellow... For the skyscraper clue, wouldn't that break the chaos skyscraper rule? Okay, I think for that, I think I actually have to go back and read the legalese of the skyscraper rule. Sorry, no, not that one. Okay, we're going to read the legalese. So here's the fine print. If the outside clue is a skyscraper, every seen skyscraper must belong to a different region. Right. Okay. Every scene skyscraper. Okay. So it's not just the region has to change. Right. So the 9 cannot be in here. Right. So the 9 actually is over here. Good spot. I did not interpret that correctly. So there's a 9 over here somewhere. And so one of these two is a 9 is the point. Okay. Oops, I don't know why I changed that to gray. I didn't mean to. One of these is the 9. Oh, I guess I was in blue before. Which blue was I in? Is it that blue or that blue? I think one of... I suddenly accidentally switched to... there we go. Okay. And then the upper one can't actually be a 9 because there's a 9 in the row. So now we get to see if I accidentally changed what blue we're using. Does that look like the right blue? Does that look like the wrong blue? Who knows? We'll find out. Okay, so these cells are yes, all the skyscrapers that are seen have to be in different regions. It's not just that there has to be a border like I'd previously thought. 2, 3, 4, 5, 6, 7, 8, 9. So these are 2, 3, 6, 7. This one's not a 2 or a 3, at the very least. And then I think these can be basically anything, is what I seem to see here going on. Okay, chat has a bunch of different things going on simultaneously that I will try to get to in time. So first of all, there need to be at least 4 regions in this row for the skyscraper clue to work. Because the 4 seen skyscrapers need to be in different regions. And so there's 4 regions at least. 1, 2, and then 3 and 4. But unless the 9 is exactly here... here's a good point. The 9 is here. Because if the 9 isn't here, I still need to see 2 more skyscrapers, and I, at this point, can only have seen 2, because this 4 is never getting seen. So I need to see 1 here and 1 here. Oh, maybe the 9 could be here. Sorry, I think I misspoke. But I don't think the 9 can be there. The 9 definitely can't be here. The 1 is also a skyscraper. 1, 2. If the 9 were here, that would be 3. And it needs to be 4. Okay. So Carl, I think, is arguing this has to be a 7 because there aren't enough numbers that aren't higher than 5 here. So if this was a 5, I'd need to pick all of these from 1, 2, 3, 4, and I can't. So I agree with Carl. This is a 7, and that's a 5. Very, very well spotted. So it is an 8 and a 9 that go over here. That are seen. Let's see. Yeah, so there is an 8 over here, although that was even true just from Sudoku. So I guess the real question is, if this is the 9, then this would go 8 region, 9 region. Is that possible? Maybe. Who knows? KNT is very upset about some region, something I said earlier. I feel like all I said out loud was that there's at least 5 regions in this column, which I feel is still true. And then I wrote regions here, but that was just to remind myself this is not part of the solution. The 1 in row 6, column 9 is in the last region. Hey, Franco, welcome back. It's not in pink? Or is pink the last region? Oh, it probably can't be pink. Yeah, it can't be pink. Because if it was pink, brown wouldn't be able to finish. Which is very interesting. Yeah, this is like almost set up for pink to be able to let brown finish, but not quite, I think. Certainly not with the fact that I need to fit 5 regions in this row. But certainly pink could let brown... Oh, sorry, I was trying to make this pink. Never mind. Yeah, this is definitely not pink. Okay, what kind of clue is the 5 in row 7, column 10? Okay, let's look through this. So it's not allowed to be a numbered rooms clue. Yeah, we know this is a different region. I'm not giving it a color just because I know it's a different region. You need to do more to earn a color from me than just have me know you're not the same region. So the number of regions would be one possibility, I think, although that would be very prescriptive, but I think it could be a region count, which would be pretty consistent with this row. And notably, if the 9 is here, it is a region count. If it's not a region count, it's certainly not a frame. It's not allowed to be a numbered rooms. It's not allowed to be a sandwich. It's certainly not a skyscraper. So the only other option is that it is an X sum. So this is either an X sum or a number of regions. Carl really wants to give this a color. Oh, are you? Oh, I see. Okay, I see now why people want to give this a color. Okay, because people are thinking more steps ahead than I am. So it is an X sum, right? Because the point is that this is. Oh no, it's not an X. So it is a number of regions. Never mind. Yeah, this is a number of regions. So the point is, this is a region sum, right? Okay. So, oops. So, so I will go ahead and, for in Carl's honor, we will dub this. We'll dub this one. Oh, sorry, pink is already being used. We'll dub this a green. What do you mean they look wrong? How else am I getting to 5? Oh, it's because I wasn't counting this. Never mind. Yep. It's because I can't count. That's why I was confused, because there's already 3 over here. Got it. Okay, that's the thing I was missing. And so now, that makes this work out completely differently. I didn't count this. But now if the 9 was here, there would be 6 regions. Because if the 9 was here, it would put in those borders, but that would be 6 regions. And so the 9 is here. So this is not a 9. And there is an 8 in one of these 2 cells. And it's not possible that, like, pink wraps up and around like this, as we've discussed previously. Oh, this still is regions. I just can't count. Okay. Oh, I still meant to give this a color. I did, and then it lost it. But we can do that. I think filled with dread is a very appropriate reaction to have to this. This puzzle. Yeah, so people are pointing out, if this isn't brown, we have huge problems. Yellow does not count twice, which is super weird. I'm going to guess that Niverio changed that rule at the very last minute to stop the puzzle from breaking. Because it's very weird to count regions the way this puzzle counts regions, but it does not count yellow twice. So brown needs to take this cell in order for it to escape and not get boxed in by pink and these things. And so pink needs, even if pink takes a cell over here, pink needs to take these 2. So brown needs to take this one always. Let's see. 1, 2, 3, 4, 5. Okay, that's our 5 regions for this row, actually. Various edges in there. So this could be purple now. That's acceptable. Yes, and we have 5 regions in row 7. That's the point. Okay, so now green can't take this cell, because if I count and I count correctly, that would put 6 regions here. So green's not allowed to go down, which means that this had better be brown, because it's certainly not pink or anything else. So green needs to grow up. Now, even in the event that pink takes this cell, all of these are brown. Brown always needs to take this cell because it's not done even if it does take this cell. So green needs to take this cell. Pink, even if it takes both of those cells, is nowhere near done yet. So it's 1, 2, 3, 4, 5, 6. Okay, so this has got to go to 7, and it's at least got to go here, actually, no matter what happens. Niverio would really like us to think about the 2 clue. So let's see. What could it be? It's not a frame. It's not a numbered rooms. It's not a skyscraper. It's not an X sums. It's not a sandwich. So let's see. It's not a sandwich, not an X sums, not a skyscraper, not a numbered room. So it's not any of the real kinds. So it is a region count. Okay, so this is a region count clue, is the point. Okay, so in other words, if this is pink, we're going to have problems, because if this is pink, I can't make all of these cells. Yeah, green's going to have to take a cell up here. So if this is pink, it's not going to work. So this is not pink. It is brown. Because the only colors that are allowed in this column are brown and green. Brown has to grow up one more, and then brown is done. And so now green is forced to take all of these, and now green is done. So, sure. Purple needs to take one of these two. Let's see. Yeah, and then this column... but in the kind of sad way. Like, aren't you sad that these regions ended up looking like this? If I were studying this, I'd be very sad that these regions ended up like this. Purple only needs one more cell. So could pink come here and purple go here? No, because of this column. It's the number regions clue in this column that's the problem. Yeah, I had one puzzle where there was a region that was like the top row that made me extremely sad, but I liked the puzzle otherwise, so I published it anyway. So I feel your pain at ending up with 2 regions that look like this. Hey, Alex. Okay, so... So how many regions are done? We have 4 regions done, right? These 4 regions are all done. Okay, and we need at least 5 regions to make appearances in column this one. And so the 4 done regions are not making appearances in that. And so that means that every remaining region needs to make an appearance in this column. So in particular, green has to make it there. So green needs to beeline straight there, either here or here. Does this do bad things to orange? this looks very bad for orange. Because now orange needs to wrap around like this. Which now means orange is probably going to have the wrong number of cells. Because now orange is going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, okay, yeah. Or green can't get there like that. So green has to get there like this. Okay, and so green is done. Yeah, it isolated these cells without giving them a region to be friends with. So that was never good. Pink, no matter what pink does, needs to go up because pink is currently only at 6 cells. So even if pink grabs both of these, and pink can't grab both of them because one of them is purple. So actually that pushes pink up 1 more cell. So one of these is purple and one of them is pink. I don't know which is which yet. But that means pink is done up here. These are not pink anymore. Which now means that orange is finished. It's just this little quaint little region up here. So orange does that. And it's just a question of which of these is pink and which of them is purple. Now, people have repeatedly suggested I look at 8 in pink, and I have absolutely no idea how I'm getting, or what I'm supposed to be doing with 8 in pink, I'm going to confess. Okay, so now people are suggesting I look at this. So this is a frame. I can just go ahead and fill in. Not that it's going to be relevant anymore, but now let's look at what this can be. So it's definitely not a region count. It's not a frame. It's not a numbered rooms, a stupid numbered rooms, no less. It's definitely not a sandwich. And 2 is never an exsum. So this is a skyscraper. Good point to Andrew for that. So this is a skyscraper. Which means something, I'm sure. 1, 2, 3, 4, 5. Okay. KNT can now be happy that we've officially proved that this is really a regions and not a skyscraper. Unless it's also a skyscraper. 9 in row 4. Not there. Is the 9 in row 4. Ah, right. The 9 in row 4. Right. I can't repeat 9 there. I can't put 9 there. So this is a 9. Okay. Agree. That's a 9. I can't put the 9 here. Actually, I could put the 9 in either of these places already. So it actually doesn't matter. I didn't need the skyscraper clue to know that this was a 9. Is the upshot of this. But the point is, knowing this is a 9 now does mean, thank you, Jaleb, that I know the rest of the world. So the rest of the world looks like this. Because of that. So that is relevant. And so that gives us the rest of our who's a whatsits. What are these digits? These digits, I know what they are. They are a 5, and a 7 and an 8. So that makes this digit not a 5, 7, or 8, which makes it a 6, which makes that a 3 and that a 6. Means none of these are 6s. Those aren't 6. And so once these aren't 6, that means these aren't 8 or 6. They're a 5, 7 pair. That 6 makes this an 8. Which makes that a 7, which makes that an 8. I will remember. That's a 6. These two digits, actually, let me remove, those aren't 7 or 8. These two digits are 1, 2, 3, 4, 5, 6, 7, 8, 9. And I know what order those go in by Sudoku, 4 and 5. In about 6 million ways. These digits I can fill in. They are 1, 2, 3, 4, 5, 6, 7, 8. Okay, these are 1, 2, 4. These aren't 1, though, so that is 1. And that's 2, and that's 4. By continuing by Sudoku, so this isn't 2. Let's see. These 3 digits I can fill in. I've got a 2 and a 3, 4, 5, 6, 7. Yeah, these are 2, 3, and 7. And these aren't 7, so that is 7. Rules 3 out of a bunch of places. So this none X-wing on 3s says that one of these two cells is a 3. These two cells are the same. Let's see. Are there any other places I want to fill in? I kind of want to fill in this row. So I got a 1. We need a 2 and a 3. I got a 4. Need a 5. Got a 6. Need a 7. And then we've got an 8 and a 9. So these are 2, 3, 5, 7. That one's not a 2. Could be a 2. This one's not a 5 or a 7. It is a 2 or a 3 only. Let's see. Row 7. Row 7 looks juicy. 1, 2, 3, 4, 5, 6, 7, 8 is all that's left. Let's see. How many 1s do I have in the grid? Surely I have almost all of the 1s. These aren't 1. Those aren't 1. That's not 1. So the 1 in orange is in one of these two cells, I suppose. Remember that the 8 and the 9 have to be in different regions. I definitely don't remember that 8 and 9 have to be in different regions, because I'm not sure what clue we're even talking about. Oh, there's a skyscraper thing going on here. This can't be a 3 anymore, because if this was a 3, this would have to be bigger than 3 because of that. So this isn't a 3 by skyscraper considerations. Right. The skyscraper reading from this way, we never finished. And the skyscraper reading from this way means I can't put an 8 here, because the scene skyscrapers are in different regions. Okay, so good point, Carl, even if I did not immediately understand what was going on with my life. So that's a 6. These aren't 6. I'm told there's a 5-7 pair that I should be looking at. There's an 8 in pink. Let's see. This isn't a 6. I know that much. Let's see. Row 4. Row 4 has a 5-7 pair. Good. So this is not a 5 or a 7. This is a 2 or a 3. And now the 2 skyscraper works no matter what. And that is a 2, 3, 7 triple in brown. So these are actually the other ones. So these are not 1, 2, 3, 4. They do include a 5, not a 6 or a 7, and an 8. So these are a 5-8 pair. And I know the order. 8 and 5 go into the grid. these cells are 2, 3, 4, 5, 6, 7, 8, 9. This is not a 3 or a 2. This is not an 8. Oops. Oh. 8 was not one of the options. Oh, but it's not a 2 because there's a 2 in the region. Let's see. Row 6, column 6 is a naked single. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so this and this are the same digit. Let's write in all the options and let's see what it is. Okay, so it's not a 3 or an 8. It's not a 1 because it sees that 1. It's not a 9 because it sees that 9. It's not a 5 or a 4 because it sees that 5 and that 4. It's not a 7 because it sees that 7 immediately next to it. Okay, and now in order to verify Andrew's point, I just need to find one more place. It needs to see a 2 or a 6 that I do not see where... Oh, it sees a 2 in the first row, so it's not a 2. So it's a 6. There we go. 6 and 6. Great spot to Andrew there. Okay, this row only has 2 digits left in it, so let's go ahead and fill them in. 2, 3, 4, 5, 6, 7, 8, 9. Okay, so these are 2, 3. So that gives us a 2, 3 pair in this column, which gives us a 6 here and a 3 here, which gives us a 2 and a 3 and a 2 and a 3. So this isn't a 3. Let's see. This column is missing a 2, a 4, 6, a 7, not an 8 or a 9. Let's see. This region is missing a 1, a 2. We've got a 3. We need a 4 and a 5. We've got a 6. We need a 7. We've got an 8. And we need a 9. Okay, these are not 2, 7, or 9. This one's not a 4. This one's not a 1. These aren't 9 or 5 or 4. That one's not a 2. That one's not a 1. These are not 2 or 1. That one's not a 4. Row 5 already has a 3. That's a good point. So that's not the 3. Also, purple already has a 2. So either or both of those reasons make this a 3. The 2 in this column actually is a good thing to ask about, because the 2 in this column can't go there. The 2 in this column can only go here while we're talking about things. This is not a 5. So this is a 1, 7, or 8, but it's not a 7. So this is a 1 or an 8. In fact, actually, let's fill in the rest of purple. Purple needs a 1. It's got a 2, 3, 4, 5. Needs a 6. It's got a 7. Needs an 8. Let's see. This isn't a 1 either. I feel your pain, Niverio, because I had to do that on the puzzle I just set, and yes, it was terrifying, because it was like, oh no, please tell me I have not accidentally ruined everything. This is not a 2. This must be a 4, 7 pair to finish off this row, except that's not a 4, so it's a 7. And that's a 4. So that's a 3, that's a 5. That's a 2, and that's a 7, and that's a 2. And that is a 7. Let's see. That's 7. Okay, not that 7, but that 7 tells me that's a 9, and that's a 3. You'd think some of these would be more useful as I filled them in, but what are you going to do? So This is not a 9, so that gives me a 1, 5, 7 triple. So this isn't 5 or 7. This is 4 or 9. But I should just add, this is 4 because I have a 1, 5, 7 triple, and this is 9 because I need to put a 9 in the box somewhere. So that's an 8 and that's a 4. Let's see. This 8 means this isn't an 8. That's not an, oops, not that one. That's not an 8. This 6 looks up and gives us an 8 there. So that's a 1 and a 6. The 1 looks up, gives us a 7 and a 5. I did not do that correctly. Try again. 1 looks up, gives us a 7 and a 5 and a 1. 7 looks down and gives us an 8 here. This is not a 5 or an 8, so it's a 7. That's a 5. And then over here, we are missing a 3, 4, 5, 6 and an 8. The 6 goes there, the 8 goes there, the 7 gives us a 5 and a 7, and we were already warned the answer check would not work because we used a kind of edges that is not good. But we will, I think, take credit for solving this. This is a beast of a puzzle, but this is really nicely put together. Naked singles in your area are available if you act fast. Just wait 6 to 8 weeks for delivery. I think this region is my favorite in terms of shapes. I think this is a fun little region. Only a little over 2 hours. I'll take a little over 2 hours. That's not too bad. Yes, I really like this move you're making towards very elegant rule sets. I think that is a very good move. Yes. Yes, it does look like a hammerhead shark, or a hammerhead zeta, as I called it, and the F region is appreciated. Lots of cool stuff going on in this puzzle. I liked that I could use the little notes, so I appreciated that I did this in Penpa, even though I complained about it originally, but I like that I could use the notes around the edge to record what these things were, because otherwise I might have completely forgotten what everything was by the time I was done. Alrighty, I'm going to take a quick break, and when I come back, I'm going to do a puzzle that is easier than this puzzle and has fewer rules than this puzzle, which eliminates not all that many puzzles, but I'm going to find a puzzle that meets those requirements, and I will do it when we get back. So I will see you shortly. Oh, that's right, setter challenge. Sorry, setters. Okay, so next setter challenge. For those of you who like the setter challenges. So next setter challenge is that you all know that I am very fond of coloring. So the next challenge is I want a puzzle that involves a new sort of coloring that I have not done before. So let me give you a couple examples of what would count. So entropic lines would have counted, except I've now done entropic lines puzzles. But Sudoku puzzles that involve coloring different sets of digits, or coloring some different thing, or coloring it in a lopsided way, or whatever, that's all fine. I have definitely done puzzles where I have to color every single digit. That does not count as coloring in a way I've not colored before. But what I would really like is for pencil puzzles that use color in a new way. So most pencil puzzles involve coloring in gray and green, and that's all well and good, but I would be interested to see some new pencil puzzle variations that let me color a pencil puzzle in 3 colors, or whatever your mind sparks to with that. So definitely the last puzzle I did was very slanted towards Sudoku. So this one I want to slant more towards pencil puzzles. It has to be new to me. I have done a lot of things, but I certainly haven't done everything, and I'm certainly not going to do a copyright check. I I have not done a 3-color yin-yang puzzle. So if you want to do a 3-color yin-yang puzzle, I will happily accept a 3-color yin-yang puzzle. But again, there are plenty of Sudoku options as well. So if you want to do a Sudoku option, that's fine. Whatever it is you want, but that gives you sort of a plethora of options. I'm trying, by the way, for all of these challenges, part of my specific motivation is that I want to have a really, really broad... I have solved a number of yin-yangs on this channel, Niverio. I have not yet solved Jesper's yin-yang, which I'm told will be longer than Niplu Ultra, but that I kind of want to solve. But I try in these to make it so that when we then do all of the puzzles, they won't all be the same. So I think this one leaves a lot of wiggle room. Although now I'm worried that I'm going to be doing 3-color yin-yangs for 2 weeks. But we can do that. I've done... Fistamafel had some yin-yang puzzles that I've done. I did one by someone. Maybe it was Fistamafel on stream at some point. There's always room for more yin-yangs. But anyway, that is my... Nori. That is the next setter challenge. So you're going to have a good 2 weeks, at least, to do that. So take your time, come up with something exciting. You can send it to Tristan when you are ready. Be sure you get it tested beforehand. But other than that, that is the challenge. You can let me know if you have any questions about exactly what I mean by any of this, but generally my goal is to make it fun, so I'm going to construe things as widely as possible is generally my thing. But if you want to message me and ask, hey, have you done a puzzle? I have, for example, done Japanese sums puzzles. Sorry, Panthera. But if you want to make variations of things, or if you want to know, like, hey, have you ever seen something like this? I'm happy to answer it. But short break, and then we'll be back with another puzzle. Alrighty, welcome back. So I see there have been a couple questions that I can answer in the meantime. So one question is, how do you send puzzles to Tristan? And so there is a Discord called now the Puzzle something. But there's a Discord server with a link that you can go to, and you'll find both me and Tristan there in the zetamath channel. So you can, if you're not on the Discord, I really recommend coming to the Discord, and then you can submit them to Tristan there. Also, the Cogito asked if it's acceptable to do a Sudoku and pencil puzzle hybrid. Absolutely. A Sudoku pencil puzzle hybrid is a perfectly reasonable way to satisfy the thing I have requested. Maybe if I'm very lucky, Sven will add more colors before it is time for me to do the color challenge. Although with how much people are complaining about colors lately, I worry that Sven is going to take one of the colors away. But Pentominus is definitely a pencil puzzle. It definitely counts. I've done Pentominus puzzles before, but if you make any sort of slight variation on a Pentominus puzzle, that would certainly satisfy it. But yeah, so I'm looking forward to seeing what people create. So this will be the fifth time that you all viewers have created puzzles for the stream, and all the previous ones have been absolutely fantastic. So I am hoping that we get to do the same. I have not done a Murapeke or a Morapeke Sudoku hybrid, so that would be a perfectly acceptable thing, yes. Hexominus, yes, that sounds very intimidating, but I would do it. I figured that Sven would take away yellow first to show that he was serious. It's not like the best color, but it's not one of the crummy ones, you know. But yeah, definitely I would like there to be one. If there's only going to be 9, I would like there to be one gray. I would like it to be this gray. And then I would like, oh, sorry, I didn't actually. This gray, the one that you can actually see, not the invisible, not the one that's basically white, and not the one that makes everything illegible. So I want to keep this gray and kick out the others. I don't think I've done a Battleship Sudoku before, so I think that might count. Alrighty, so this is a puzzle by Lisztes. So we've got all of these. Yeah, it is true. The best use of black is as a flash. This is probably the latest in the stream I have ever described what the rules of German Whispers are. Because we're now 4.5 hours in the stream, and I've not done a German Whispers puzzle yet. And I also have not done a Renbun puzzle yet. It is unprecedented times here in zetamath headquarters. But the way these green lines work is that digits that are next to each other on the green line have to be at least 5 apart. So if I put a 3 here, I could put an 8 or a 9 here, and so I could do that, and that would work. But now I need to stay at least 5 away from 9. So I could put a 4 here as long as I put a 9 here, except that's a problem, so maybe you shouldn't put the 4 there. So that's how the green lines work. These killer cages, they give you the sum of the digits inside them, and digits can't repeat within them. So the fact that the digits can't repeat within this one, not super exciting. The fact that the digits can't repeat within this one, much more exciting. Also, very kind of Lisztes to remind us that the sum of the digits 1 through 9 is 45. I very much appreciate that. And then these are arrows. So this digit in the circle is the sum of the 2 digits on the arrow. So this would be an acceptable way to fill the arrow. And I believe that is all of the rules. So there we go. Yeah, so Tallcat is suggesting doing a poll on which colors we get rid of. It can be just like with the M&Ms. If people remember when there were brown M&Ms, and then the tan brown colored M&Ms, and then people voted to get rid of that one and then voted in to add blue M&Ms because there hadn't been blue M&Ms before that. So the thing you have to do in German Whisper puzzles is you have to color. That's not a good color to choose. You have to color things in high and low, and so I'm just going to put it up here. Blue means 1, 2, 3, 4. Orange means 6, 7, 8, 9. Don't listen to Simon when he tells you otherwise. So the thing I'm immediately suspicious of is this German Whispers in a 15 cage. Because the thing about German Whispers is they always alternate strictly between low and high. So if these digits were both high, they would sum to a minimum of 6 plus 7, which would be 13. And that is too many, because then these two digits would have to sum to at most 2, and that's not going to work. So we get our first coloring by coloring those blue and that orange. And now we are off to the races, maybe, kind of. Oh, a bet cell. Bet cell, yes. Let's do a bet cell. This looks rather bet-cellious to me. If people would like to do a bet as to what this cell will turn out to be. You can also do a bet color, if you would like. I have no idea how much coloring I'll do in this puzzle, but I'll hit myself in the face with a microphone somehow. But experience suggests it'll be a lot. Now, there is another fact about Whisper lines, other than that they are obligated to be colored in orange and blue as soon as you have a Whisper in your puzzle. And that's that you can't put 5s on them. So there's also a 5 over here. Now, the world's tallest cat has noted that exactly the same reasoning I used here. If these were both high, the minimum they would sum to is 13, and I can't put 13 in a 45 cage. So these also have to be low, with this being high. Now, as a triple arrow, this is always going to be high, because it's a sum of at least 3 numbers is going to be minimum 6. So this is going to be high. Now, we know there are 2 highs and 2 lows on this Whisper here. And so there are 3 highs between these cells. So these cells are 3 lows. Sorry, there's a 5 in here. 5 and 2 lows and a high. It's probably worth marking, actually, that I know that there's a 5 in there. So the 5 in this box I actually know is restricted to these. Couldn't this be a 5? Yeah, this could go 7, 1, 2, and a 5. And in these parts, we tend not to reward 5 with a color, but it could exactly be 7, 1, 2, 5. So I don't know. I know it's not blue, but I don't know but I don't yet know that it is orange. Let's see. Is there anything exciting to do with the geometry of this cage? I mean, this cage sort of suggests that maybe I should think about some geometry, but I'm not sure. If you find a way to make a puzzle that requires coloring 5s, probably would be new for the channel. Although whenever Casey is here, we always color 5s in his honor, because he gets sad if the 5s have to go without colors. Okay, so let me fake color this one. Yeah, okay, so I'm going to color this one in yellow and purple. both because it makes me happy, but also because it gives me a little bit of insight into what's going on. Namely, these two are the same color. Whatever color that is, the other two of them are over here. I don't know whether yellow is blue or orange. That's why it's yellow. And so, actually, that gets us a digit. Because this cell sees all 4 yellows and all 4 purples. So that makes this cell a 5. And we will see the very rare 5 dance from Precious Zach. So Zach gets to do the 5 dance. Bloop, 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 bloop. Thank you, Zach. 5 dance. Okay, so these are both yellow. Now, it is being suggested that these digits being blue would be a problem with the arrow. But I feel like 126 is a valid arrow. Yeah, 4 is not locked off of anywhere except down here. In fact, I know 4... Well, sorry. If 4 is on here at all, the 4 or 6... No, don't listen to me. Words. I'm just going to say words. There have been a number of very cool Shikaku Sudoku puzzles, Tremkel. If you look in the zetamath Those Puzzles catalog, you'll find we've done quite a few of them on the stream. So there have been some by Kodak and Shy. There was a very memorable one by the Kachito that was actually submitted for a previous challenge. But yeah, so there have been some, but there's certainly a lot of space for it to explore further. Let's see. Okay, Logan is now going to argue that yellow is orange. Because row 6, column 2 is the same as one of these. There's only one place for it in the 45 cage. Ah! Now that is brilliant. Well spotted, Logan. That is great. Okay. So this digit has to show up in this box. That is gorgeous setting. Okay. This digit needs to set up in this box, and it's not those two. So it's one of these two. So this digit is the same as one of these two. But now it has to show up in the 45 cage somewhere, but it's not in any of those places. So it's there. So in fact, yellow is orange. Oops. Yellow is orange. Purple is blue. And this digit is that digit. And one of these two is that digit. That was, yeah, phenomenal spot. And phenomenal setting, too. That was a real... Like, it's so innocuous the way it is set up. Like, once you say it, it's like, ah... So it is very easy to explain, but I would not have seen that for a long time. black flash is not. Ah! And now, yes. So now notice this cell is at least 5. It could be 6. It can't be anything higher than 6 because these two sum to at least 3. So this is 8 or 9. To make that work. Making row 8, column 4, 5. Blue. Right. This 5 has made this 5 together with these two oranges, as Josh points out, have used all the oranges and the 5 for the row. So these are blue. So this is orange. So that's blue. And so, yes. So Jay's question is now, where does the 4 go in this row? Well, I can't put a 4 on this arrow because then it would be a minimum of 4, 1, 5. That's too many. So the 4 is in one of these two cells. But now, in order to be next to a 4, black flash has to be a 9. So the black flash of this puzzle was a 9. And so one of these is a 9. This may or may not be the exact situation that Tallcat was trying to argue could not happen at the beginning of the puzzle. So... right. How did I see this but not that? Liz beautifully points out the thing that I just completely ignored, which is that I have 4 blues in this box, so this can't be blue. And it's got to be blue or orange, so it's orange. Which is exactly the logic I explained when I looked at this little dinky one and then did not follow through to get these. Okay, so one of these two is a 4. Because neither of these can be a 4. These are from 1, 2, 3. So this one's actually only... No, never mind. Don't listen to me. That's not how that works. That's not how any of this works. SPQ said it first. Well, it is one I... Very rarely does chat say something and I go, wow, I really should have seen that. But that one maybe I feel like I should have maybe seen, possibly. One of these is definitely a 1, because this digit's at least 5. The 9 here, yeah, the 9 is one of these two cells. Where is 6 in row 8? Yes, 6 can't be either of these two cells because then they'd need to be surrounded by double 1. So Carl is correct. One of these two is 6, but this also can't be 6 for the same reason. So this is a 6, and this is a 1. That's not a 1. Let's try again. Oh, I need to turn off alphabet again so undo works. One moment. Letter tool off. There was maybe it's under advanced. I think there's under advanced there is there's a mode so that if we want letters, we can have letters and still have undo. But anyway, we want the undo for now. Oops. Redo. Okay. This is a 1. There we go. That'll sound better in the tape. So that works out. So this can only be 7 or 8. This can only be 2 or 3. Meaning that this digit on the arrow is now at least 3. 5, 6, 7, 8. 3, 4, 5, 7, 8. No, not at least 3. At least 4. My whole point was it's not 3 anymore because 3 would break this cell. Kurobon might be a bit behind. If someone wants to in chat, tell them. 5, 6 pair in box 8 is resolved. Oh, that was surprisingly difficult for me to figure out. The 6 there means that is not a that is not that. I was like, where's the other 5, 6 in this box? How do we place that? So yes. So now this digit can't be a 4. So this is a 2 or a 3. It's not a 1 and it's not a 4. So this is a 2 or a 3. This is a 7 or an 8. It's not a 9. I really wish YouTube would fix the whole like falling behind thing, because it's really hard as a viewer to figure out when you're behind. Let's see. This in the cage has to go up there somewhere. Let's see. Oh, people are pointing out correctly that I actually know that these two need to sum to 4, so they're 1, 3. So these are 2, 4. Which people are completely right about that. And now this has to be an 8, because 7 doesn't whisper 8. So this isn't an 8 anymore, so we can pull off another pencil mark. Okay, so this is a 7 or a 9 up here. This is orange now because of the 5, because remember the only thing this could be that wasn't orange was a 5. And so this is an orange. So I don't think this can be 9, because if this is 9... blue. I meant blue. I was like, wait, that doesn't work at all. No, blue. Thank you. So this is blue. Much better. That seems much workier than the other way around. As they say. See, there's a 1 over here somewhere. Let's see, if this is a 4, this would be a 1, 3. Oh, great point from Niverio. The 8 is now placed in this box because that 8 looks over here and sees that now that's an 8. Let's see. Tremkel says if row 2 column 5 is a 7. Actually, yeah, I think this figures out. Yeah, then so if this is a 7, then these need to be 1, 2. It's all they can be, and then this has to be a 5. So actually, this is a 9. That's a great spot. I would not have seen that for a bit. But yeah, if this is a 7, actually the only way it works out requires this to be a 5. So that was a very clever spot by Tremkel. So now these need to be a 1, 2, 3 triple. Otherwise, the world breaks. There's a fascinating question about these 9 pencil marks. Particularly fascinating because I definitely used them. Because I said this couldn't be 9, which I think used to. Oh boy. But these 9 pencil marks are not so good. We're going to hope we have not completely broken the puzzle and just gently put those back and wash our hands of whatever happens. This cell is definitely not a 3. It's a 2 or a 4 because it needs to go up here in this box. Oh, speaking of, these are a 2-4 pair. Yeah, these are 7, 9. These are 1, 3. These are 6, 8. These are orange, because I've got all my blues and a 5 for the row. So these are now 6, 7, which makes that an 8, and that a 6. Right, these can be orangified now. Thank you, Andrew, because I've got all my blue, and I got the 5. The 5 does lots of stuff for the oranging. If I were forced to say one good thing about 5s, it's that 5s often let you color real digits. The 7 and the 8 look down and make this a set. Or sorry, the 8 and the 9 look down and make this a 7. These aren't 7. Let's see. This is a 3. No, sorry. This is a 2, 4, 5. I don't know exactly how it works out. If this were a 2, it would create a lot of pressure on this arrow. Let's see. Row 8, column 9 is done. Ah, yes. Thank you, Ambrose. So that 2, 4 pair looks over here and makes this a 3. So I actually can write in what these are. So let's do that. So these are 2, 3, 4, 5, 6, 7. Which gets me not a whole lot of eliminations, but let's just keep going and fill in these. So these are 1, not 2, 3, not 4, not 5, 6, not 7, 8, or 9. So these are from 1, 3, 6. So this can't be a 4 anymore because of the 3 below it, because it would need to be a 1, 3 in order to do that. So this is either a 5 with a 1, 4, or a 7 with a 2, 5. So actually, in all cases, there is a 5 in one of these cells. Because this is either is a 5, in which case it needs to be a 1, 4. Or if this is a 7, it can't be 1, 6, because that would break this cell. And it can't be 3, 4, so it needs to be 2, 5. Okay, and so that actually removes some 5 pencil marks from there and there. Let's see, Eric Praline says it can't be 2, 5. Let's see, what's wrong with this being 2, 5, 7? Because then I've not used enough digits. Because if this is 2, 5, 7, now this is a 4, 4 pair. So yeah, great spot to Eric. We would create a 2, 4, a 2, 5, 7, 4 quintuple. That's very cool. Okay, so this is a 5. These are that's a 5 for that matter. These are a 1-4 pair. These aren't 4. These are blue, and that's blue. So all of these are orange, actually. Let's see. The only blue left in this box is a 3. Everything else is orange. It's being suggested that if I try very hard, I can identify that this digit is a 4, which I suppose is true. Sudoku emoji. Oh, that's good. I want a digit dance emoji. A Sudoku emoji sounds good. I feel there are many emojis that we could get. Let's see. There's only, I guess, the last orange. Okay, so the last orange in this box is on this line. So these two cells cannot be orange and they can't be 5, so they're both blue. That fit, and so this is a 4 in particular. I think this is the Sudoku that was being requested by Tallcat. So these are 1, 2, 3. These are a 5 and a something. These are a 5 and a blue of some description. So this cell sees every blue and a 5. So this is orange, and is in fact the last orange for its column. So it's a 7. Wow, this puzzle is. Whew, how on earth did you set that up? Inquiring minds would like to know. So now this column, the entire rest of it's blue. So thing. Let's see. Do we have more that we can do? Row 3, column 7 sees every orange and every blue. It does see every orange and every blue, so it's a 5. Thank you, Carl. Every orange in the box via the medium of one of these is orange, and every blue in the row. And so that lets us orange in these two cells. So these are a 6. Oops. These are a 6, 8, 9. Okay, let's see. We've only got a 6 left in this column as far as these go. Blue in box 3. Okay, so blue in box... Oh, I was looking over here. Right. This is blue. That's what you're saying. Blue in box 3. Yeah, this cell is blue now to finish off that. I was just looking at this cell and realizing I know this cell isn't blue, and then wondering if I know it's not orange, or if I know that it is orange. But this cell can't be blue because it sees 1, 2, 3, and 4. But I don't think I know anything about it yet, unfortunately. Let's see. This cell is a 2 or a 3. I know that much. If row 4, column 5 was not 6, then... right. If it's not 6, then this is low because the 5 is gone, and now all of these would be blue, and that's 5 blues. Great spot, Carl. So this is a purple... Sorry, this is an orange 6. It's either 1, 5 or 2, 4. This 1, 4 over here, I am being noted, looks down here, so that's a 2, and that's a 4, and that's a 9, and that's an 8. Good spot, Ambrose. Thought I was going to sneeze, but then I didn't. While I was sneezing, I noticed that these are blue. To finish the column, this is 1, 2, 3. This isn't 4, so that's not 2. These are all orange and 5. I don't think I can do a lot with it being orange and 5 immediately. 7 in box 3 must be in column 9. Oh, but that went away while I was trying to parse it. Row 6, column 4 is not 6. So it's blue. It's not 6 because we put a 6 in the box. Great spot, Ken. So that gives us a 1-3 pair. So that's going to give us a bunch. So that was a great spot to Ken. So that's a 1-3 pair. So that's a 2. That's a 4. That's a 2. So neither of these is a 2. This is neither a 1, 2, 3, 4. This isn't any of the things that aren't 5. So that's a 1 and is blue. So yeah, that was a very important spot. Let's see. Okay, so we've got a 2 and a 7 and a 9 to place in this box. 2, 7, 9. These aren't the 9, so that's the 9 and is orange. We've got all the blues in this column and the 5, so these two are orange, and in fact are a 6-7 pair. This is a 4, by the way. I'm sure chat has pointed that out a million times. This is a 5-8 pair. That's not a 2. Can place 9 in box 6 now if I look closely. That I can. 9 in box 6 needs to go exactly there. Thank you, Tony. Great to see you again, Tony. 1 in row 4 looks right. Ah, the 1 does look right. So that's a 4 and that's a 1. So that's a 3 and that's a 1. This is a 2 or a 3, but it's not a 3 because of the 3-6 pair, so it's a 2. This is not a 1, 2, or a 3, so it's a 4. That 2 sorts out the 7 in the 2. The 3 in this row has to go here because of the 3-6 pair in this box. So that's a 3, making that a 2. Making this the 7 and this the 2. Oops. This isn't a 2. Welcome back. Welcome back, Megalan. How have you been? You were doing an escape room the other day, right? Was that as enjoyable as it sounds? Let's see. These two digits are... Speedrun the end of the puzzle before doing the coloring? That seems blasphemous. 6, 8. Okay, so in particular, the point is they're both orange. I get it. Okay. So, so these are a 5-7 pair. Okay, so the bet cell, I regret to inform you, is a 5 or a 7. This row is done because it just needs an orange left. In fact, we actually know it's an orange 8. If you want to go fancy with it. 6, 8 in box 6. Ah, yes, this is a 6, 8. So that is an 8, and that's a 6, and that's a 7, and that's a 6. Ah, so the thing on the whispers in this box is a 6. So this is a 1-6 whisper, because the 6 isn't in any of these places. So this is a 3. So that's a 1 and that's a 3. I know how to sort this out. Bear with me. There are 4 oranges already. So this is blue. And this is orange. Okay, so this is the blue 1, 6, and this is the orange 1, 6. We'll pretend I'm doing a 2 to 10th puzzle. Okay, I do need to fit a 7 in row 2. It is an unfortunate fact, but row 2 needs a 7, and the only place it's going is here. I guess also known as row 7 by Sudoku goes there, but whatever. You all like hidden singles better than Sudoku anyway. Okay, so this row needs some stuff to go right. What clue haven't I used yet? Oh, this 1. That's the thing. This 1 is going to sort out everything. So the 3 goes next to the 9, which goes next to the 4, meaning that's the 2 and that's the 7. So the bet cell, and I'm very sorry for this, is a 5. That's a 6, or I guess, sorry. That's orange. And that's blue. So I need another blue in this column, but this cell sees all the blues. So this is blue. Likewise, I need another blue in this column, but this cell sees every blue. So this is blue. This sees every blue and 5, so it's orange. This sees every blue and every orange, so it's 5. So this now sees every blue and 5, so it's orange. So this is uncolored. Okay, so I think we've made it through the tricky part of the puzzle of making sure we don't accidentally finish the coloring before we finish the puzzle. So I think we can now fill in that that's a 2 and that's a 4. I think we can fill in that that's a 3 and that's a 6. Oh, there's a 7. Oh, thank you. Thank you, Ambrose. That was almost a disaster. There was a 7. That poor 7. There we go. Okay, so there we go. Okay, good. Thank you. So that's a 6. That's an 8. That's an 8. That's a 5. That's a 1 and a 3, and a 1 and a 3. And an 8 and a 9 and an 8, and a 6, and an unknowable 9. Very nice puzzle. I like that one a lot. The number of times where it turned out that something was colored and then was immediately known was really impressive. Like there really aren't that many clues in this grid. If you look at this grid, it does not have a ton of clues, and they all had to conspire together to give you exactly the right pieces of information at any given time. But my favorite part of this puzzle was the observation that whatever this cell was, it had to go here and here, so it had to go there in the cage, which was just an amazing spot. That was a hell of a thing. Good night, Daniel Silverstone. I hope you feel better soon. I know you're not feeling super well, but I hope you feel better soon. You did miss what the new setter challenge is, Mega Lamb, but I will give you the short summary, and then I'll do one of your puzzles, which is that the short summary is that the new setter challenge is to set a puzzle, either Sudoku or pencil puzzle, that uses coloring or colors in a way that I have not done before. So whatever you would like. And we're going to do heartbeat after this. So we have this lovely looking grid coming up. Yeah, that was a great puzzle, Lisztes. Very exciting. I'm going to take a short break, but then when we come back, we're going to look at this grid, which is either a heart or a spider, depending on how you look at it. So we'll be back very shortly. Alrighty, welcome back. So this puzzle involves thermo, projected sum, and whatever this line is. I'll need to figure it out by reading the rules. Digits along a thermometer increase from the bulb end. So this is the bulb here. So this digit is smaller than this digit, which is smaller than this digit, and so on down the line. And gray lines without bulbs are palindromes, which read the same forwards and backwards. Okay, so the little inner heart, this is a thermo, and these little splash lines over here, they're thermos. And then this is a palindrome, which means that if I put a 9 here, I have to put a 9 here. And if I then put a 2 here, I have to put a 2 here. And so on all the way around the grid. I think I inspired this puzzle because someone in chat was saying what should they set, and I said someone should set a projected sum thermo puzzle, and so I think that made this happen. So I feel obligated to do this at some point. Clues outside. Okay, and then the clues outside the grid. Okay, I should read this because this is not quite standard projected sums. Okay, so clues outside the grid, sum the digits that fall on some of the given lines. The number of lines contributing to the sum are to be determined by the solver. All or none of the digits on a particular line contribute to the clues given. Not all sums are given. Okay, so for example, this 8 here is either the sum of these two digits, or it is the sum of these two digits. It's certainly not the sum of all of these. Oh, although this one's down here too. Sorry, this is also a line. So it could just be that, well, it can't be that digit's an 8. So it's the sum of these two and this, or just these two, or these two and this, or whatever. Okay, so this is an ambiguous projected sums puzzle. So this should be an interesting ride for all of us. Let's see if we can figure out where we start. So I'm supposed to get 27 here. Let's see, getting to 22 here is not actually all that easy. I'm trying to decide exactly how I want to color this. So within the row, I have to take these two. If I don't take these two, because these two are on the same line, and I either take both of them or I don't take them. That's a good question, actually, Tremkel. Do I have to take both of these? Is this one line or two lines, the thermo in the middle, for purposes of this? Everyone in chat was all over it. I didn't even notice. So okay, so I need to include both of these. So I'm going to promote both of these by giving them a color. So by the palindromicity of this, these two are the same and these two are the same digit. That is the... It looks like it would be 1, but I don't know for sure. So one of these is blue. Interesting for the vertical 8 clue. Wait, is a line either always counted or never counted, or is it just for each clue? Oh, it's constant. Sorry, I thought every clue decided which lines it wanted to count. But if I understand this correctly, and I think now reading it again, I think I do interpret that, every line is either always counted or never counted. Is that right, Megalam? So knowing that I'm counting this line tells me that these cells count towards the 8 clue? Okay. That makes it way, way, way easier for me to figure out what on earth is going on in this puzzle. Okay, so these two cells definitely count towards the 8, because now we've decided this outer heart ring, it definitely counts. So these two count towards the 8, which now means the inner heart ring can't count, because if the inner heart ring counted, that would get us to too many. And so now this cell doesn't count. So this cell does count, and now it doesn't matter because now this is either on both thermos, whether they're the same or different. So this whole heart thermo, it counts because we need it to count in order for this to work. So the way this works is the outer heart counts, the inner heart, 1 or 2 thermos counts. And so I need the sum of these 3 digits to be 22, which means that they're all at least 5. But they could be 5, 8, 9, or what have you. Because I already know the outer line counts by the 22 clue. Because if I don't count the outer line on the 22 clue, I don't get to enough to get to 22 in this row. So it's still a real palindrome. It's just not, just doesn't count towards the projected sum. Okay. Bet cell. That's right. We need a bet cell. I'm going to guess that this is a good bet cell. That is my my prediction. So everyone place your bets now on what digit this will be, or what color it will be colored, because we'll probably be doing a lot of coloring. So I kind of want to give each of these their own color. Let's see. This is going to correspond to that. So this is not blue or yellow. Oh, this could be yellow. That's annoying. Let's see. And this is going to be 1, 2, 3, 4 after blue. 1, 2, 3, 4 after blue. Okay, so yeah, I really don't know about those. Purple 4. Purple 4 has been called. Everyone is going for purple 4. If it turns out to be purple 4, that's going to be quite amazing. I mean, Megalam, you can still bet on what color I end up coloring it, because I don't think your solution guide tells you that. Okay, this column is actually also quite tight in order to get to 22, because now in this column, I'm only summing these 3 digits. I have to get to 22. I definitely have to count... No, sorry, I was going to say something nonsensical. These 3 digits only sum to 9. Okay, so in this column, these 3 cells all count. And they sum to at most 9. So that's pretty huge. So first of all, where is this digit? It is 1, 2, 3, 4. It's 4 after blue. 1, 2, 3, 4. It's there. These 2 are the same digit. That's not super exciting. But this digit is therefore at most 6. So if this is at most 6, this is at most 5, this is at most 4, this is at most 3, we can go ahead and good lift these, which is just the fancy name for filling in all the possibilities on a thermo. So this is not 5 anymore. But this cell is at least 5? Yeah, this cell's at least 5. So actually that puts a lot more pressure, because now these 2 actually, this can't even be anywhere near 4. Because these 2... Oh, Math Pesto has become a fan. Thank you, Math Pesto. Welcome to the windmills. Enjoy all the rights and privileges therein. So now... this digit needs to be a 1 or a 2. Living the good life, exactly. That is a perfect way to put it. So so these digits need to sum to 9. So this is only a 1 or a 2. So let's so in particular, it's not yellow or blue, so we can give it a color. 2, 3, 2, 3, 4. 1, 2, 3, 4. Okay, what color should we give it? First person in chat to name a color. I will give this pair that color. I am being told it has to be a 1. Green. Okay, so it's going to be green, and we're being told it has to be a 1. So if this is 2... no. 2, 3... right. If this were 2, this would have to be a 3, and then this would go 4, 5, and that's not going to work. So this can't be a 2. So so green is 1. Now this being a 2 or a 3, of course, means this isn't a 3. So yeah, these two need to add to 8. So they're either 3 and 5, with this being a 4, or they're 2 and 6, with this being an anything. Let's see, there's a 1 over in one of these two cells. Okay, I bet I can figure out which of these two cells is a 1 by following my palindrome. So, right. This is not a 1, because it goes there. So this is the 1. And it reflects 1, 2, 3, 4, 5 in here on this one. 1, 2, 3, 4, 5. Wait, I've already broken the puzzle. How did I screw this up? Why can't row 3, column 3 be 1? I have no idea. Neither of these two things can be 1, so this is the 1. No clue. No clue whatsoever why I thought column 3 was not going to be the 1. This 22 clue is almost interesting now. Almost, but not quite interesting, because this cell can sneak into it. So this row, actually, that's going to be huge, because now these 3 cells sum to 17, and so these 2 cells sum to 16. They have to be a 7-9 pair. So that's huge. So this is 2 after blue. So 2 after blue is there. So that's also a 7 or a 9. And this is 1 after green. So that's a 7 or a 9. By my my estimation. Okay. So yeah, so that's the 17 done. This 22 still interests me, and I feel like I should be able to do something with it, but I have yet to figure out what that thing is that I'm supposed to be able to do with it. Let's see, this is a 27. Okay, that's kind of interesting. So I need to get to 27, and 2 of these things are really tiny. Like, the absolute maximum that these two sum to is 7. And so if I take those out, I need these 3 cells to sum to at least 20. What's the most this cell could be? 8, 7. I guess the most this cell could be a 7. That's not exciting. Actually, this cell can't be a 7 because it sees a 7-9 pair. So the most this cell can be is 6. Yeah, so... Okay, so I'm being told this cell can't be a 6. If this were a 6, this would be a 5, and now this cell could only be 1, 2, or 3. But it can't be, because it has to be at least 4. In fact, it has to be at least 5. So yeah, this can't be 6. Okay. So let's write this out. Okay, 1, 2, 3, 5 is the minimum here. So this needs to be at least 5, but I believe it could be 6, 7, or 8. This, I believe, could be 3, 4, 5, 6. It can't actually be 7 because of the 7s looking at it from the 7, 9 pair. So this is 2, 3, 4, 5. And yeah, this is still 1, 2 from before. I think I did that correctly. So the 22 in column 5, Eric is suggesting we look at. Yeah, the similar, it puts pressure on the same digits, I guess, that we already have. I guess it actually pushes yellow down, doesn't it? Because if this were a 9, it would be too big. Oops. Okay, so this can't be a 9. In fact, it can't be a 7, 8, or 9, because if this were a 7, 8, or 9, I would complete my triple, and then it would sum to at least 24. So this can only actually be 5 or 6. And now, if this is 5 or 6, if I look in this row across the 22 clue, that's very clever setting and very clever observation. So now I need this to sum to at least 16. These two need to sum to at least 16. And so that means this can't be 5 or 6 for sure. These are from 7, 8, 9. For some reasons, only one of them can be a 7. So this is 7, 8, 9. Carl has a beautiful point. Blue sees a 7, 9 pair. Because these are, remember, these are a 7, 9 pair. And so this is an 8. So blue is 8. And we get to do an 8 dance. Thank you, Zach. You can do your 8 dance now. His 8 dance looks a little like penguin karate. Do, 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 do. 8 dance. Apparently the ones did not earn a digit dance. It is sometimes ineffable what digits earn digit dances. So now this has to be a 9, because if this was a 7, I would not get there. So this digit's a 9. And now I can probably figure out what this is with the power of math. So with the power of math, I need 17. This needs to be a 5. So yellow is 5. Let's see, that 9 looks up here to that 7, which makes that a 9. And so now that means that's a 9 and that's a 7 by the power of palindromicity. So now if I ask where the 9 goes in this row, one of these is a 9. That's certainly not a 9 because it would put a 9 there. Let's see, if this was a 9, it would put a 9 there, so that's not a 9 either. So this is a 9. Just by various, palindrome things. So this column now, we can maybe figure out 5 plus 9 plus 7, 16, 21. So this needs to be a 1, as several people in chat have pointed out. And more importantly, it gets to be green. Oh, so now I'm told this thermo has to count. Let's see, for the column 3 clue. So in column 3, we count this cell, and this cell, and this cell. This isn't a 5 anymore, by the way. this cell, and this cell, and this cell. And there's no way that those sum to 22, so we need this cell to count. And it actually has to be pretty big, right? Because the absolute maximum of these is 5 and 4 is 9, and 8 is 17. And so this needs to be at least a 5. So this is 6, 7, 8, or 9. Was my palindrome logic on 9s wrong? So I knew by Sudoku 9 was in one of these cells. If 9 was here, 9 would also be there. That's broken. If 9 was here... Oh, it's because if 9 was here, 9 would also be here. Ah, you're right. Okay, sorry. You're right. 9 is in one of these two cells. Oh, but there's a 9 up there. So actually, I could rule 9 out of here. I just did it in a dumb way. And this really does work. This can't be a 9, because that would be a 9. Wait, maybe that could be a 9. Do I know that this can't be a 9? No, I don't think so. So one of these choose a 9. I don't know what I was doing. Oh. There's not supposed to be a 9 pencil mark up there. Okay. 9 up here. Yeah, so the 9 up here is in one of a bunch of spots. Okay. 8 in row 5, points out Tristan, or blue in row 5, as we say in this house. Blue in row 5 goes here. Which is very useful. Let's see, this is supposed to be 23 now. Sorry, David. Only so much I could do, but I'll try and help you out next time. Okay, so in this column, we're summing this cell, this cell, this cell, and this cell to get 23. Who knows? The box 2 and 3 9s are approximately placed, I am being told. So the box 2 9 is just outright placed, right? The box 2 9 can only go here, I think. Which I think probably is the center of this palindrome, so it probably doesn't do anything. And then one of these two is a 9. Let's see, 7 in box 1. Let's see if this were a 7. 1, 2, 3, 4, 5. Yeah, this can't be a 7. So 7 in box 1 can only go here, which puts a 7 here by the palindrome. I did look at the 23 clue in column 6. Remember, it includes this cell. That does finish the 8 in column 8. So this is actually not included. Okay. So this thermo's not included. So the 20 clue we can do now. So the 20 clue now includes these 3 cells, which makes this a 5 in order to make the 20 work. So this isn't a 5. And is yellow. Let's not forget it's yellow. Priorities. Enjoy your dinner, David. Thanks for stopping by, and thank you for your donations and support as always. So now yellow in this box has to go here, and incidentally is 5. So now yellow in this box has to go here. And now that's on a thermo, a palindrome. So I get to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is yellow. So one of these is yellow. I don't know which one yet. Okay, so now do I know what's going on with this 23 clue? I don't think I do because of this wiggly piece. So 9 and 8 is 17. So I need these two cells to sum to 6. Well, I know at least this can't be a 3. Oh, I guess the point is these need to be a 2-4 pair in order to sum to 6. Because one of them is 2-4, and so they both need to be 2-4. Let's see, 9 sum in column 4 is resolved. So we've got a 1, a 2, or a 3, and a 5. So that's got to be a 3 there. And so that makes that a 4 by thermo. Let's see. 11 clue in row 7. Very smart to Kurobon. Because this thermo we've shown doesn't count. This thermo doesn't count. So we're just saying these two cells sum to 11. So this can't be a 2. So this can't be a 4. It has to be a 2, with that being a 9, making that a 4. Very good spot. That 2 does reflect across the palindrome. Thank you, Trumkle. I was going to completely forget about that part. Let's see. It seems a good time to give these a color. No, I can't quite give them a color, can I? That 9 looks up. Yes, that 9 looks up here, makes that a 9, which then through the medium of the palindrome makes that a 9. Let's see. Do I know that this thing, whatever it is, do I know that it is not any of the digits I already have colored? It is not 5 or 8. I sadly don't think I know it's not 8. It seems like it might be 8. Let's see. Are there anywhere else? Is there anywhere I can color that I know is not anything? This cell. I can color this cell. So this cell I will color for you. Let's see. This is 1, 2, 3, 4 along. 1, 2, 3, 4 along. Okay, so this can be orange. So let's see. We can mark it for candidates. It is not 1. It's not 2. I think it could be 3. It's not 4. It's not 5. It could be 6. It's not 7. It's not 8, and it's not 9. So orange is actually only 3 or 6. Oh, the bet cell has been placed. The bet cell is 5 and is yellow. Sorry to all of you people who guessed purple 4. When purple is next to yellow and 5 is next to 4, you were very close on both bets. Sadly, we can't win them all, I suppose. These digits are a 1, not a 2, a 3, not a 4 or 5, a 6, and a 7, not an 8. So that's not a 7. That's not a 7. In fact, actually, the 7 is placed. It goes there. Alrighty. 7 is in one of these two cells. These are a 1, 3, 6 triple, meaning that is also from 1, 3, 6. Oops, center. And that can't be 1, so that can't be 1, so that can't be 1. So that gives us a 3, 6 pair in this column, which means the things left in the column are 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, that's not a 1. I can go that far. That's not a 2. That's not a 1 or a 9 or a 4. Weird naked single 2. But I'll take it. So this row is missing. We've got 1, 2, 3, 4, 5. We need a 6 and an 8. And so this cell is going to get reflected to there. So this is going to be a 6 or an 8. And this cell is 1, 2, 3, 4, 5, 6 in. 1, 2, 3, 4, 5, 6 in. It's also going to go there. Okay, so this is a 6-8 pair by by magic. Let's see. Should I look at how my sums are doing? Like this sum looks helpful. So 9 and 2 and what is 17? The answer is 6. So that makes orange a 3. So that makes this a 6. Makes these not 6. In fact, this one's not 3 either, so it's a green 1. Makes that a 6. Makes that an orange 3. Let's see. Okay, so placing that 6 also made that a 6. And making that a 6 also makes that an 8, which makes it blue. Makes that a 6. Some of chat is excited by the fact that I was able to add to 17. It's about the edge of my abilities, but we'll call it good. That 6 makes that a 6, which makes that a blue. Okay, and that blue is that blue. Okay. This box is only missing a 2 and a something. 4, 5, 2 and a 6. And I know the order, so that's a 2. That's a 6. And that being a 6 must place something somewhere, right? Or is this the midpoint? Oh, I think this is the midpoint. This is the midpoint. Okay, so this does not do anything, is the moral of the story. But this digit, I know what it is. It's a... I say that, of course. It's a 3. This row is missing a 2 and a 4. And I know the order. That's the 4. That's the 2. This box is missing a 5 and an 8. I missed a 5. Did I miss yellowing a 5? I'm sorry. I didn't see it. Where did I miss yellowing a 5? Over here, I've got a 3 to place. Well, the 3 is over here and is orange. And then 2, 3, 4 to place here. This isn't a 6 or an 8 or a 9, so this is a 7. Let's see. Do I have more addition that I should be doing, or am I just... I might actually be basically done with addition. Let's see. This isn't a 9. Let's see. I think a number of people have suggested I fill in candidates in box 9, so let's do that. 2, 3, 4, 5, 6, 7. These aren't 6. These aren't 3. These aren't 7. That one's not 6 either. So this is a 2, 3 pair. So that one is 7. That one is 6. That one is 2. And that one is orange. So these two digits are now known. They are a 1 and a something else. And a 7. And I know the order. So that's the green. And that's the 7. So that's a 7 just by Sudoku. Let's see. These digits. Oh, actually, I just know what this digit is. This just is a 2 by the palindrome, or by the row, or by whatever. These cells are a 1. Oh, I know where the green is. The green is here. We'll make it the right color eventually. That's a 1. 2, 3, and then this is a 4. Coloring isn't about need. Let's see. It must be said. Okay. These digits, I'm going to go ahead and fill in. 2, 3, 4, 5, 6, 7, 8. 2, 5, and 8. This one's not a 5. That one's not a 5. I did not do this one's not a 5. That one's not a 5 very well. This one's not a 5. This one's not a 5. So this is a 5. It's yellow. So this is an 8, and it's blue. We're getting colors all over the place. Life is really picking up. The 5 in this column has to go here. So these two cells are a 3 and something else. Well, the 3 is the one that has to go here. Oh, it is orange. This 3 is also orange. Whoops. Sorry about that. And so this is also an orange 3. So I'm sorry that 6 didn't get a color in this puzzle. I was never able to pin down that something wasn't one of the other colors. Let's see. This digit needs to be something. I think it's a 2, which makes this blue. And this a 2 and that an 8. Let's see. These digits I can go ahead and fill in. 2, 3, 4, 5, 6, 7, 8, 9 is what they are. That one's not an 8. That one's not a 9. So this is a 1, 4, 9. Oh, this is a 1, 4, or 9 by the row, but by the column, I probably know what it is. There's one more orange. Is there really? Oh, there is one more orange. Ooh. Nice slick save on that orange. By the column, this appears to be a 4, which makes that a 9 and that a green, which is going to place a green here by Sudoku. So that's a 4. That's a 9. That's a 1. That's a 1. That's an 8, which is blue. So this is a 4. Oops. So let's see. So I should have 4 colors in every box, and I don't have 4 colors here yet, which is suggestive that this is supposed to be an 8. I should have 4 colors in every row, and I do have 4 colors in this row. Let's see. 2, 3, 4, 5. This is a 6. Nice. Only 3,000 minutes. A little more. Not bad. Yeah, that was a cute puzzle. I've not seen this figure out which projected sum lines to count and which ones not before. That's an interesting twist to say, okay, well, you're going to count some clues and not others. And the fact that they're all very long, so figuring out whether they counted was really neat. Yes, what happened is I had this puzzle up to do like 3 streams ago or something, and then Megalam messaged and said, hey, I'm going to do an escape room today, so I'm probably not going to be there, so if you could put off doing my puzzles, that would be cool. So I did. And so therefore, we ended up having a puzzle that apparently was open in my browser for a while. I didn't really mean to start the timer. That part was just CTC being CTC, if you will, but that is the story of how we ended up doing a 3,000 minute puzzle. Alrighty, I'm going to take a quick break to stretch. And then when we come back, Not quite sure exactly what we're going to do just yet, but we'll do something. So I'll see you shortly, and when I do, we'll do something. Hello, everyone. Back with what we have next up is a puzzle by KNT. KNT makes a bunch of really amazing chaos construction type puzzles, usually. I don't get to do nearly as many of their puzzles as I would like, because most of their puzzles are quite difficult and quite long, so I have to pick and choose. But this one was based on a puzzle that I made, actually. This is a puzzle that is somewhat inspired by Bounce, but then combined with Nurikabe. So let me try and explain the rules as I understand them. We need to shade cells in two different colors. So we have blue and green. And so the blue cells, that's the C, that is the stuff that's not part of land, and so that needs to all be connected. And the blue is not allowed to have any 2x2 blocks. And then the green is then sort of making up islands. Digits on an island can't repeat, and every island has to contain its size as a digit somewhere. So if I make an island of size 7, somewhere in those 7 cells, the digit 7 has to appear. Numbers outside the grid give the sum of island cells in that row or column. And then, so that is sort of like projected sums that we did in the last puzzle. And a digit in a circle tells you the total number of corners and edges that are part of a boundary of an island. So if, let's just draw in an island, if you imagine that this is the island, then this circle, if you look at it, it uses all 4 corners and it uses 2 edges. So this circle would have to contain a 6. Likewise, this one, if you look at it, it uses 4 corners and it uses 3 of the edges. So this would have to contain a 7. Okay. I'm happy to see that not all circles are given. Which is my ultimate fear in the world, is to do a puzzle where all circles are given. Okay, so first things first. There's a clarification on the LMD page. Let me click the link to the LMD page. Let's see, where is the clarification? Oh, here's the 6x6 example. Oh, okay, so if you'd like to see an example, this is probably helpful if you have not thought about this constraint before. So you can see these things, for example. All right. Let's go back to this if I can find it. Okay. The first thing I see here, because this is literally the first step in Bounce, is that none of these can be land, because the total land cells in this row sum to 1, meaning there's only 1 land cell and it contains a 1. Well, let's just imagine that this was that cell. Well, then what digit would have to go in this circle? Well, then the digit that went in this circle would have to be a 7, but it's also a 1, and it can't work like that. So actually, all of these I can blue. Now, I'm going to need to keep repeating to myself that blue is water and green is land, because when I set the previous version of this puzzle, I used green to mean nothing and purple to mean land, but I'm going to try and keep to the sentiment that is being used here. Okay, so now I need to make sure that all of these are positive, and none of them are 1. And if I make this cell unshaded, or if I make this cell not island, it's a problem. So if I make this cell not island, what's this cell going to be? Well, it's either going to be a 0, which is a huge problem, or it's going to be a 1, which is an equally big problem. So this has to be land, which immediately makes this digit a 3 before I even go any further. So we get to have our 3 dance. Yes, if there is a mod available, Tristan or whatever, we have some bots going a little bit wonky in the chat. It would be good for someone to delete it. But meanwhile, the thing here, a 4 on land can look like lots of things. But just to answer your question before we do the official digit dance, if the 4 was on land, it might look, for example, like this, with these being water and that being water. That would be a 4 on land, right? Oh, no, sorry, that would not be a 4 on land, sorry. But we don't actually know whether the 4 is on land or not yet. We have not gotten there. Yeah, let's let you bet 5 on this cell. Yeah, I wasn't counting the outside of the cell. I realize. But a 4 on land could look like, it might not be possible on the outside of the board. I don't know. We'll get there. But it's pretty easy to have a 4 on the inside if it's plus shaped. Anyway, now, sorry, 3 dance. We've got to do the 3 dance. 3 dance. 3 dance. Alrighty. So we have an equally big problem if we make this land. Because now if this is land, now this is also a 3. So this is water. So this comes down here. Now, I don't think I know anything like an island has to have size bigger than 1. All I think I know is that digits on an island, blah, blah, blah. I don't think I know that. This has to be green, though, because if this is not green, then this becomes a 1, which is not allowed. Or avoid a 2x2, but I liked my way better, but whatever way you like. Mean that this is a 2. And now this, if I am not careful, is going to be a 3. So it needs to be more than 3, which means this cell needs to be land. Yeah, you could do it with the ocean doesn't have 2x2 rule, but you also can do it with the fact that you can't repeat the circle, which I just happen to like better. But the ocean doesn't have 2x2 is definitely the way you should do it. But if this isn't land, this is a 3 again, so this is land. Oh, which means it's a 1. And the rest of this is thingy. Okay. Now the water would be trapped if the water didn't continue, so the water has to go here. This digit here is at least as big as 4, but it's already at least as big as 5. Yes. Ranks correctly points out I can just fill in that this is a 5, which is a very fair point. So this is wise. This digit here has to be bigger than 3, because it already sees 3, but it also sees 4 and 5. So this digit actually needs to be a 6 or a 7. Those are the only options for this digit. So I think I can probably force this if I need to, but let me write in I used the given 4 here, by the way. That was why I was looking at that. Let's see. Sorry. Do I want to look at something else first? Okay, I think I do want to look at this. So, could this be a 7? And I think the answer is no. No, it can be a 7. If it's a 7, it joins this island, but that's a problem. So, yeah, if this is a 7, the only way that works is if all of the things around it are different than it. And so if this were water and a 7, well, that's just not possible because I'm never using this edge or that edge. So it's not water. If this was land and a 7, well, then I need to use everything except this side. But now this is a 2-size island, which would need a 2 here, but it can't have it. So this isn't a 7. It's a 6. So that's cool. Now this has to be a 7, because it's already at least 5. But the biggest one of these can ever be... I guess it could be 8, actually, in this puzzle. No, it can't be 8. Because if it were an 8, then it would be an island of size 1, and it would need to have a 1 in it, too. So this is a 7. And structurally, that means the land needs to look like this. That has to be water. The land has to continue to grow. Because 7 is not done. By the way, Tristan, or some mod, you can delete that. Please and thank you. So... Okay, so this probably has now got to be a 4, right? It's not a 1 in any event. So it could be 4. It can't be 5, 6, 7, and it's certainly not 8. So yeah, so this is a 4, which does actually force the pattern of this to work. Why didn't row 2, column 3 grow down? Couldn't the 7 have gone down instead? Okay, let's. Okay, what are we talking about? How far back are we talking? Was my thing wrong? Oops, why is forward not working anymore? Row 2, column 3. Oh, okay, so, to where I filled in that was a 6 and that was a 7. Okay. So the question is, could this go down? Maybe this could go down. Okay, yeah, yeah, I think you're right. I think this could come down. I still think this has to be a 4, though. Because what else is it going to be? It's already more than that. And then once this is a 4... But this being a 4 forces exactly what I said before. For exactly the reason I said it before, doesn't it? Because now I'm back exactly where I was before. I think I'm good, though. Yeah, the box is a 1. I'm mostly just trying to make sure chat is happy, because chat was very unhappy, but I just did exactly the same thing I did before chat got unhappy. So I'm making sure. The 1 means this can't stop. So it has to go down at least to there. Let's see. Okay. Okay, chat is happy. Chat tells me chat is happy. Okay. So... So this is at least a 3. Probably bigger. I actually need a good bit of land in here, actually, because of this streak of blue. And I have to avoid blue 2x2s. Okay, so this is already, I should keep in mind, this is already counting the coast. So this is already at 4. So this needs to be a 5 or a 7. Those are the only options numerically for this. If this was a 7, it would need to be this sort of size 2 pattern that we've previously discussed, which seems okay. If this is a 5, let's see, it's already got 3, 4. If this is a 5, it has to look like that. It's already got more than 2 because of the side, Garion. The boundary on the edge of the board is already contributing 2 corners and an edge. And the fact that it's an island tells me it's definitely got that. Oh, let's see. I can shrink my face a bit. Oops. Oh, actually, I'm not sure even with that, I can actually get you to be able to see this. The digits in the circle tell you the combined number of corner cells and edge cells that are part of an island. But yeah, I think probably I should just make my camera that size and just answer it when people come in. There is a 4 down here. I can say that much. Oops, not a 6. There's a 4. Oh, I should fill in what these digits are. That's probably a good idea. Let's see. 1, 2, 3, 4, 5, 6, 7. These are an 8 and a 9. So if this is a 7, it is an island of size 2. Let me see why that breaks. I don't think I see why an island of size 2 necessarily breaks. I agree 7 makes it an island of size 2. Part of a boundary of an island. Yes, part of a boundary of an island. So this digit has to be bigger than 3. And the way I know that is because it sees land on one side and water on the other. So this is already bigger than 3. This is already at least as big as 3. But then it can't be 4. 5, 6, 7, maybe? Okay. Let's see. Maybe Ranks is correct that I should ask how in the world can this be a 4? Let's see. I'm not sure I can quite... Okay, so let's just briefly draw in. If this is a 7, it looks like that. This is currently at 3, and then we put an island over here, and then the 4 is satisfied. So that's the way the 4 works in the world that this is a 7. The world where this is a 5... Oh, well, here's an interesting point. In both the world where this is a 7 and the world where this is a 5, this is blue. No, sorry, that's not true. Don't listen to me. In the world where this is a 5, this is green. And this is green. Okay, what if this 4 is green? Can we get to 4 if this 4 is green? Yes. But the 4, if it's green, would see 3 over here, and so I would need to see something like that shape for the land. So the 4 I have to almost surround by land in order to make it, if it is land, it has to be something like that for it to work. Yeah, the 5, because 5 is this 5 is currently, if this digit is 5, it's already seeing 1, 2, 3, and it's seeing this corner. So it would need to see just this corner as well. So if this is a 5, then this needs to be then this is land and this is sea. So let's just draw in the 5 just so that we can make sure that we understand what's going on. So if this is a 5, I think this is ocean and this is land and this is land. And nope, I didn't do that right. Sorry. This is land and this is land and this is sea. That's the correct way to do this. So if you look at the 5, if this would be a 5 in this situation, because we see 1, 2, 3 down the side, 2 corners, and then we see these 2. So we see all 4 corners, and then we see well, I wasn't saying whether the 4 is broken or not. I was just trying to make sure people understood how we were counting to 5. Because we see 1, 2, 3 here, and then we see these 2 corners. So there's 1 edge, 4 corners. I'm not trying to do a perverse look ahead. I'm just trying to make sure, because lots of questions in chat about what exactly these clues are counting. Okay. But I might actually have to draw in all of these. Okay. So the constructor is telling me they do not consider that look ahead. It's definitely significantly into my threshold of look ahead, but I will accept it if the constructor accepts it. So in the world where this is 7, we know what the world looks like. In the world where this is 5, we can go through this much, and then we have to ask what happens with the 4. And now the 4 is seeing... Well, now the 4 is just broken, because the 4 sees 3 edges here and 3 edges here. So that at least doesn't work. So then the question is there a different way to fill in the 5? Which I don't think there is, right? Because the 5 is already seeing 4 things. So if this is a 5, it can only see one more thing, which means it can only see this corner, and as the 5th thing, which would mean that yes, then the 4 would be surrounded in both sides. So this does have to be a 7, and so that's a 2. And so this ends up looking like that. This isn't a 7, and is water. This is water. It's seeing 3 already, so that's water, and that's water. And that's land. Oh boy, we're popular today with the bots. Okay, this is no longer able to be 3 because it already is going to see more than 3 because of this corner up here. So this is not a 3. Sorry, not a 3. Let's see. We remember that we need to total to 19. Currently, we total to 10. So we get either 1 or 2 more land cells here that need to total to 9. Down here, we need some land cells to total to something. Uh, this does need to see more. So one of these two is land, maybe both. I guess I also know that from the no 2x2 rule. This cell is at least 4 also. So I think this is actually also only a 5 or a 6, right? This can't get to 7 because it already does not have a border there. It doesn't have a border there. So yeah, this is at most 6. So this is a 5-6 pair, actually. So oh, and so the point is now with the... I can't add to 9 in 2 or 3? Oh, in column 1. Sorry. I'm got confused in what columns I was thinking about. Let's just look at this column. What's left in it? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the point is, one of these remaining cells needs to get me to 19, and it has to be a lone 9. Good observation to whoever first said that, and to whoever then understood it. I agree, yeah. So this column, in particular, this column needs an 8 and a 9, none of which can come from down here. So this is an 8 or a 9 as well. So these digits we actually know. These are 1, not 2, 3, not 4, 5, 6, 7. These are 1, 3, 7. All of which together add to 11, in fact. So that is all 11. And then these digits are 2, 3, 4, 5, 6, 7, 8, 9. Okay, 2, 4, 6. Okay. So this is... I guess I don't know that this is definitely not a 1 yet. I probably will very, very shortly if I think about this. So I can put that down there. It's definitely not a 7 because neither the top nor the bottom is in it. So I agree that it's definitely not a 7. Not all circles are necessarily given. But yeah, this would be a 1 if all of these were green. Oh, but not all of these are green. That's the point. Only one of these is green because it's the green 9. Thank you. Sorry, chat was trying to get me there, and I was being a very difficult horse. This can't be the 9 because then there'll be a water cell down here. Okay, Sayori was very patient with me there and got me there. So that is the 9. This is blue. It's not a 9. And so that is going to get me that this is now not, it's not 1. It has to be a 3. And now if that's a 3, that means all of this is green. These aren't 3. This is a very smooth puzzle so far, by the way. This has not been at all persnickety so far. So these cells are 1, 2, 3, 4, 5, 6, 7, 8, 9. Jaleb points out this just geometrically can't be a 2. I agree. It's not possible to for this to not include. In fact, actually, and now the fact that this is a 4 or a 6 means this is definitely water. Because if this wasn't water, then I would be capped at 1. So this is water. Oh, in fact, this just can't get to 6. So this is a 4, which means that this needs to be land as well in order for this to be a 4. Right? Did I do that right? No, one moment. I did not do that right. Sorry. Sorry, no, I'm counting this completely wrong. Don't listen to me. There's 3 down there. Sorry, I did not say that smartly. This is already at 3. And so either something comes down up here, making this land, or this is land, in which case then this becomes... Actually, wait, this being land doesn't work, does it? Yeah, I was just checking that. I don't think this can be a 6. So the land water, so this being land and this being water, that's fine. That makes this a 4. If this is water, now this is at 5, but it's not getting any more. So this can't be water. This is land. But 6 now. It can only ever possibly get to 4. So this is make that a 4. This needs to be water. Okay, now this only has a handful of options. This is only 5 or 8. Oh, sorry. Apparently I disappeared briefly. Am I back? Did I? Let's see. Let me see. Does my thing say I'm dropping frames? It does not think I'm dropping frames. Unknown. But at least I'm back. So if this is green, it's a 5 or an 8. If this is green, it's a 5 or an 8. Can I rule out the possibility that this is a green 5 or 8? Well, if this was green, it would have water here and here. Yeah, if this were green, it would be a 7. So it's not green. Just because you would be forced to put water here and here, which makes it a peninsula, which makes it a 7. So this can't be green. This is blue. Yeah, 8 can't go in circles in this puzzle, I don't believe. Yeah, 8 can't go in circles in this puzzle. So... oh, I am being told I have an 18. I have a 19 clue in row 9 that I had not considered. So if I make this green, then what does that do? That makes this sum to 5, 8 plus 9. That's already way too big. So that actually already is enough to rule out that possibility. So that's blue. These sum to 13 already. So I need, and these sum to at least 6. So actually, wait. Didn't I just break the puzzle? Yeah, I broke the puzzle. Because this is broken already. Oh, no, it's not. It needs to take this cell. Okay. Sorry. Minimums. Yes, this needs to be a 5 and a 1, and the rest of this is blue. Sorry, not the rest of that. The rest of this is blue. But this island does not contain its size, so it has to grow. Which means it has to take this cell. This cell has to be an 8. This island is donezo, meaning that these are blue. meaning that I probably know what this is. This is a 6. So this had better be a 5. And it is. Good. Yeah, I'm not allowed to repeat digits in an island. Which makes that a 9 and that an 8 and that a 9. Makes these not 8 or 9. They are 1 or 3. This is 3, 4, or 6. Depending on exactly where exactly how the land sort of goes around it. Oh no, it can't be 3. If this is 3, we put too much blue. We make a 2x2 of blue. So this can't be 3, because if this is 3, that would mean I'd have to put blue here, here, and here. So this can't be 3, actually. This is only 4 or 6. If this were 4, would that require a 2x2? I think you're right, actually. I think if this is 4, it also creates a 2x2, because if this is 4, that means I only get 1 land cell in these. So I think this is a 6, actually. So that's a 2 and that's a 6. And the way that works is to put a land here. Okay, so now this digit is under some pressure, so it sees 1. So I'm just doing Sudoku first. So it sees 1. It doesn't see 2, 3, 4, but it sees 5, 6, 7, and it can never be an 8 or a 9 for that matter. So this is only allowed to see 2, 3, or 4. Oh, and this is under similar amounts of pressure. So it is also not a 5, 6, 7, or 8. So this is also a 2, 3, or 4 for the same reason. So let's think carefully about that. The world where this is a 4, it would look like that shape. It already sees 3. This cell? It sees this one. Oh, it sees that one and that one. And this one. Okay, yeah, it does see 3 already. Okay, I agree. Okay. So, on the same page now, I agree. It sees 3 corners currently. So, these are both land, is the punchline, no matter what. Because if I make one of these water, this already goes over. Because if I make one of these water, that adds an edge and a corner. So these are both land, regardless. So now water needs to get out. So this needs to be water because the water needs to be connected. If this goes out, it merges with this. And so it would become a 3 in that instance. Otherwise, this is a 1 because it ends here. Row 5, column 4 sees 2 already. Right. If this is a 2, then we make a bunch of 2x2s. Okay, that's a good point. Okay, yeah, so this is another one where the... if this was a 2, we would put a land there, and that's fine. We'd have to put all this water, except now we've made too much water. Which, yes, gives us a 3-4 pair. So let's see. Let's write out the rest of this column. 2, 3, 4, 5, 6, 7, 8, 9. This is not a 9. This is not a 2 or a 9. Oh, this isn't a 7 either. This isn't an 8. I was thinking there was going to be a Sudoku thing with this island and taking this cell, but I don't think there is, at least not immediately. Is there any world where this is land, though? Yeah, I guess this can be land if these are both water. No, that doesn't work. If this is land, this already sees 4. So that means I can't put any more land over here. So this can never be land, right? I think this is always water. For purposes of this cell. Because I think if this is land, I think it makes this too big, or makes both of these water, neither of which works. So I think this is always water. Which makes this a 1, this a 3, this a 4, this a 3. Which makes this green. And makes these 2 green, because I can't see this edge ever. Makes this blue. Okay, so that gives us a whole lot of stuff, I believe. It's probably right. Maybe. Felt reasonably good to me, I think. Okay, so this digit can't be very large, because it already does not use these 3 edges. So that means it's at most 5. It doesn't use this corner either. So this digit is at most 4, but it's not a 1 or a 3 or a 4. So this digit's a 2. And so that means this is land automatically. One of these is land and one of these is sea. This is an 8. So that's a 7. This is not a 7. That's not a 7. Or an 8. Good point from Sayori about... I have a 16 clue here. I'm not very good at noticing my clues. So I need 6 more. So I think I could do... I was wondering about 1, 2, 3. So I'm either doing 1, 2, 3 or 1, 5 in here. So this is from 1, 2, 3, 5. It's not a 2. I was just trying to convince myself that it could not be 1, 2, 3. But K and T seems to believe it could be, so I'm going to allow that possibility. Okay, so these digits only have a few options. They're not 1, 2, 3. They could be 4, 5, 6. They're not 7, 8. They could be 9. This one's not 4 or 6 or 9, so that one is a 5, just a naked single. These aren't 5. This one's not a 9. And I do know one of these is land. I just don't know which one. Let's see, how big is this now? 1, 2, 3, 4, 5, 6, 7, 8. Oh, the last land cell is here. It's in one of these, so this is always water. I think Carl saw that because the size got larger than it was able to be otherwise. So these are from 1, not 2, 3, not 4, 5, 6, 7. So these are from 1, 3, 7. This is never a 1. So this always has to be a 3 or a 7. 7 seems very unlikely. 7 would involve a land here and a land here, which is not possible. 7 would require lands in both of these, but we know one of these is land, so that land would connect to a region that already has 9 cells. So that's a 3. So these aren't 3. Oh, did I picture that badly? Oh, it might be a 7 going this way. Sorry, it might be that these two are land, say, and then the water comes out this way. Sorry, you're right. There's another option that I was not considering. 1, 2, 3, 4, 5, 6, 7, 8, 9 go up here. These aren't 7. So I don't know anything at all about those. So both this being 3 and this being 7 are incredibly ridiculous. If this is 3, it means I need to create no more things. That means I need to make all of these water. But I also, yeah, if this is 3, it creates too much water. Because if this is 3, I already see 3 here. So that's water, that's water, that's water, that's water. But now, because of the corners, that's water and that's water. Okay, so this actually is 7. Okay, so now I have to think carefully about this. So one of these is land, and then a water cell. And then this is going to diagonally touch, because then there's going to be... Okay, so one of the consequences of this is always land. Because if this was the water, then these would both be land, and the thing I said before would be true. So this is not water, it's land. But I don't know yet which way that goes, I don't think. Maybe if I think very, very hard about it, I'll figure it out. Let's see. Sayori says row 4, column 5 is a 6. I do see why, because there's a 4 in the box. That's why. So these aren't 6. I was like, where on the island is there already a 4? But correct, completely correct. Okay, these digits are 3, 4, 5, 6, 7, 8. 3, 4, 5, 8. This is not a 5. I can at least confirm that much. It's not a 4 either. So this cell can't join this island because it can only be a 3 or an 8. Beautiful, beautiful. So this is water. Now, in order to keep this a 2, this needs to be land, which makes it the last cell of the land. Which means this isn't a 6. This is water. Which makes this land. this is land to avoid a 2x2. These are not 4, 9, of course. So that's a 7 and that's a 6. These digits are doing... it did nearly happen that I did extreme geometric analysis before doing Sudoku, but I did eventually get there. 2, 3, 4, 5, 6, 7, 8, 9. That's too many digits. Oh, there's not a 9. The 9's already over there. Okay. So this goes here and here. There's a border here. Okay. So this number's already bigger than that. So it's not 3 or 4. It's already 5. And it can't be 8. So it is 5. So no 5s there. 3, 4, 8, triple. Okay, so if this is a 5, that means I can't see a border on any of these sides, so these are all land. The water in box 3 now has to connect, so that's going to give us a lot of water. Water, water, water everywhere, or something. Coming around the bend like that. Go back to the 5. So the 5, oops, sorry. The 5 is already done, so I can't add anything else. So that's why I added these in. Why is my shortcut for forward not working anymore? Okay, something is broken in Sudoku Pad. I don't know what it is, but undo and redo used to work, and they no longer work. So anyway, the 5 forces these to all go like that, which then forces the water to come down like that. Oh, this has to be water because it has to get out. This little inlet here has to connect to the ocean. So let's see. So this can't be a 5 because it's on the island. That can't be a 5 because it sees a 5. So this is a 5. Thank you, Garion. Let's see. This is a 1-3 pair. This is a 2-6 pair. There's more boundary here. More boundary here. The green Stradlin box. The green Stradlin box has to grow because it can't have a 2 in either position. Good point to Tallcat. So one of these is green. So one of these many cells is green. Let's see. If this were green, it'd be weird, but I think would be okay with these rules, technically. Let's see. I think I'm probably supposed to do very aggressive Sudoku at this point. This is a 5. Let's see. So let's write in the rest of these cells. 1, 2, 3, 4, 5, 6, 7, 8, 9. These aren't 3. That's not 8. It didn't go as well as I hoped. I'm going to be honest. No aggressive Sudoku is needed. Oh, I could maybe look, for example, at my clues, because I keep forgetting that there are clues outside the grid. So, for example, this being a 5 actually means I need a 1 on land somewhere in this row, and that's all the land I get. I do need a 3 or a 1 and a 2 down here. So if it was a lone 3, it would have to go there exactly. And I need a 1 over here somewhere to finish off this. Is there a checkerboarding thing? I don't think so. Row 7, column 9. Pencil mark a 1, 2, 3 in row 7, column 9. Right, you can. Very nice, tall cat. So this digit can only be a 1 or a 3, which is going to give us a pair. And the reason for that is that in this column, there's either a lone highlighted 3, which is there, or there is a 1-2 pair that is green, which would be there and there. So this is always a 1 or a 3, which gives us a 1-3 pair, which means that's not a 3. Very good, tall cat. It's also green. Right, it's also green, even more importantly, for exactly the same reason. Okay. This can't be green now, because that would isolate this bay over here. So this is blue. Is blue. So one of these two cells is a 1 and is green. Let's see. Do I want to pencil mark all of this? Kind of. Let's see. Water has to get out. Where, Eric? Row 7, column 6 candidates. That is a reasonable place to look. So let's just go ahead and do 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Let's look at what this can be. So this can't be 5. It certainly can't be 8 or 9. So it can only be 1, 3, or 4. The world where it's 1 would require too much land, because the world where this is 1 would require land in every direction, which would isolate the water. So this is not 1. This is only 3 or 4. Let's see. Can I clean up any of the rest of these at all? Hopefully. This isn't a 5. This isn't a 5 either. Oh, this also has a box, but it doesn't see anything in the box. So let's see. What are the commonalities if this is a 3 or a 4? I think if this is land at all, it creates way too much land. Because as soon as this is land, I only get one water cell around it. But I'm not quite sure. I'm not quite sure about that. But I think this is going to have to be water. Is I think what's going to happen here. Should I look at what happens if this is a 1 and a 2? Because if this is a 1 and a 2... No, maybe I look at what happens if this is a 3. Because if this is a 3, then this is water. So this goes out this way. It needs to grab a 2 if it wants to stop, but it can't because there's a 2 already. So it needs to keep going. It needs to grab either that cell or that cell next. I don't know. That feels messy. Let's see, if this is a 3, it makes this a 1 because it goes 3 and then an 8 up here. See, 3's in box 5. We're being suggested to do some Sudoku. Ah, yes, that is very wise. Okay. Afraid not with the score of the day. 3 in box 5 only goes in one of these two cells, so this is a 4, and we don't have to think about it anymore. So these are not 4. So that's a 9. And that's a 4. So that being a 9 means these aren't 9. That's not a 2 either. This column, what is this column missing? 1, we've got a 2, we need a 3, we've got a 4, 5, 6, 7, and then we need an 8 and a 9. And this is not a 1 or a 9, it's 3 or an 8. This is not a 3 at the very least. 1, 8, 9. Annoyingly, I think this can still be lots of things. Yeah, I got the 4-9 pair in box 2, but I don't blame you for thinking I wouldn't. Okay. This cell. This cell is interesting. So it could be a 1. It's not a 2 because it actually sees this 2-6 pair. It's not 3, 4, 5. It's not 6. It's not 7. It could be 8 or 9. So this cell's actually way more restricted than it looks. If this was land, actually the same would be true about this 2-6 pair. Would that break? No, I think this cell is actually way less restricted. Okay, let's see. So Tallcat is looking at what happens if this island continues. So what if it goes here? Can it stop? Well, it can't stop. It can't go here because it would make an island that's too big. So it would have to keep going. Is there something wrong with the island doing this and having size 8? The 4. The 4 in that instance becomes very problematic. Right. Okay. So I agree with Tallcat's point. So If this island grows down, it has to keep growing because actually 7 is cleverly excluded from appearing anywhere inside of it, and it can't connect over here because that would make it too big. So then this would grow down, but now this 4 is broken either way, because either this is water, in which case it's already at 6, or it's land, in which case we've done the thing we said we couldn't do before and have made worse. So this does not grow down. So this is water. So one of these cells is a 6. I don't know which one, but one of these two is a 6. Row 6 clue is done now. Ah, right. Thank you, Garion. Keeping me honest. Yes, so this comes over here, makes that a 1, makes this not a 1, that not a 1, that not a 1. Now if this was water, it would be too big, so it's land. Now this can't be land because it would separate the water, so it's water. This already sees 2 corners. Let's see. Okay, so let's understand Sayori's point. So row 7, column 9 is row 3, column 8. Ah, gotcha. Okay. And then the question is, where does it go in box 6? And the answer is it goes here. That's really clever, actually. Very good spot, Sayori. So, in other words, all 3 of these digits are 3. That is the point. Because this digit can't repeat on the island, so it has to go here, but then it can't be a 1. So these are all 3, which makes this C, makes this land. This has to be land to avoid a 2x2. This has to be land to avoid a 2x2. Okay, that 3, of course, makes this a 1 in lots of ways. Okay, now we've got some Sudokuing to do. So I'm told we can clean up column 5. So this is not a 3, which gives us an 8-9 pair, which makes that a 1 and that a 3. Oh, I did not draw in border here. Oh, I did not actually ever count the 4. Oh, right. This is separated. Okay, so yeah, we do actually have connectivity to finish the shading. Good catch to those of you who said it. Several people noticed that at the same time. I was looking forward to doing something more complicated than that to finish the shading, but no, the blue up here needed to connect, so that finishes the shading. These two things need to sum to 17, so they need to be an 8-9 pair just by this 26 clue. So 8-9 pair, it goes there. This 8-9 pair... Oh, no, sorry, I was going to say something that's not true. I'll try and stick to things that are true when possible. Let's see. This column needs a 3, though, and the 3 in this column is going to have to go here. I'm sure there's an easier way for me to see that, like placing 3 in this box, for example. So this is a 2, 8, or a 9, and it's not a 9. So this column needs... Oh, this column already has a 9. So this column already has a 9, so that's an 8, and that's a 9, and that's a 2, and that's a 9, and that's an 8 and a 2. Let's see. So this cell is 6, 7. It looks like. The bet cell is a 9. Congratulations if you bet 9. 5 and 8. These aren't 9. Oh, they're not 8 either. So that's a 1 and a 5. These cells are 2, 3, 4, 5, 6, 7, 8. 2, 6, 8. These two cells are a 2, 3, 4, 5, 6, 7. There are 4, 7, and we know the order. It's a 4, that's a 7. This isn't a 1 anymore. It's also not an 8. So therefore it is a 9. These two cells are a 1. We've got a 2, 3, 4, 5, 6, 7, 8, 9. So these are a 1, 6, and I know the order. It's a 6, that's a 1, which immediately tells me this is a 6, because remember, this island needs a 6. So that's a 2. Let's see. That was all I wanted to make sure I did, was not forget that I needed to put a 6 on this island. And I successfully didn't forget that, but I probably forgot every other thing. So let's see. These two cells, 2, 3, 4, 5, 6, 7, 8, 9, 2, 7, and we know the order. That's a 2, that's a 7. This can't be a 3 because there's a 3 on the island already, so this is a 4 or an 8. Let's see. This 9 looks up here. This 9 also looks up there, so that's a 4, 8 pair. That's the 9. 2 and 6 look down at this 8. So that's a 2 and a 6. The 8 is a 4 and an 8. And a 4 and an 8. And I think we did it. That's a really nice puzzle. I like that one a lot. Again, the time sort of flew by on that one. But my brain took forever, and I don't think it ever got there to be okay with these things touching in corners like this. Just because the version of this that I spent forever and ever and ever staring at, the whole rule was you couldn't have things touching at corners, and so my brain kept not doing good at visualizing what things touching at corners would look like. But the implementation was really nice, and the connectivity was a really nice extra piece. Like it showed up a lot in terms of figuring this all out. And I liked that there are some nice chunky regions in here too. Yeah, overall I had a lot of fun with that one. Alrighty, I'm going to take a quick break, and then we'll come back with a probably quicker puzzle. We'll see how it goes, but I'll reach for a quicker puzzle. And then I'll be right back. Alrighty, welcome back. So I realized we were very close to doing a Saturday stream without having a puzzle with Renbon in it, which just really feels like the sort of thing that we should avoid around here at zetamath Enterprises. So we're going to wrap up with this Renbon sandwich puzzle by Lisztes. So this is, yes, Lisztes puzzle 2 of the day. Today is Saturday. Sorry, Wednesday stream. Whatever day it is. Sorry, the long one. I forget. The Saturday stream is the short stream. Alrighty. But yes, excellent puzzle, KNT. I really enjoyed that. I was hoping the 2-6 pair I noticed would do more than it did, but very nifty puzzle. We just watched a solve of this, huh? All right, so what are the rules of this? So these are Renbon. So these cells contain a string of consecutive digits. So for example, they could be 3, 4, 5. They can't repeat, but they can go in any order. So 5, 3, 4, that would be fine. So that's that. And then sandwich we saw earlier. The sandwich clues on the outside of the grid tell you the sum of the digits between 1 and 9. So if I had a 1 here and a 9 here, I could have a 5, 7, 8 here. And then I could add those, and then Tallcat could tell me that that doesn't add up to 22, and then I could move the 9 here and put a 2 there. So this would be a valid way to fill the 22 sandwich clue. You have the crusts of 1 and 9, and then you look at the sweet, sweet filling. All right. So let's get started. 22 is one more than you can do in 3 cells. So if I did 6, 7, 8, that's the most I could do, and put bread here and here, I still could not get to 22. And what that means is this cell and this cell can never be crust, because if either of these cells was crust, then it would break the 22 clue, because I would be forced, whichever way I went, to do the 22 in 3 or less. So I'm going to mark these as green to indicate that we know these are not crust. Now, Sayori has a really smart point about the 9s here. Which is that we have to make 3 9s. And we can look and see one of those 9s could be between box 1 and box 2. Sorry, between box 4 and box 5. One of them could be between box 5 and box 6. But I can't actually repeat either of those combinations. If I try and do another one between box 4 and box 5, or another one between box 5 and box 6, that puts a third crust in box 5, so I can't do that. So actually, one of these 3, and this is actually true for any band like this in any sandwich Sudoku, one of these must breach the entirety of box 5. So one of these 9s is a 2, 3, 4. Tristan told me that he banned the mouth emoji so that this would not happen, but it seems the bot was smarter than the banning of the mouth emoji. So what that means is one of these, and it's not this one, is 2, 3, 4. So we either have 2, 3, 4 exactly here, or 2, 3, 4 exactly here. 2, 3, 4 exactly here might actually break. No, not quite, because I could put a 2 and a 3 here, a 4 here, and a 1 there. That would be okay. But I do know one of these is 2, 3, 4. And so I also know there's got to be a crust piece here, because one of these 9s has to be a 2-digit sum in this direction or that direction, and the other has to go in the other direction. So I guess maybe the question is, what if instead of being the 2, 3, 4, what if I tried to put a crust in this row? So I guess maybe my question really is, can this be a crust? I think so. Greens themselves in column 3 and 7. Sorry, SPQ. Because the 19 or the 1/9s are in boxes 4 and 6. Okay. Got it. Right. There's a 1/9 in one of these cells. So, because there's a 1/9 in one of these cells, there's no way that this is a 1 or a 9. And there's no way that this is a 1 or a 9, because then I'd have to make this thing in 2. So those are green. Again, I need at least 4 cells. So actually, even this won't work, because now I need a 1 or a 9 here or here, but a 1 or a 9 here is still too close. So actually, these also get greened. Very good, Sayori. And so similarly, I can green these. And so right. So actually, this is 22 and 4, although 22 and 4, I suspect, has a lot of flexibility to it. So this column, I notice that a lot of the options would involve putting 1 and 9 on Renbon. Let's see. And Carl says those can't be crusts. I'm making sure I understand why. Let's see. Why can this not be a crust? So if this were a... row 1, column 3, and row 1, column 9. Sorry. What happens in row 1? So, I mean, I obviously can't have both of these being crusts. Are you saying I can't simultaneously have them be crusts, or I can't have either of them be crusts? Well, yes, the 8 sandwich can't be 3 cells. Yes, I understand that. Yes, I understand that. But if one is a crust, they both have to be crusts. Why couldn't I put a 1 here and an 2 here and an 8 here and a 9 here? Like, I believe you. I just am not... I don't see why that's bad. Oh, darn it. Oh, I still haven't. Did I not turn off letters? Back. Okay. Earlier, when I turned off the letter tool, it actually did make my undo buttons work, but now my undo, now they work. What on earth? Who knows? Okay. So I'm still trying to understand what people are telling me about why, if this is a crust, it makes that be a crust. I would have thought it would be the opposite. If this was a crust, this would be the crust, and then these two would be the crust. That's the pattern I would have expected. Uh, oh, right, but that's not how it works. It's because of the 2, 3, 4 that I was just completely forgetting. Yes, right. So if this is a crust, then this is a crust. Can't be here because it's too small. Can't be here because it would be 35. So then it's here. But now once the crust is here, the 2, 3, 4 sits in here, and so that is a crust. But now the only place for this crust to find its friend is up here. Okay. So, agree. Okay, so these two are not crust because of that interaction down there. Got it. Okay. So now, if those two aren't crusts, now these two can't be crusts. And so now these all are crusts. And so this is 2, 3, 4. These are not 2, 3, 4. So this is 2, 3, 4. And so we can do our calculations on the 2, 3, 4 Renbon that we did before, because I thought this was not going to work, but it actually does work. But this is 2, 3, 5. Yes, I agree. But we have to be careful now. I can't make this 2, 4. So this can never be 3, because if these are 2, 4, then this would need to be 3. I'm going to green this stuff while I am thinking about it. Okay, but I think there's more forced here, because let's see. Let's actually write this out. So this is from 1, 2, 3, 4, 5. If this is 5, this could be 3, 4, and then this could be a 2. That's fine. If this is 4, that doesn't work. If this is 4, then this is a 2, and then this is 3, 4. That does not work. That's straight out. If this is a 3, then this is a 2, 4. That doesn't work. If this is a 2, then these are a 3, 4, and that doesn't work. So this is only 1 or 5. It sees a 2, 3, 4 triple. That would have been the smart way to see it. Yes, Logan. It sees the... it sees these. It sees all of them because it sees those two through the Renbon and that one through that. That's a smarter way to see that. Let's see. So these cells are from 2, 3, 4, 5, 6, just for the record. So the 1 in this box is definitely not on the Renbon. And the 4 in this box is definitely not on the Renbon. So the 1 and the 4 have to be off the Renbon. And so the Renbon definitely includes 7 and 8. Good point. These can't be 5 for whatever that's worth. But Garrett is completely right. These can't be 5 because 5 isn't adjacent to one of those things. These are green, by the way. Okay, so there is much focus on the 9 sandwich here. So if the 9 sandwich wanted to be a 3-cell sandwich, it would have to be 2, 3, 4. But I can't possibly do that because of the 2, 3, 4 triple that I have in box 5 already. So the 9 sandwich has to be 2 cells. So let's see. What happens if this is a 5? So if this is a 5, it makes this a 1, which would then require this to be... This would be the 9, and then this would be a 7, and this would be a 2. So if this is a 5, it has this giant cascade where this goes, this is a 5, so this is a 1. This can't be a 4 anymore, so it's a 2 and a 7 and a 9. It's very forced, but I don't know that it's broken if we do it that exact way. I do think I can green this cell. Because if this cell was crust, I would have to be making a 3-cell sandwich, and I can't possibly do that. Oh, good point. Good point. Okay, so Glum Hippo has a really good point, which is that actually this being 1 actually forces this to be 4. So actually this being 5 doesn't work. If this is 5, it makes this 1, makes this 4, but now I can't possibly make the 9 clue work. Okay, so that's not 5. Row 7, column 5 is also green. Yes, for similar reasons. So actually, that's going to place a 1, or not going to place a 1, but going to pencil mark a 1 here. Because this actually can't be part of a 2-cell... there's no way to make this part of a 2-cell sandwich. Lisztes sandwich puzzles tend to be quite intricate. We've somehow come to a world where I'd say Lisztes is not one of the scarier setters overall, but Lisztes sandwich puzzles specifically tend to require a great deal of precision. 5, 6, 7, 8. Over here, I'm just going to write for the record. Yes, I also remember us doing that one. Crust in row 8, column 5. Okay, so if this is 9, then that needs to be a crust as well, which would make this a 5 and this a 2. Okay, so we're looking ahead 9, 5, 2, 1 here. And now these 2 digits need to sum to 9. With this one unable to be less than 5, and this one unable to be less than 5 unless it's exactly a 4. So we'd again need the 4-5 combination. But I think we said we can't do that. Why did I say this had to be a 5, or did this have to be a 5? I don't know. Oh, because of the 1, right. Right. Okay, yes. Got there. Okay, so I said all the ingredients, but I lost track of putting together the important ones. So in the world where this is a 9, this is a 1. So that's a 5. So this is a 3, 4. But the point is, these two digits, this is at least 6, whereas this is at least 4, and that's too many. So we can green that cell. The Demano apparently solved Niplu Ultra as their first S cell puzzle, which is especially impressive, I think. Okay, so the claim is the same thing happens here. If this is a crust, then I would want this to be 5 and 4, but this can't be 5 and 4. Okay, yes, I agree. That's actually the much easier of them to see that breaks, I think. So now this has to be a crust, because if it's not a crust, then those are my crusts. So in fact, that's a crust and that's a crust. And so this is a 1, and this is a 4, and I think we get our digit dance. This is a 1 dance. 1 dance. 1 dance. Doop. Woo. 1 dance. Woo. Woo. See, the 1 dance involves jumping very high in the air because it's shaped like a 1. Very good, Zach. Thank you. The 5 dance is more horizontal, Tallcat. The 1 dance is very vertical. But also I have relatively low ceilings. It would look better in a more professional digit dancing environment. So this is probably a 5. If that's a 4, I'm going to suspect. Just hypothetically. That's fair. That's fair. The 8 clue. The 8 clue needs a 1, 9 in this box. That is a good point, Sayori. So if I did not put a 9 in either of these two cells, I'd have to make 8 in 2 or 8 in 5 or more, both of which are ridiculous, which means none of these are crust. Let's see. Sadly, for whatever reason, I have not been invited on RuPaul yet. I cannot imagine why, but let's see. Row 6, column 4. Right. This 9 requires to use a 1 in this box. So these two can't be the 1. Also, if these two were the 1, my sandwich would total to 0. And 0 is not the same as 9. And this clue is definitely 2 cells because these can be neither 2 nor 3 nor 4. So these are green as well. Likewise, this is 2 cells, so these are actually not 1 or 9 either. I believe I can green those as well. So I think that gives us all of that information. These are totaling to 13, which is a pretty middling total, I think. I'm a little worried about how quickly we're running out of clues to use in this puzzle. Okay, so the one... So it's a 6, 7, or 8 that goes with this 9. Oh, this is a 1-4 pair now. That's a good point. Okay. Oops. I was about to do something way worse. Okay, this is a 1-4 pair, so these aren't 4. So whichever of these is a 5, it goes with a 6. So one of these is for sure a 6. And then the other is a 2-3 pair. Okay, and these digits, we can just fill in, we might as well write them in, are 6, 7, 8, 9. Well, these aren't the 9. Oh, so one of these is the 9. That's the point. One of these is a 9, so there's not a 6 on the Renbon. So this is a 6. Boy, that's actually reminiscent of the Lisztes puzzle earlier, with the sort of magic of making the digits dance in exactly the right way. So we've got only a few digits left to hang out over there. Now, what I was about to look at before was that whichever digit goes here, whichever digit is part of the 9 sandwich, one of these is big, so one of these is small. And I was hoping that it would be a problem if this was small because of the Renbon, but I really don't think it is. I think, if anything, it's the opposite of a problem. Which is all very unfortunate. So let's see. If this is part of a 2-cell 8 thing, yeah, these are from... Yeah, that's what I was looking at when I was looking at this, was whichever of these is part of the 9 sandwich, is a 6, 7, or 8. So it has to go with a... Well, it's a 6. Whichever one is part of the 9 sandwich is a 6 or 7, and so it needs to go with a 2 or a 3. So one of these cells is a 2 or a 3, and then I was hoping that this being a 2 or a 3 would be a problem, but I don't think it is. Yeah, it can't be 8 because I can't do 8 plus 1. So yeah, it really is a 6 or a 7 going with a 2 or a 3. Yeah, there's obviously no 1 here, because they're already marked as not purple. I think there can be an 8 next to the 9. I don't think there's anything wrong with an 8 being next to the 9. The 8 just can't be next to the 9 in the direction of the clue. Carl confirms what I suspected, which is that there are a million ways to make 13 as the outies up here. The not a 1 next to the 9 was completely correct, and I was just not even paying attention to my own coloring to not notice that. The other has to be from 2 or 3. Sorry, I'm trying to parse this. Meanwhile, we're getting more porn bots. Okay, so there's only one way to make 13 without a 2, which is as 3, 4, 6. And every way of making 13 involves a 2 or a 3. So, got it. Okay. So, one of these two is a 2 or a 3, and one of these two is a 2 or a 3. So we have sort of between, and there's a 2 or a 3 up here and a 2 or a 3 up here. So we have sort of a weird virtual 2-3 pair that's making it so these cells can't be 2 or 3. So these cells are only from 1, 2, 3, 4, 5, 6, 7, 8. And these aren't 6. So these are only from 4, 7, 8. And one of these is 7, 8. So this makes a weird... Yeah, this is a 4, 7, 8, 9 quad. So these digits are 1, 2, 3, 5. 6, 7, 8, 9. Yeah, so these are from 1, 2, 3, 5. Why can't row 7, column 3, 7 be 5? Uh-oh. Row 7. Because I forgot that 5 exists. Oh, those couldn't be 5. This one could be 5. Darn it. Ruining the world. Now I don't get my nice little quadruple. Okay, but there's a 2 or a 3 here or here, and there's a 2 or a 3 here or here. Is there any useful connection? I mean, they can't both be in the same column. So there's that. What if the 9 sandwich in row 6 is a 2, 7? What happens with the 13 outies and the 2, 3, 6 below? Well, we already said the 2, 3, 6 below would be a 6. This is always, if this is the part that's a part of the sandwich, this is a 6. Unconditionally. Because I can't put 2 3s in here, because then I would break the 22 clue. So always, this is a 6. If this is 7, 2, this is a 6. So let's see. Am I supposed to scroll back and look at the list? Is there something insightful that I can gain by looking at the list of all of the ways to do this? I have maybe lost track of the list of all the ways to make this. All I remembered is that there's always a 2 or a 3. Ah, there we go. Okay. So it's never 2, 3, 8. It could be 2, 4, 7, 2, 5, 6, or 3, 4, 6. Let me write that down. We'll pull out the pad of paper from earlier. So 2, 3, 8, but we're never that. 2, 4, 7, 2, 5, 6, or 3, 4, 6. Okay. Okay. So if there's no 2, it's always 3, 4, 6. Right. So the one of these that goes with this is never a 2. Because if it was a 2, this would be a 6, and then this would be unfillable. Okay. So in other words, the one of these that's correct is itself a 6, going with a 3 in one of these two cells. And so the 3 up here goes with a 6 down below, making one of these 2, 4, 7. So one of these sides is 2, 4, 7. I don't know which one. Yeah, the paper came out earlier for Niverio's puzzle, which was a beast. And then it got to stay out. So 3, 6, 5. But I've kept scrolling back to where Carl told me what all the combinations were. Okay, so these aren't 6. That's one consequence of what I just said. Okay. Now, 2, 4, 7 are actually numbers that are kind of interesting in terms of the 8 clue. Because if a 2, 4, 7 wants to be part of the 8 sandwich, it needs to be a 2 with a 6. That's the only way it works. Because you can't do double 4, and you can't do 1, 7. So in whichever of these sides does have a 3, puts a 2, 4, 7 up in one of these places. And then if that's the side that does the 8 sandwich, then we have to go 2 and then 6. But I don't see a problem with any of that. Let's see. 2, 3, 6, 7, 8. I must be making it because there have been a lot of bots today. And I seem to recall that right before Ranks started making it, he got a lot of bots. So I can only assume that I will be doing my 10,000 subscriber celebration in the very near future. Uh, 3 in the sandwich in row 5. That's right, there is a sandwich in row 5. I just haven't even thought about this sandwich. Okay, so yeah, what is the sandwich? So what's going on in row 5 sandwich? That's the sandwich I've not been thinking about. Okay, so one of these is a 1. Going with a... Well, it can't be going with a 4, because that would require a 5. Can't be going with an 8. So... So Yeah, so if this is correct, then this would have to be a 6 or a 7. So one of these two cells is a 2 or a 3. Ah, is that the point? One of these two is a 3, and one of these two is a 2 or a 3. And they can't go the same direction, can they? No, they cannot both go the same direction. So that means because this Renbon always has either a 2 or a 3 or a 3 on it, its only candidates are from 2, 3, 4. Now this super can't, if I super can't do a 2 in this spot, I don't think. Because if I, well, not with a 7. Oh boy. So the 3 in this row, where's the 3 in row 5? The 3 in row 5 is definitely not part of... Wait, do I know the 3 is not part of the sandwich? Maybe I don't know the 3 is not part of the sandwich. Because maybe it could go 1, 6, 3, 9 in one direction, and then 6, 3, 9 in the other direction? Okay, so what happens with the 3 in row 6? So, okay, so if this sandwich, let's just imagine this sandwich goes, let's imagine this sandwich goes left. So if it goes like that, what's going on here? Well, then, first of all, this sandwich has to go right. This is not a 4 anymore. So this is a 2 or a 3. This is a 7, sorry, a 6 or a 7. But this is a 3 because the point is this, in this scenario, this is a 3 and a 6. And so the only way I get a 3 in this universe is if this is a 3 and a 6. And so this is a 2 or a 4. But I don't see what's wrong. Now the outies are broken. What outies? Oh, let's see. Because we've used a 2 or a 4. Oh, we've used a 2 or a 3 here. I'm confused. So I'm looking over my list to try and remember what the combinations I'm supposed to be looking at are. So here, this is a... So this would have to be a 4. And so I do 6 with 4. So 6 and 8 is 14, and 4 and 3 is 21. Okay, so the point is this this does not work, although I have absolutely no idea how a human was supposed to see this. Let's see, how far back? Let's... there we go. That's where you do this. Oh, no, sorry. I have to go further back. There we go. So I think it has something to do with the fact that this is a 6. Yeah, so I think the thing you're supposed to see is that this can't be a 6. I'm trying to make sure I understand why this can't be a 6. So if this is a 6, my outies have to be either... If this is a 6, my outies have to be... Oh, right, that's the point. If this is a 6, my outies are 2, 4, 7. And the thing about 2, 4, 7 is it involves a 2 and a 4. That's the whole point. So if I don't use a 6... if I use a 6 here, for the outies, I only have one option, because I'm always using a 2 or a 3 down here. And so as soon as I do that, as soon as I make this a 6, I then make this a 2, 4, 7, but now that's made this a 6 and this a 3. And now with the 6 and the 3, this is now a 2, and that doesn't work. Okay. I won't claim to like it, but I will accept it. This is not a 6. So you're saying just sum the digits in the... okay. I see the... I see now how people are doing... I was thinking, like, wait, am I just doing the same math over and over again? I see now how people are doing this. So the point is, the way people are doing this is, now that this is a 2, 3, 4, just max out this. So this is an 8 and a 7 at maximum. That's 15. With a 4 and a 3, that's 22. So the only way that this actually works is to maximize it. So 7, 8, 4, 3. Oh, wait. Sorry, that was not using this being a 6. The 7, 4, 6. Right. But neither of these but if this was a 6, then the maximum breaks, because then I get too low. Okay. Yes. Okay. Right. Okay. So that's not a 6. Which does something. Maybe, possibly. I don't think we know the sandwich has to be a 6, do we? I don't think we know anything about this sandwich. So why couldn't it be 7, 2? Oh, I know why it can't be 7, 2 now. Okay, so if the sandwich goes this way, okay. If the sandwich goes this way, we did do this before, but it's just long enough ago I forgot. If this was a 7, 2 sandwich, now this is forced to be a 3, but now the 3 in this row is part of this sandwich. So this sandwich doesn't go this way. This sandwich goes this way, I think is the point of all of this. So that's a 1 with a 9, and a 1 and a 9, and a 1 and a 9. Some various greening. And so that's a 1 and is purple. So that's the 6. That's a 6 and a 3. So that is not a 6. This is not a 4 or 6. Sorry, this is a 6 and a 3 because of the 3 getting placed there into that sandwich. These aren't 6. This is a 2 or a 4. Let's see. This is not a 1. Okay, this is green. Okay, these need a 2 because every 14 or every 13 and 3 requires a 2 or a 3, some such nonsense. This needs a 2 is the point. So because this needs a 2, this is now a 6, which means this is a 5, which means this isn't a 5, and this isn't a 6. So 2 or a 3 without a 6, 2 or a 3 without a 6. Okay, so if I don't use a 6, and I can't use both a 2 and a 3, these are 2, 4, 7. 2, 4, 7. So that makes this a 3, and this a 2, and this a 3. So this is also 2, 4, 7 because it also doesn't have a 6 or a 3. So it is also 2, 4, 7. How unexpected. So that's not 7, that's not 7, it's not 4, that's not 4 or 7, it's 5 or 8. Actually, that's an 8, and that's a 5, so that's an 8. And that's a 7 and an 8. This is the other thing. It's not a 3, despite the pencil mark. This is a 5. This is a 2, 4. These aren't 8 anymore. This is 5, 6, or 7, so it's a 7. So these aren't 7. 2 and 4 over here. This is a 5. Okay, yeah. I know that the 8 clue has to be 2 plus 6 because it's not 4 plus 4 and it's not 7 plus 1. So that means this isn't a 2 or a 3. It's a 7 or an 8. So this is the 2 for the column because we've got a 7, 8 pair now. So these aren't 2. Let's see. This 2 looks up here and says that's a 3 and that's a 2. This 1 looks down here and says that's a 4 and that's a 1. So we can we can purple that and green that. Let's see. The 8 in box 8 is done by this 8. This is an 8. So that's a 7. These aren't 7 anymore. They are a 2, 4 pair. Okay, so the is a 9, this would be a 1. If this was a 9, this would be a 1. 7, 9 pair is resolved. Ah, yes, it is resolved. Okay, excellent. So this is a 9 and this is a 7. Thank you, Ken. Purple and green. So now this is just not crust. So this is crust, which means this is crust. And so we can fill in lots of stuff. So first of all, we can green. We can green down here. Can green that cell since it sees a 1 and a 9. Okay. This is a 9 and a 1 and a 2 and a 6 by our previously stated thing. So that's a 4 and a 7 and a 2. That's a 4 and a 7. Let's see. So these digits are 2, 3, 4, 5, 6, 7, 8. 3, 4, 8. These aren't 4, so that is 4. This is a 5 or a 3. Don't know which yet, I don't think. These are, let's see, we've got a 1, we've got a 2, we need a 3, we've got a 4, we need a 5, we've got a 6, 7, and we need an 8. These are 3, 5, 8. These digits are 2, 3, 4, 5, and 6 again. So let's see. One can be placed, right? One can be placed here. Oh, by the way, this is green. That's the point. The whole reason this is on a Renbon is so I know it's not a 1, so that I can place the 1 there. So that now, now this is now green. So now this is a 1. So this is now green. Still have a little bit of ambiguity on the 9s, but I think we have all the 1s. Oh, no, we don't have any ambiguity because this is now a 9. Good spot to Sayori there. It's green. Oh, we still have an X-Wing on 9s. Okay, we still have this unfinished ambiguous pattern, but we can fill in these digits. 3, 4, 5, 6, 7, 8. This is not a 3. It's a 5 or an 8, I guess. These aren't 6. Oh, we have 6s placed down here, actually. So let's fill in these digits. 2, 3, 4, 5, 6, 7. Let's see. These are not... That's not 7 or 5. It's only 2 or 4. These aren't 4. Could be 2, 5, or 7. Oh, but there's a 2, 4 pair in this column now, so this isn't a 2. It's a 5 or a 7. Okay, so these aren't 6. I guess they're super have not been 6 for a while. These two cells are 2, 3, 4. Yeah, these are 2, 3, 4. Did that give me a triple? Not quite. I have a lot of near triples. Harder to work with near triples than actual triples. 5 in row 1, I'm being asked about. 5 in row 1. Very good spot, Carl. 5 in row 1 is up here, which fixes that's a 3 and an 8 and a 3. That 3 turns this, so that 3 removes those 3s. Makes an honest 2, 4 pair out of these things. So that's a 3. Down there. 6-9 pair is what's left over in box 1, says Demano. That sounds plausible. Looks right to me. So let's see. And we've got this 2-4 pair in this column. Means that's not a 4. Let's see. 2, 4, 5. The digits don't look right in this row. Oh, the 6-9 pair here gives me the 5. There we go. Gives me the 5 and the 6. Gives me the 8. Gives me the 3 and the 5. There we go. The 8 gives me a 7 and an 8. The 5 gives me a 7. These aren't 7. That one's not 8 either, so it's a 4. So that's a 2 and a 4 and a 2 and a 5. So these two digits are a 9 and a 2, I believe, right? Yep, and so that's a 4. So that's not a 4. Or an 8. Or sorry, 4 or a 7, so it's an 8, and that's a 7. That 8 is going to look up and do the 5 and the 8, which is going to look down and do the 6 and the 5, which is then going to finally finish that these are purple and these are green. Let's see, 9 and 6, and 2 and 9. Oh, I'm not done. And 2 and 4. There we go. Amazingly intricate puzzle. That was maybe a bit too technical for my my tastes. I might have liked another clue, but I really respect the setting on this, because this is it's a really amazingly intricate machine here that sort of pieces all of these things together. And the way that the 22 clues were so heavily used in terms of like knowing what these outies were and the way it all worked out and the way everything fit together. And I think my favorite part was the fact that 247 only had one digit that worked in an 8 sandwich, and that somehow ended up being a really crucial ingredient in all of these pieces being put together. Like, I feel like this puzzle was a lot of collecting separate pieces that eventually sort of in a grand finale all got put together. And I really respect that kind of puzzle in terms, just as an artistic accomplishment. All right. Well, I should say thank you to everyone for hanging out today. I hope you enjoyed the puzzles. If you missed any of today, there were a lot of great puzzles that we did today. So you can go back and watch the VOD. So particularly if you missed Niverio's dynamic construction, the finale of his dynamic trio, I really recommend you go back and watch that. I think that was a lot of fun. I also announced the setting challenge today. So if you missed me announcing the setting challenge and you'd like to participate, you've got plenty of time. But you can go back and look at that. Thank you to everyone who's been watching. Thank you to all my supporters, people who subscribe, people who watch, people who like the video. Not too late to like the video if you have not yet. But we've got all of our people on Patreon, as well as YouTube members. Both of those are available to you if you want to join. You can get benefits like you can vote on the puzzles. We always do the puzzle that is most voted on by those people who are on the Patreon or the YouTube members who get voting privileges. So if you want to hop on there and start voting, you can. So far, it's taken 4 votes to be the most voted on puzzle. So if you want to, you can sway the vote with only a little bit. Well, see, I have to put Orb 2 in the bucket before people can vote for Orb 2, you see, Demano. And so that is a problem because I can confide in you that Orb 2 is not in the bucket for people to vote on. Now, if you go up to the next level, then you can suggest puzzles, although it might still be hard to convince me to accept a suggestion of Orb 2. At 10,000 subscribers, we'll say at 10,000 subscribers, maybe I'll do Orb 2. We can do that. Hey, I did Niplu Ultra. We can at least do that, although I think Orb 2 is a whole level of insanity beyond Niplu Ultra. But also thanks for all the super chats today. We got a bunch of cool super chats from people. Thank you always to David Ratner, who always is a big patron of the stream. Had a lot of fun. I hope to see you all around. Well, I saw a bunch of new faces today too, so very exciting to see some new folks. Hope to see you around again. Go ahead and throw a subscription if you haven't. I'll put up the thank you screen to thank everyone who supports the channel. Thank you all for coming, and I'll see you on Saturday. It's actually Saturday. Oh, and super chat from Logan Wall. Thank you, Logan, who says yeet. Thank you very much appreciated. See you all very soon. Bye-bye for now.